What is Spring Boot? Spring Boot is a Java-based framework for developing and building software applications. So Spring Boot is used for building back-end applications, for building microservices, for building RESTful API, for building standalone applications, for building enterprise-level application, for building cloud-native application, batch processing apps, heavy data apps, real-time application, and etc. So now why should we learn Spring Boot and what are the advantages of learning Spring Boot? In addition to the fact that Spring Boot is easy to learn, it has rapid development, it's the go-to, framework for building microservices. It has its own server. You don't have to, install anything. When you package it, it runs on its own server. It has auto configuration. It has its own starter dependency and all of these. In addition to all of these, one of the advantage or the one other advantages to learn Spring Boot is the fact that when you have the knowledge of Spring Boot, there are jobs out there that need Spring Boot developers. There are a lot of jobs out there that require a Java-based Spring Boot developer. So I've worked as a Java engineer for a long time, and I still get referrals today for Spring Boot, Java engineers. So there are a lot of jobs out there who requires a Spring Boot developer. In addition to that, it's also very easy. You are going to see that as we move along the course. Spring Boot has been one of the easy framework I've come across. As long as you understand the basics and you have a knowledge of Java, it's very easy and it's production ready. It's already built to be production ready. So we're going to look at all of these as we proceed in the course. So what's the difference between Spring and Spring Boot? So we might have come across this term where we talk about Spring and Spring Boot. So what are the difference between these two? So it's very simple. Spring, it's like the engine of a car, while Spring Boot is the car. So Spring Boot is the full framework, while Spring is the engine that powers the Spring Boot. So let's get to see that, right here as an example design. So you can see right here we have an entire car, which you can call the Spring Boot. So it contains the car engine, the tires, the wheel, the steering, the seat, and every other component of a car. So this entire car is referred to as Spring Boot. So Spring Boot contains everything you need to build an application. While the car engine, which is an aspect of the car, which is what powers the car, can be referred to as the spring. So the spring is a dependency or the engine of Spring Boot. So that can be seen right here in the design. So you have the Spring Boot right here. It has the spring, it has the Tomcat server, it has the security dependency, you have the Lombok library and every other kind of library right there. Then when the spring is set aside as a standalone, it required every other component right here for it to function properly. So Spring Boot is the framework, while Spring is the engine that powers the entire framework. Okay, let's look at the layers of a Spring Boot application, or we can say the architectural design of a Spring Boot. So right here we have the client. Before then, the Spring Boot basically have three layers. We have the controller, which we call the API layer. We have the service layer where we write our business logic. And then we have the repository layer, which is where we make connections to our database. So the three layers in Spring Boot are the controller, the service layer, and then the repository. Then we have our front end, which can be your React application, your Angular app, or your Vue, or it can be your browser or your mobile app. So the client interacts with our backend application through the API layer or the controller. So whenever you build your application using Spring Boot, the controller is where we expose our API, which the front end or the client can interact with. So data flows from the controller down to the service layer to the repository, and then it then flows back, and the response is returned back to the controller, which will then be returned back to the client. So let's get to see a more detailed view over the data flow. So right here we can see this is the Springboot project. It can be any enterprise project. It can be a banking system. It can be any backend application. So right here we have the client, which is your front end. It can be your browser, your mobile app. So when the client make a request, let's say a user wants to log in, and the user passes his first name, his password, and click on login. When he does that, when he click on that button, a request is made to our Springboot application, which is captured by the controller layer. So the controller layer intercepts the request from your client, which then passes it to the service layer. The service layer is where you have your business logic. From there, the business is processed, or the request is processed, then the logic are implemented, and from there it interacts with the repository layer, where it accesses the database to be sure that user exists. If the user is existing, it gets the data of the user, passes the data back to the service layer, and the service layer passes the data back to the controller, and then it then returns the data back to the client, and then the user is either logged in successfully or not. So again, let's get a more broader view. This is the client right here. Request comes in, which is intercepted by the controller. The controller passes the request to the service layer, which then passes it to the repository. Repository gets the data from our DB, take it back to the service layer. The service layer runs the business logic by processing that data, take it back to the controller, and then the data is then sent back to the client. So this is how data flows in a Springboot application, and this is the general architectural layer in a Springboot application. So as we go in depth into the course, we are going to understand all of these fully. So now let's head on to create a simple Springboot project. So before we do that, you need to have Java installed. So for us to check that, go to your terminal or your command prompt or your git bash or your shell and type in Java space dash version, click enter, and that's going to show the version you have installed on your laptop. So if peradventure you are getting command not found or version not found, then come to your browser right here, just type in Java version, or let's say Java downloads, so to say, then click on the first link, which is the oracle.com, and you're going to see Java downloads right here. Make sure you are right there, and we can see the latest JDK is 25. So select your operating system. If you're on a Windows, click on that. If you're on a Mac or Linux, so select your operating system, click on this to download right here, and then that is going to download the Java development kit, which is called Java JDK. So when you install that, the Java runtime environment is also going to be installed along with you. So if you're unable to get that, just say Java JRE download, something like that, and yeah, and it's going to, okay, this is Java JDK. So install the JDK, and it's going to also install your runtime environment for you. So JDK is called Java Development Kit. It basically contains all the tools and classes needed for you to be able to write and build a Java-based application. So have that installed. So after you've done that, let's now head on to create our Springboot project. Now, to create your Springboot project, we are going to be using the Spring Initializer. So come right here on your browser, type start.spring.io, start.spring.io, type this on your browser, hit enter. Then it's going to take you to the Spring Initializer right here, and we are going to be using this to create our Springboot project. So in the language section, select Java right here. We want to make use of Java. In your project, we want to be using Maven, so select Maven. That's going to be used to manage our project and our dependency. So make sure you click Java, Maven, and for your Spring Boot version right here, select the latest stable version, which is version 4 right here. So at the time of me recording, this is version 4. So at your time, it probably can be, a more higher version. So select a stable version right here, the one without, these brackets right here. So these snapshots are just for testing purpose. So this is a stable one right here without the, bracket like so. Now for your project metadata, so the group can be anything you want it to be. The artifact, I'm just going to call this simple API. It can be anything. The name, you can pass your name to it. You can pass in your description. Then the package name is going to be your group dot your artifact or your project name, like so. So that's going to be your group dot your artifact like that. That is going to be your package name right there. Then for our packaging, we are going to be using the jar. The jar is a modern way of packaging a Java application. So select jar right there. Then for your configuration, I'm going to be sticking with the properties. The properties is more a modern way of configuring our, properties like so. So select that. Then for my Java version, when I check my version right here, you can see I was using version 25. You can select whatever version you are using, or if you are using a more lesser version, you can also click on 25. And then in your project configuration, I'm going to show you how to configure that to make use of that. But select the version you have, or if you don't have a recent one, just click on 25 right there, and I'm going to show you how to do that when the project is being created. Now, towards the right, we are going to add our dependency right here. For right now, if I click on generate, this is just a bare bone thing. There's no dependency, so we need to add our dependency. So if I go back right here to when I was explaining this, we can see a Spring Boot has different dependency like the Spring, which is the root. You can have the server, you can have security and all of that. So now let's add some dependency right here. So because I want this to be very simple, I'm just going to be using one dependency right there. So click on add dependency right here. When you do that, you can see a bunch of dependencies that you can add to build whatever kind of project you want to build. You can see there are a lot of dependencies right there, kind of much and much. So I'm just going to be sticking with just one so we can get to understand the basics. Then moving on, we can head on to add multiple dependencies, as we learn along. So I'm going to be making use of the Spring Web, so which I'm going to scroll down right here, and we can see the web right here, and there's a Spring Web right there. So I'm going to be adding this. Now, if we look at the description of this, it can say build web, including RESTful applications using Spring MVC, using Apache Tomcat as a default embedded container. So when I add this dependency, I'm going to have access to the Spring framework, which you can see right here using the Spring MVC framework. I'm also going to have access to the Apache Tomcat server, which is going to be our runtime environment. So when I click on that, you can see that has been added at our dependency. So you can add multiple dependencies that you want. You can decide to say, I want to add, let's say, if you are using a database, you can decide to add MySQL, or if you are using a Postgres, you can say PostgreSDB and etc. So for me, I just want to stick with this so we can understand the basic of Spring Boot. So just stick with this one dependency right here. Click on generate. When you click on generate, it's going to download a zip folder for us, and that's going to be in your downloads. So come right there to your downloads, and we can see this is the project right here, which it was downloaded. Double click to extract it right there, or right click on it and click on extract depending on your operating system. So extract that, and that's going to open the folder right here. Now if I click on the folder, we can see we have some files right there, and I'm going to head on to open this up in my IntelliJ. So if you don't have IntelliJ, come right here and search for IntelliJ IDE download like that, and it's going to take you to JetBrains where you can download IntelliJ. Just click on that, and it's going to say download this. So this is the professional version, so you can download that right there. So click on the link right there to download, and we're going to see you the next lecture. Okay, let's open this project up in our IntelliJ IDE. So if you do not have IntelliJ installed, so come right here to your browser and type, just search for IntelliJ IDE, download, then click on the first one, which is JetBrains, click on that. And then you are going to come right here, you're going to see, select your operating system right here, and then click on the download right there. So this is going to help to download a professional version for you. So after you've downloaded that, then open when it's downloaded, double click on it to install it on your operating system, and after it's been installed, it's going to open up. So for me, I already have it downloaded, and I'm just going to open it up right there. So I'm going to type IntelliJ IDE right there, and this is going to open up like so. So if you are, if you are new, it's going to be like this, but if you've already had some projects already, you are going to be seeing some like projects listed up right there. So if that is you, just click at the top and go to open. But if you are downloading for the first time, you're going to see something like this. Make sure just click on open right here, because we want to open an already built project. So click on open like so, and it's going to take you to your system, navigate to where your project is, where it was extracted to, which is this right here within my download. So I'm just going to click on that, click on open, and it's going to open up right here. Okay, so this is it. I'm just going to double click on this so it can cover my, my view. And right here you can see it's trying to configure Kotlin settings right there, which I'm trying to see why it's trying to do that. Let me see. Okay, let's just ignore that. It's going to try to build the project right there. So now before we do anything, let's try to take a look at what each of these files mean right here. So if you take a look at your left, you can see under the project right here, you can see there are different kind of file structures right there. So let's get a look at each of them, and then I can then teach you how to configure if you are using a different version installed on your operating system. So now let's get a look at each of these files right there. So at the top right here, you can see a folder called .idea. So this folder, it's basically generated by your own IntelliJ IDE or whatever IDE you are using. It contains settings specific for your code editor. So this is going to be generated by your code editor that contains settings, which you can see right here, specific for your own code editor like that. So moving down, we can see we have another folder called .mvn. So this folder right here, if I click on it, you can see there's a wrapper right there. There's a Marvin wrapper.properties. So this folder contains the wrapper which is used to execute your Maven script. So we're going to be looking at all of these. So just know that this contains a Maven wrapper which is used to execute a Maven script. So where are the Maven script coming from? The Maven script is going to be coming from this mvnw right here. So we're going to see what this does. So that's what these are. You don't really have business with either of these files right here. They're auto-configured, so leave them as they are. Now moving down, we have the SROC right here. I'm going to jump this, and I'm going to come back to our SROC folder. So 99% of our work is going to be within this SROC folder. So we're going to be spending almost 100% of our time working with this SROC folder. So let me jump this, and I'm going to come back. Now moving down, we have the .git attributes right here. So this was auto-generated. It's used to define the attribute for some specific file that is being tracked by Git. So that's what this does. Again, we have no business with this. Now moving down is the .git ignore right here. This contains files and folders that we do not want Git to track. So we don't want Git to track this file if we are pushing our code to a remote repository. This, whatever we define right here, will be ignored or will not be tracked. So now moving down, we have our help.md. This basically just contains a documentation, for our project. If you have a specific thing you want to write down right here for, let's say, for people to get to know so they can know how your project works. Those can be penned down in the help.md. Now moving down, we have the MVNW. So the MVNW, is the Maven wrapper, which contains the command that it's be executed by this Maven wrapper right here. So the MVNW, they are basic commands. The MVNW is specific for the Mac. I'm just trying to look for a better way to say this. So these are commands that are specific for the Mac and the Linux, while the MVNW.cmd is specific for the Windows operating system. So again, we don't really have business with these right there. These are auto-managed, and they are also managed by Maven. So we don't have business with these files right there. Then again, another important file right here is the pom.sml right here. So this is a very, very important file, and this contains the information of our project. It contains our project version, our dependency, it contains our plugin, it contains our Gradle property, our Maven property, whatever. It contains all the basic information we need to manage our project. So this is where you register your dependency. If you have plugins, these are where you configure them. Now, if we look at it right here, it's an XML file, which you can see right here. It's a basic XML file, and it contains the project name, as we can see right here, the group ID, the description. Remember when we are having this description right there, which we can see the description right here, demo project for Springboot, which is again the description right here, right, as we can see them right here. So okay, now we can see our name right here, simple API, which was this name right here. Okay, now this contains information for our project. You can see it has our properties right here. Our Java version right here is there, and here it contains our dependencies. We can see we are using the Spring Web Starter, which is this one right here, the Spring Web, which you can see right here. And we are also having these tests for that Spring Web right here. So again, this is our plugin, the Maven plugin, which is what we are using, and others. So when we add, if there are dependency we want to use on our project, those will be registered right here within the dependency section. So this is what the pom.sml does, is where we register our dependency. If we have new things to add, new library to use, we basically come here and register them. So this is more like the, let's say, the JSON, how will I going to call it? It's more like the package.json of a Node.js application, something like that, right? Okay, now moving down, we can see we have the external libraries right here. So this basically contains the codes, or it contains the libraries for our application. As we can see right here, we have the OpenJDK library right here. So we're going to be making use of the classes from this library right here. If I move down, we can see we have the Maven right here, the logins, different kind of packages and libraries. So this is where the code resides, and this is where we will be importing those code from. So as we move along, we're going to be seeing them, and I'm going to be showing all of them to you. So these are the file structure. And if I come right here to the SROC right here, we can see we have the test right here. This is where we write our test case. We can write our unit test, our integration test, those test application. This is where we write those code. Then our main right here is where we write our main code right there, where we write our logic, all the codes we need. Now in the Java right here, we can see we have the simple application right here, and right here it's been annotated with our Springboot right here. We have the plus version, the plus right here. Let me move this a bit to the left, so you can see we have this plus, green plus right here, and we can see the green plus also at the top. And right here we can see you have the main right here. So this right here is the entry point for application. So if I remove this, by saying a Springboot application, this is an annotation which is saying, hey, this is the entry point for the application. This is where the application is run. So if you want to run this application, I will come right here and click on run right here, and it's going to build my application, and it's going to run my application. So this is where we run our application. When we execute the command, Marvin run, all of that is going to come right here and run our application. And this is our main file, which means that this is the entry point for our Java application. It's okay. So right now, if I pull this up, we can see our application is being run. It has started, and at the left right here, we can see we had a new folder added called target. So these are basically the build file, contains the code of the build file and all the classes that were built and bundled. We can see them right here. So to stop this, at the top right here, you're going to see this green button right here to stop, or this red button, so to say, to stop, or the green button to restart. So when I click on this red button at the top, it's going to stop my application. And below here, we can see it's, it has been stopped right there, and I can just do this to bring that down. Now moving down, we can see the resource file right here. This is where we have our static resources. Let's say you have your images or your static videos, you want to use them within the application. Those will be stored in the static folder right here. Then we also have our template. Let's say you want to, have your HTML template, your custom HTML template. You want to have some HTML things within your application. Those codes will be there, will stay right here within the template. Then right here we have the application.properties right here. It is the configuration where your application is configured. Here you can define the port of your application. You can, this is where you connect your application to your database. You can define the port. You can have some other configurations. Some properties files will be stayed right here, will be placed right here. So that is the use of the application.properties. So these are the files in a Spring Boot application, and these are what they do. So as we move along, we're going to be looking at them more, and we're going to understand them more and more. Now let's get to see how to use a different version of Java on your project. So let's say, for example, I'm having a different version installed on my operating system. Let's say Java, let's say 8 or Java 11. And in my project right here, if I go to my POM, you can see I selected Java 25 right here. So how can we do this? So it's very simple. What you have to do is to come to the top right here where you have settings icon right here. Click on this big settings icon, and you're going to go to project structure like so. And then right here, you're going to see your name, your SDK. Click on your SDK right there. If you cannot see 25 right there, click on download JDK right there. Or you can click on add JDK from this if you already have it somewhere installed. If you don't, then just click on download JDK, and it's going to try to download that like so. Okay, I already have it, so I don't really need to do that. And that's going to be it. Again, if you have Mondo 1, you can right click on it and then select whatever you want to use right there. So I'm just going to, I think this has hung because I am trying to cancel this up. Okay, so let me see if there's a way I can just close this up and do that again. Okay, that's been done. Now if I click on it, you can see I have more than one JDK. I have version 21, I have 25, I can add more like that. Okay, alternatively, if you are unable to access your project structure from here, you can come to the top right here where you have help right here. Click on the help right here, then search for project. Where is it? Project structure like so. Click on that, and that's going to open your project structure right there. The same way, come to your SDK, just you can say, I don't know, let me just come down, click on download JDK like so if it's not already there, and that's going to be packaged specific for that project, and that's how that is done. Okay, so now let's head on to, let me run application once again, and let's look at the logs and explain them one after the other. Now to run your application, you know what to do. Go to the root of your app, that is within your SROC, the main right here. You have the Java, open it up. You're going to see your project right here, and you're going to see the main right here. So click on this green button to run it. Alternatively, at the top right here, you're going to see a green plus button right here to play. Another one is going to be like a bug. So this one is to debug and this is to run. So click on this to run. And when your project is running, you are going to see a green red right here to stop, and then this is going to change to rerun. Now when your project is running, you're going to come below right here. You're going to see that some logs have been popped up. So let me pull this up again. You're going to see some things popped up right here. If you have errors trying to run your application, those are going to be right here in your terminal, something like that. It's going to pop up below right here, okay? Now, if I move right here, you can see this is basically big Spring right here, just like a design stuff. And right here, it's, using my JDK25 right there. And here, the Springboot version is 4.0.2, which we can see correctly. And moving down, we can see these are the logs, and this is the timing for each of them. You can see this is 2026 February, and these are the time in which the logs are being registered. And it's giving a unique info to it, as we can see. And moving up to the right, we can see the test of the logs being printed at. So here we can see application successfully started. It's using Java 25, and then it assigned a unique PID of 4053 to it. And moving down, we can see this is where the target class is situated, which is right here. Now moving to the other one, we can see another log say no active port set, which means that we didn't specify a port. So because of that, the Tomcat is using the port 8080. Again, we're going to show you how to change this port right there. Then we can see that a Tomcat server was initialized, which means that that's one advantage of using Spring Boot. It comes with its own default server. So you don't have to worry about your server. You don't have to worry about anything. All you just have to do, just click on this play button and your application is going to be run correctly. So when you want to deploy, you don't need to worry about the server. Also, bundle your application into a jar with a simple one line of command. Deploy that jar in whatever server you want to put it on, and it's going to run correctly. We're going to be seeing all of these right here in this course. So right here, we can see our port is 8080. Our server has started, which is Tomcat, and we can see it's Apache Tomcat. This is the version. And we can see the root of the application was completed in these milliseconds. And Tomcat is running on port 8080. Application has successfully started, which we can see right here. And it took like 2 seconds, 2.6 seconds for our app to start. So these are the logs right here. And this is how logs are printed. So if you have errors on your code, it's going to show you right here. And with this, we can easily track them. So these are the logs, that is being printed right here. If I want to stop my app, come right here, click on this red big button, and we can see commencing graceful shutdown and graceful shutdown completed, which means our app has been shut down. So that is it. If I want to bring this down, you can click on this right here to hide, or you can just click on this to remove it. So this is it for this, and I'm going to show you how to change our port. So to do that, come to your resource right here, go to the application.property right here. I'm just going to say server.port equal to, I want to give it a different port. Let me just call it 80, let's say 8090. Click on run right here, and let's just wait and see. We can see port is now on 8090. If I want to say port, let's say 3021, I click on this to rerun. And we can see port is now 3021 right here. If I can, right here, right? So, okay, see it also right here, right? So this is how to change our port. Let me just stick with, let's just say 80, let me say 80, let's say 8085 or something like that. Click on that to rerun. And now port is running on 8085 like so. So this is how to change our port. That is being done in your application.property by saying server.port, and then you are going to see your port. Again, if you want to connect to our database, this is also where everything is being done. As we move into the course, we are going to get hold of all of these. Now, let's continue to build a simple contact API. So it's an API where you can add a contact, get all the contact, edit a contact, and delete a contact. So by building this project, we are going to get to see how Springboot works and get to understand the basic of Springboot. So this is going to follow architectural design of data flow, which is from your controller to your service and then to repository, and we're going to be having these different layers right there. So I'm going to head on down to my project, and in this project we will not be connecting to our database. We just want to do something very simple. I'm going to first of all come right here to structure my application into the different layers. So right now I'm going to come right here within my Java here and create a new package. I'm going to call this controller. Let's have our major layers set up right there. It's going to be the controller, and it's going to contain our controller implementation, and then this is going to be our controller layer. So again, let me have my service layer. This is going to be the service layer, and it's going to contain our business logic. And then lastly, I'm going to have my repository like so. This is going to contain our repository implementation. Again, if we come back to our design, we have the controller layer, the service layer, and the repository layer. So this is the major structure of Springboot. So when you go and when you visit Springboot project, you're going to be seeing these layers right there. Also, there are you can create other folders to help simplify your implementation by coming up with the model. So I'm going to come right here, create a new package, call it model. This is going to contain our entity or our model, and then I also want to have my DTO, which I'm just going to call the package DTO, and this is going to contain our DTO classes. So DTO means data transfer object. So it's a class that will help you to return data, more like an API response, like so. Okay. So now the first thing we have to do is to create our model right here, which is a contact, and I'm going to do that. So in a very large application where we start to work with database, we start using other library like the JPA, we have something called entity, and those are going to be done right here within the model. But let's keep things simple. Let's just come up with a simple class called contact right there, which is going to be used to, collect, and save contacts, more like an object. So come to the model right here, create a new Java class, call it contact. This is going to be acting as our model for now. And right here, that's a class, and it's going to have the feeds, which is going to be the ID. A contact is going to have the ID, then it's going to have a name, and then it's going to have the phone number, which is going to be called phone number, like so. And because we are using Java, we need to create the getter and setter for each of these. So before I do that, let me just create an empty constructor by saying public contact, like so, and then just have an empty constructor. And moving down, I'm going to have my getter and setter by saying get ID, like so, then set ID, get name, set name, get phone number, and set phone number. You right? Okay. Now, by now, I'm writing my getter and setter manually. In future projects, we're going to be using Lombok to auto-generate this right here. So we won't have to be having to write this on our own. But for the sake of, for beginners, so we can get to learn and see how things are done, that is why I'm writing the getter and setter up like so. Okay. So this is going to act as our model, which is going to be help us to, save our contact, to collect the contact object, etc. So the next lecture, we are going to have our API response DTO, which is just a simple record that will help us to return the response back to the user. So we'll head on to have our DTO, which is our data transfer object. So I'm going to come to my DTO folder right here, right click on it, create a new Java class, and this time around I'm just going to make it a record, and that's going to be, name is going to be called API response, like so, and that's going to be a record. And right here I'm going to make this an API response of type generic, which is making it a T, like so, and this is going to have status code, and it's going to have the message, and then I'm going to have my data like so, like that, and this is going to be, this should be within the constructor right here because it's a record, like that. And this should be a comma, and this should be a comma, like so, right? Yeah, like that. Okay. So let me just try to format this. So if you want to format, if you're on a MacBook, write Command Option L to format. If you click on that and you see format code, you can see right there, the shortcut is up right there. Okay. Now for those who are using Java 11 below, you will not have access to this record right here because it's a new feature which was introduced in Java 14 upwards. So if you are using Java 8 or Java 11, that is JDK 8 or JDK 11, you have to like use a class by coming to do something like this, by saying class, and that's going to be called the API response class of type T, and this is going to be something like this, and then you have all your feeds. That's going to be your integer, status code, then you have your message, and then you have your data, and then you come up with the getter for each of them, like so, and then yeah, just stuff like this, and you can have your constructor by saying public API response, and that's going to be your status code, your message, your data, something like this, right? Yeah, something like this. So if you do something like this, it's also okay. Then you can also have for the data, let's say get data like that. Yeah, so if you can use something like this, it's also very perfectly okay. But the reason why I'm using a record, it's more of a cleaner code syntax, because what records does is records is a more modern way for us to write DTOs whose major job is just to return the data. Why did I do everything? Why did I everything? So the job of a record is just to collect an information and send it without modifying the information. So if you're not having plans to modify your information, it's just for you to, it's just to, it's an immutable way for you to, handle data, right? So by using record, you don't need to write, getter and setter. You don't need to write your equals to hash code. You don't need all of this. So this is just for you to collect data and then return it like so, without having to. So when all the feeds right here are final, and so it's just stuff like that, right? Okay, now because this is our API response, I'm just going to do something right here by saying add JSON include. I'm going to say JSON include, which is going to be .include .not null. So right, what does this mean right here? So what does this JSON annotation include .not null mean? So what this means is that if you're using this record or this class to return a response, and there are fields right here that are empty, is going to ignore those fields. So that's what this is doing. If I'm using this to return a response and there are fields that are empty, those fields without data will be ignored. So that is what this is doing right here, right? So if I'm using this to return data back to the client and there are fields that are null, those fields will not be returned along, those fields will be excluded. That's what this is right here. Okay, now this is our DTO. So whatever a request comes in and it's being processed and I'm returning a response, this class will be used, or this record will be used to return a response for every record. So that is a more better way to structure your application, to have a particular class or a record that is used to return a response for every single API request. So this is our API response right here, and what we did in last lecture was our model, all our contact right here. So we're going to proceed in the next lecture. So now we are going to have our repository. So again, data flows from the controller to the service to the repository, then back to the service to the controller, and then to the user. Now, for those who are wondering, why do I have to write my repository first? Why don't you start by writing your controller? Remember, the controller depends on the service layer. The service layer depends on the repository. So if I have to come up with my controller layer, I need to have my service layer up before I write my controller, and I need to have my repository up before I come up with my service layer. So this depends on this. So the service layer, the controller needs the service layer to function. The service layer needs the repository layer to function. So it's more appropriate for me to start with my repository layer, because the repository layer most likely do not need much except my model and my response class. So let's start with the repository layer. So again, the repository layer, it's where we have it's where connects our application to our database. So let's keep that up. I'm going to come to my repository right here and create a class, or you can make it an interface. For me, let me just make this a class, and I'm just going to call that contact repository, like that. And this is I'm going to annotate it with at repository. When you see this repository right here, which is coming from the Spring Framework stereotype repository, this tells Spring Boot that, hey, this class or interface should be treated as a repository. That means that this is where we have our connection to our database. This is expected to talk to our database, and this is where data is coming from. So that is basically very simple. So when you see the repository annotation in a Spring Boot application, it's basically telling you that, hey, this is the database layer, right? Okay. Now let me come up with my stuff. So because we are not connected to an actual database, I'm just going to come up with an in-memory storage, just an array of data which can be used to store data temporarily when the application is run. And let's just do that, right? So I'm just going to come right here and say private is going to be a final, and I'm just going to call this a list of contacts, like so. Our contact should be coming from our model right here. And then I'm just going to call this contact list, and this is going to be a new array, a new empty array, like so. So this is going to be used to store our contacts, right? So again, I'm going to have to increment the ID, like so, by saying ID. I'm just going to call this ID counter, and by default, I'm just going to give it a 1 like that, okay? So I'm going to move down to have a method to help get all our contacts. So it's going to be a public method. It's going to return a list of contacts, and that's going to be called find all. And again, this is going to return a new array list, and that's going to be of our contact list. So this is going to return all the data in this contact list right there. That is basically all our contacts. So let's have a method to find by a particular contact. So that's going to be an optional of contact right here. Remember, this contact is from our model right here, and then I'm going to call this find by ID, and I'm going to pass in the ID right there like so, and then I'm just going to return the data by saying contact list, get hold of all the contact list, say dot stream right there. That's going to get hold of everything. Then filter like so each of them, and then I'm just going to call say contacts by say contacts right contact dot get ID if it's equal to the ID. So this is going to, then I'm just going to say dot find first like so. So this is going to get the contact which is going to loop over all the contact lists and get hold of each of the ID and return a particular contact whose ID is the same as the ID that is being passed in. So if there's no ID passed in, it's going to return an optional right there. So an optional basically means it's a null data, something like that, right? Yeah, more like an empty kind of data, okay? Now that this will be used to get a particular contact by ID, let's also have a method to save and then to update a data. So again, this is going to be a public, then it's going to return a contact right there, and then I'm just going to call this save, and then I'm going to pass in the contact to be saved right there, call it contact, and have my implementation. First of all, this method will be used to save and update a contact. So if I'm passing in an ID, that means I want to update a contact. If I'm not passing in an ID, that means I want to save a new contact. So I'm going to first of all have that logic by saying if contact right there, which is this contact that I want to save, if it has ID, if there's ID, if the ID is null, right, or if the ID is smaller or equals to 0, which means that there is no ID, or the ID is not greater than 0, then I'm just going to add a new contact right there by saying contact.setID, which is going to be contact ID counter like that. Then I'm going to increment it by making it plus plus, and then I'm going to say contact list dot add, and then I'm going to add the contact right there. Okay, so this is going to be used to add a new contact. So S, if peradventure a contact ID exists, I'm just going to update the contact by first of all deleting it by saying I'm just going to have a method down say delete by ID. Let me quickly have that right there by coming right here and say public void delete by ID like so. I'm going to pass in an integer called ID, and then I'm just going to say contact list dot remove. I'm going to use the word I'm going to use remove. Where is it? Remove if the contact is the same as the ID that is being passed in. So this is going to be used to delete a contact or remove a contact from the array list right here. Okay, so I'm going to come right here. If the contact if the contact have an ID, that means I want to update it. I'm going to come right here and say delete by ID contact dot get ID like so, and after that I'm going to say contact list dot add, which is going to be the contact right there, and after everything is done, I'm going to return the contact right there that was either saved right here or edited right here. Okay, so that is it. So this is our repository layer. So when you see the @repository annotation right there, this basically tells you that, hey, this is the repository and this is where our application interacts with the database. Now let's move on to have our service layer. So again, if we can recall vividly, we say Spring Boot have majorly 3 layers. Data move from the repository to the service layer to the controller, which then feeds it to the client right here. So right now we've already done the controller layer. We've already written the repository layer, so to say. The repository layer is where we connect to our database, and it's the layer that helps us get data. So right now with this, we can get all the contacts, we can find the contact by ID. So this is going to return this data right here to the service layer. So now let's head on to have the service layer. So within the service package right here, I'm going to right click on that and create a new Java class. I'm just going to call it contact service. Let's keep it simple like this, and it's a class like so. And the first thing we need to do is to annotate this by say at service like so. This is coming from the org spring framework.stereotype. So by having this annotation right here, it's going to tell Spring Boot that this should be treated as the service layer. Okay, this is where our business logic will be, and etc. Okay, so now I'm going to do that. So the next thing for us to look at is what we call the auto dependency injection. Remember, as we rightly said, that the service layer depends on the repository layer where it can interact to get data. So because the service layer depends on the repository layer, we need to find a way to inject the repository layer into the service layer so the service layer can easily get access to the data from the repository layer. So that's what we call dependency injection. So it's a desired pattern where a class requires dependency from another class. So this is the service layer. It requires the method from the repository layer. So we need to look for a way to inject the repository layer into the service class. So that's what dependencies injection is all about. So for us to do that, there are basically different ways for us to do that. So the first thing is called constructor dependency injection, by coming right here to create a constructor of this class right here, which is the contact service. So create a constructor like this, and within the constructor right here, I'm going to bring in the repository class by saying contact repository, call it contact repository right here. I'm just going to, before I do that, I'm going to come right here and say private final, and that's going to be the contact repository like so. And then right here, I'm going to say this dot contact repository, which is this right here, equal to the contact repository which we are injecting in the constructor right here. So this is one way for us to bring in the contact repository into our service class right here. So another easier way for us to do that is by using the auto wire. So I'm just going to come right here and say auto wire right here, and then I'm just going to say private, then contacts repository, contact repository. So by doing this only, it's going to bring in or inject the contact repository into this service class, and with this we can have access to the method of the contact repository. So this is, you can see right here with Spring Boot, things are very easy. By using annotations, you can easily get what you want to do easily. So let's now have the method to get all our contacts. So I'm just going to come right here and say public. This time around, we want to return an API response by saying API response, and that's going to be of type list of contacts. So again, I'm going to explain all of these. So let's just follow along, and then I'm just going to call this get all contacts like so. And here I'm going to first of all get all the contacts and save them in a variable called list of contacts like that. I'm just going to call that contacts or contact list, and here I'm going to say repository, which is now the contact repository dot find all like so. And by saying contact repository dot, I'm going to have access to all the methods right here of the contact repository, and now I can have access to the find all right here, which we can see. and I'm getting all the data which is being stored right here. So now after I've done that, I can then say return, let me say return new API response, and this is going to be the status code. I'm just going to pass it 200. Then the message, I'm just going to say, let's just say we can say all contact found or something like that. All contacts retrieved, and then I'm going to pass in the data, which is the contact list, like that. So this, I'm returning the API response right here, and then this then will be returned to the controller, which will be calling this service class. So we're going to see that shortly. So let's also quickly move down to have the method to add a contact. So I'm just going to come right here and say public, and that's going to return an API response, and that's going to be of type contact, and I'm going to call that add contact, like that. Add contact, and this is going to take in the contact object which I want to add, and here I'm going to first of all save the contact like so. Let me just call this saved contact, and this is going to be contact repository dot save, and then I'm going to pass in the contact I want to save, and then when I've saved that, I can return, let me push this up a bit, I can return the API response, and that's going to be status code 200. I'm just going to say the message should be, let's say, contact saved, and then I can pass in the saved contact right there. Okay, now let's have the method to let's say to delete a contact or something like that, and then I'm going to come right here again, public is going to return an API response of type, I can say type any, like that. By using a wildcard, I'm going to call this delete contacts, and for us to delete a contact, we need to pass in the contact ID we want to delete. So these are basic CRUD operations where we can get, we can edit, we can add, we can delete. Now to delete a contact, I'm first of all going to check if the contact exists by saying if contact repository dot find by ID. Do we have find by ID method right there? Let me see. Let me just check if I have any method called find by ID right there. So I'm just going to go to the contact repository and check if I have find by ID. I have find all, find, okay, I have find by ID. Let me see, which is, yeah, I have find by ID, okay. So I'm just going to say if dot find by ID, okay, I'm going to pass in the ID like so. So if the ID exists right there, I'm just going to say dot is present to be sure the ID exists. I'm going to say if is present like so, which means that the ID is present. What do I want to do? I want to delete it by saying contact repository dot delete by ID, which is the contact ID like so. And then when that is successful, I'm going to return an API response. This time around, I'm going to use a 204. So 204 is an API code where you don't need to return a content. It basically tells your application that, hey, the request was successful and I don't need to return a data back. So that's what 204 is. It's basically used for a delete request. Okay, now I'm just going to pass in a message and say contact deleted successfully, and then for the data I'm just going to pass in a null right there, which means that I'm not expecting to pass in anything. So this will be used to delete a contact. Let's also have to update a contact. Okay, so we can see we're having an error right here. So if peradventure, we're not able to find a contact, let me just return something right here, return new API response, and this time around is going to be a 404, which means the contact not found. If we're not able to get a contact by ID, that means the contact is not there. I'm going to come right here and say contact not found, something like that. and then just passing a null right there, okay? And that's going to return that. A 404 is an error message when a resource is not found. It's a status code, an API status code when we have a problem finding a resource right there, okay? So now let's head on to how to update a contact. So again, I'm going to come right here to say public. It's going to return an API response, and this is going to be of type contact. So I'm expecting to return a contact within the API data right here. So, and I'm going to call this update contact like that, and this is going to take in the contact ID I want to update. This is going to help us to figure that contact out, and then the contact data that we want to update. Let me just call this update data, or let's say data contact to update contact to, you know what, let me just call this updated data, something like that. All right, okay? So here the first thing for me to do is to find that contact. So I'm just going to wrap everything within, just going to wrap everything by saying return first of all repository, which is going to be a contact repository dot, first of all, let's find by ID to make sure the ID exists. So if the ID is there, then I'm going to map right there, and then I'm going to call this existing, let me just say dot map, and then I'm going to say existing. This is going to get the contact right there, which we found by ID. I'm going to call that existing contact, or let's just say existing. So right here, I'm going to say, wrap everything within a code. I'm going to say the existing contacts. Let me just say existing contact. Let's be descriptive so we can have, let me just call it existing contact right there. Is going to be, I'm going to change the name to be the updated contacts dot get name, and then I'm going to say existing contact dot set phone number. That's going to be the updated contact dot get phone number. You may want to have your different logic to say if the name exists, set it right there. If the phone number exists, set that. So that is a more logical thing for you to do. You can decide to do that if you want to do that, but the main aim for us is to explain so you can get to see how Springboot works. So we don't want to spend much time in writing logic. We just want to make it very simple. So now we've done that, I'm just going to say contact repository dot save, which is then the existing contacts, and then I'm going to return, this should be broken down right here, and then I'm going to return my API response. That should be new API response, and that's going to be a 200 for a successful update. And then you can say the message should be contact updated successfully, and then you can decide to pass in the updated contact, which is the existing contact, like that, okay? Or then after that, you can decide to say dot or else if, you can say or else if, let me say or else, like that, if we're unable to find the contact by ID, what do we want to do? We just want to return a new API response of status 404, and then the message will be, let's say contact not found, and then the data can be null like so, right? So this is it, and that's it. So also, if you can notice right here in the add contact, when you are making when you're adding the data to the database, the status code can either be a 200 or a 201. So let's make it a 201 to just keep things more sync. When you're adding a contact, when you're adding the data to a database, the API response should be a 201. When you're updating, it should be a 200 for a successful update. Okay, so this is it for our contact service, or what we can call it the service layer. And in the next lecture, we're going to have our controller layer, and then we're going to go over everything again to see the proper data flow. So let's head on to have our controller layer, which we call the API layer. So again, if I go back to the Springboot design, we can see we are done with the repository layer, we are done with the service layer, and now we are on the controller layer or the API layer. So the API layer is where we expose our endpoint, which can be called by either your mobile app, your web app, or any other external app like so. So let's come up with our controller layer. I'm going to come right here, and in my controller package, I'm going to click on that, create a new class, call it contact controller. You can call it anything. You can call it anything, does not really mean naming convention is not that important in Java, but we most likely use a controller just to let other developers know that this is a controller class. So right here, the first thing you need to do is to annotate, is to let the Spring Boot know what kind of controller you want to create. So we want to create a RESTful controller, or want to expose a RESTful endpoint. So you do that by saying at REST controller right here, and this is going to tell this class that, hey, this is a RESTful controller, this is our API, this is our endpoint, and whatever method we are going to be having here should be RESTful, right? So after this, you can, if you want to have custom paths, you can decide to do that by saying, annotate it with at request. That should be capital arrow. You can say at requests mapping like this. If you want to have your custom paths, you can say I want the path to be /API/contact. You can probably say / let's say other stuff, let's say v1 / if you just want to do other path like that, these are being specified right here in your request mapping. Okay, so now what we want to do is to bring in our service class so we can have access to the method of the service class. So to do that, I'm going to use my AutoWire again. We already saw how that is done. Say AutoWire and just have your class right there. Say private. The class name is a contact service, and you can just give it a name called contact service. So by doing this is going to help us to AutoWire or to bring in our contact service right here. So this is what we call dependency injection. We are bringing this class right here into the controller so we can have access to the method of this class. So this is dependency injection, and this is how it's done. So the other ways you can do that by, again, you can create a constructor of your controller like this, and then as usual, then just bring in your controller service like that, and then right here you can make this final. Let me comment this out, and then you can say this dot controller service equals to the controller service. So you can do something like this also. Yeah, that's also fine. So let's stick with this other one so you guys can get to see how this is done. Okay, now this is it. So the next thing we have to do is to have our get mapping. So to do that is to have our get request or our get API. So that is very simple. You simply just say at get mapping. So this basically is going to say, hey, this is a get request. So when you make a get request and it follows the path right here, which is going to be / let me just say greet, or I don't know, it can be anything, then call whatever method I'm going to be having right here. So that's going to be a public. I'm expecting this to return a string. You can return anything you don't want to. I'm just going to call this hello. Like so, I'm just going to return a simple thing. Let me just say hello world, something like that. Let me wrap this within a string. Hello world. And then I'm just going to say this is a contact API. Just something a little bit fun. So I can just probably just do stuff like this, right? Okay. So now let me start my service right here and let's test this out so we can see. Again, let me run my service and let's see if it's going to run properly. We can see service have started in this, like you can see, and the port is on 8085. So for us to have access to this, we're going to make a GET request to using port 8085 using this path right here, and it's going to return this. So let's do that. So I'm going to go to my browser right here, and it's going to be localhost. That was localhost 8085, which is 8085. Then you are going to go make a GET request. By default, when you access URL on your browser, you are making a GET request by default. Then I'm going to go to the path which is /API, which I can do and say /API / then the contact, which is this contact right here, /API /contact, then that should be /greet, like so. Greet, let's just see what's going to happen. You can see hello world, this is a contact API. We can see it's going on right here. Okay, now when you have your request parameter, you can remove the last slash right here after the contact. It does not really mean I've removed that. Let me start it again and let's test this again to be sure. Okay, so that started again, and the path is localhost 8 port 8085, which we can see. Then /API /contact /greet is a GET request. Fire it down, we can see this is it. Okay, now you can decide to, if you decide not to pass in this right, let me get rid of this. If I leave it at get mapping only without passing a path and I restart it, then how am I going to access this right here? It's going to be very simple. Let's do that. If I try to hit this right here, you can see white flag error. This means that that page is not found. So for me to access this right here is going to be /API /contact without passing a path right here. So that's going to by default pick this get mapping. Okay, so I'm going to remove these greets like so and do /API /contacts. Again, we can save this right here. So what if I don't want to specify a path right here? Let me get rid of this right here. Get rid of that, rerun my app, and let's see how I can access this right here. So by doing this, that means that by default, we're not going to be passing this /API /contact anymore. By just going to your 80 localhost 8080 / is going to by default pick the is going to take the GET request and return this right here. Okay, so you can see that's what we are seeing right here, right? Okay, so now let's take it back. Let's pass in our parts right here, passing these other parts. These are just for us to differentiate different endpoints or different API from each other. Okay, and this has been done. Let me restart again. And then let's do that again. If I come like this, we can see this part does not exist. We're expecting to pass in the appropriate part, which is /API /contact /greet, and now we can have our response from our API. Again, we can see right here, this is working correctly. So let's head on to have other endpoints laid out. So let's have let me bring this down a bit. Let me stop this right here and just put this away. So let's have our GET request to get all our contacts. Now we can then have access to this contact service right here. So again, I'm going to have another GET mapping right here. This time around, I'm not going to put in any path, and it's going to be a public. And this time around, I want to wrap my response with a response entity. So it's most appropriate in Springboot for us to wrap our API response with a response entity. So I'm going to say response entity. You can see it's coming from the Spring Framework HTTP. So all HTTP requests or HTTP response in the controller should be wrapped with a response entity. So, and this is going to be an entity of type. What do we want to do? Remember, if I go to my service right here, we can see each of these methods is returning an API response data type. So that's going to be a response entity of type API response. And because I'm going to get all contacts, this is going to be a response type of list of contacts. As we can see right here as the return type right here. Okay. Now, then what do I want to call this? I can give any name. Let me call this get all contacts. And then I'm going to return a response entity. Then you can say dot OK. This means that if this is a successful, then return it. And then I'm just going to say contact service dot a method get all contacts. Okay. Now if I click on the response entity right here, you can see this is where it's coming from the Spring Framework HTTP. You can see it contains the status code, the objects, all kind of stuff like that can help you to manage your response properly. You can decide to specify a different status code right there. You can, so it's more appropriate to wrap your API response using the response entity, which is what we are doing right here. Now, this has been done. Let me run this again. Let's try to get all contacts. So now our app is running. Let's get what should be the route for this GET request. Remember, for this other one, when you go to your localhost, your URL/API/contact/greet, is going to return this right here. So what about this? What should be the path? It's going to be API/contact. We're not putting any other slash right here because it does not have a specific path. So when you make a GET request, by default, it's going to read this and come right here and then make use of this. So let's just do that. That's going to be, if I do this, it's going to get me this. If I get rid of the greet and just go /API/contact, it's going to scan over here and pick the first GET mapping, which is this. So, and then when I hit that, you can see status code or contact retrieved. There are no data right here because I do not have any contacts on my application. So it's just giving me the status code, telling me the contact has been received, but in the data, there are actually no contact because I have not added the contact, right? So now let's do another thing. What if I have another get mapping right here? I just call it, let me just say status check, and then I just let me just return this and say, let me just say string. I just want us to try something else to get to see how this will behave. I'm just going to say return response entity.ok and say hey. Okay, so I'm just going to start my app again. Now we have to get mapping, to get request without a specific path. So if what's good? You can see right here we're having an error. So I just wanted us to see that, which is telling us that error with this, request mapping handler. You can see it's telling us that, hey, you cannot do this because this path already been mapped, right? So you cannot, have two get mapping of the same path together. So you need to specify a path for it. So if I come right here and call this, let me just say /hey, and I run that right here, the error will be gone. So you can see right here, the error is gone because these two no longer have the same path, right? So this is basically what I just wanted us to show. Now if I come right here and say /a contact /hey, and we can see it has been done. So that is the power of Spring Boot. When you have conflicting API, it's going to throw you an error during runtimes, okay? So let me just get rid of this and then we are going to continue. So let me continue with the create API. So that's going to be the post mapping that will be done in the next lecture. So let me stop this right here and let's look at the post request. So to do that, it's very simple. Use your annotation again, annotate, just say post mapping, and this is going to create a post request for you. You can specify a path if you want to do by coming right here and say / let me see, you can say create or something like that. You can just do stuff like that. Then come right here and have your response, have your method, which is going to be response entity of API response of type contacts. I'm just going to call this create contacts. Then right here, we are going to pass in, remember, let's go back to our service class. Whenever you want to create a contact, which is called to add a contact, right? You need to pass in the contact object which you want to add. So that is going to be passed in within the body of this post request by using what we called the request body. So that's an annotation by saying at request body, like so, and then use this contact model to collect it, call it contact, and then return your response entity of the result, and that's going to be the contact service dot, there's a method called add contact, pass in your body, and that's all you need to do. Okay, so this is the post mapping. So let's test this out. Now if I come to my browser and let's say slash create something like this, if I click enter, okay, let me run my application. Let's see what's going to happen. I'm not expected to be able to do this because the browser I cannot make a post request on the browser. So let's just try it. So come right here. This is going to be slash create. We can see it was trying to make a get request to this endpoint right here, but because it's a post request, we're unable to do that. So because we cannot use the bare browser to make a post request on the go, we need to have a different software which you can use to make post requests and to test other APIs. So there's a popular tool called Postman, which I basically use, called Postman, like so. So it's free to use. You can click on that and use that to test your API, test your different requests right there. So yep, so I already have it downloaded. If you don't have it downloaded, come right here, postman.com, sign up right here or sign in, then you can download the application for your MacBook. So I have it downloaded already. I'm just going to open it up like so. So that's been opened up. So if you just downloaded it for the first time, it's going to be something like this. You're not going to be expected to see anything. It's going to be like this. You'll be asked to, let's say you can create a collection, you can create an endpoint, or you can import something. So let's just do something very simple by clicking on new. I just want to create a HTTP request right here. Just click on that. And right here, I can pass in my URL right here. For this case, this is going to be local hosts. The port is 8085, if I can recall vividly, 8085 right here. And then the part, let's just start with it. Let's test with a get request. If I go to slash API slash contact slash greet, and it's a get request right here, and I send, you can see I'm getting this hello world stuff right here. So if I try to get all contacts by removing the greet right here and sending, you can see all contact retrieved. Now, if I want to add a contact, that's going to be a post request. So I'm going to come right here at the top, turn it to a post right here. This means that, hey, we are now making a post request. And again, remember the path, which is, let me bring this down a bit. The path is slash API slash contact slash create. So make sure you pass that down, slash create, and then to add a contact as a body, come right here. You can see the body right here. Click on the body right here. Make sure you're on raw right here. Then at the far right here, make sure you're on JSON right here. And then come right here, put in your JSON right there by putting stuff like this, your parentheses or your code block. And then the fields we need are the name and the phone number. So again, if I go to the contact controller, this is the request body right here. The body we need for the contact is the name and the phone number. Okay, so let's do that. I'm going to come here and pass in a name like this, and then the value can be, let's say, Dennis, and put in a comma and put your double quotation for the phone number, which is going to be phone number, phone number, and that's going to be putting your column, and then passing your phone number like that. It can be anything, not really important. Make sure the name value right here, which is the key, corresponds to the name right here. Make sure the spelling are correct, and the phone number spelling right here is the same with the key phone number right here. Make sure the spellings are the same. By doing this, when you click on send, it's going to map this name right here in your JSON body to the name of the contact right here, which is going to be collected right here. It's going to be collected right here, and then the phone number right here, key, is going to map to the phone number value right here. So if there's a difference in the naming, it won't be able to map. It will be ignored or something like that. Okay. So now make sure these are correct, and when I click on send, we can see contact has been saved. And if I try to get a contact now, let me just create another new URL to get a contact. Localhost contacts is a get request. Now you can see my contact has been retrieved. Let me add another one. This is going to be Lucy, and she is an American +1. Let's just do something like this. Click on send. Contact saved. If I try to get a contact right here, we can see I have 2 contacts right now. Let me pull this up. You can see I have Dan right here and I have Lucy right here, giving ID 1 and ID 2. Now, if I stop my application, let me stop it, right? And I try to run again, and it's running. If I try to access the data or the contact, remember this data will be gone because I was only saving them. You can see the data are gone because I was only saving them temporarily in my memory. I was not storing them in an actual database. So, and whenever I restart my app, everything is expected to be gone, right? So just get to know that. So when we start working with database, then we can save data permanently. So now that is it for a post request. In the next lecture, we are going to look at the delete request. So let's have for our delete request. So to do that, again, just come right here, have your annotation called delete mapping, and you can specify a path and also a path variable. So let's just first of all have the method down, and then I'm going to explain that. So this is going to return the response entity of API response of anything, and this is going to be called delete like so. Let's just call the method delete, and again, I'm expecting this to take in an ID. Remember, we want to pass in the ID of the contact we want to delete, and this is going to return a response entity .ok of our contact service .delete contact, and we'll pass in the ID right here. Now, if I do something like this, and let me say I pass a path like so, let me just say path is delete. Let's say something like this. And so how do we pass in the ID down right here? So there's what we call a path variable. So let me just stop this right here, and let's just get everything complete. So that's going to be a way for us to pass in the ID by coming right here. And you can say when you go to /delete/ want to, passing a variable like this, passing your code block right here, and then you can call it an ID. And then right here, I'm going to say path variable, and this is going to hold whatever value is here is going to be the ID like that. So let me run this, and then let's test this out, and let's just see how it works. So now if I try to run this and I try to get contacts like this again, remember, because we are not storing to a database, we are not expecting to get anything. So let me quickly add some new contact like that, and this like so. So if I try to get a contact right now, we can see we have 2 contacts. So now let me create for the delete right here by going to the localhost /API/contact/delete. And then right here, this is going to be a delete request right here. Don't forget that. And then how am I going to pass in this ID right here? We can see the path is /delete, and we're basically saying that slash any other thing that is being passed here is going to be treated as a variable, which we can see while we're using the code block right here. So if I come right here to say slash, let's say 5, this 5 extra 5 after the delete will be treated as a variable, because we are basically saying that this is a code block right here. Now, because this name is ID is going to be collected, we are saying a path variable. This is going to get hold of whatever we pass in right here, and it's going to be the ID, and then it can be passed in through the method delete here. So let's test this out. If I click on send, we can see contact not found because contact with ID 5 is not found. So if I check up contact again, we have ID 1 and ID 2. So let me pass in ID 1 and send. We can see contact deleted successfully. If I try to access all contact again, we can see contact 1 has been removed. So let me remove this 2 by passing in ID 2 as the path variable at the top right here. Send. Contact deleted successfully. If I try to get on contact, we can see no data again, it's found. So this is the delete method, the delete mapping. This is how to pass in a variable in your params, in your URL. That's how to pass in a variable, which is basically called a path variable, right? Now to collect it, you use the annotation path variable. You specify the data type, and the name should be correspond with the variable name right here, okay? So that's going to collect that and then pass it down. So in the next lecture, we are going to be looking at the update method, the update API. So let me stop this right here. So let's have the update request. So I'm going to come right here and call this again for the update API. We're going to be using the put mapping. So come right here and say add put mapping like that, and then you can pass in your path and your path variable. You can basically say update, and then you can pass in a variable of the ID, which is going to help us determine which contact we want to update by putting your code block and then passing the ID variable name. So the name can be anything. So it can be, you can call it ID of contact or whatever name you want to give to it. Now right here, let's have our method right there. That's going to be a response entity of API response of type. You can just say type contact, and this is going to be called, let's call it update contact. And then I'm going to again come right here and then pass in my code block right here. So now right here within the update contact, we want to be able to get hold of the ID of the contact we want to update, and we also want to get hold of the contact body data, which we'll be updating right there. So again, remember to get your ID, you use the path variable. So let's do that by saying path variable, and that's going to be an integer ID, put in a comma, and then I want to pass in my request body by using @request body like that, and that's going to be a contact, and then that's going to be like the contact. So let me just make this a little bit big so we can see. So again, right here, I'm going to say, let's say the API response of type contact, and that's going to be, let's just call it the response, and that's going to be the contact service dot update contact. Remember, the update contact takes in the ID and the update data. So update contact, passing the ID and then the contact data. Let me just say the contact. Let me call this contact data right here to be clear like that. And then I can return response entity.ok of then the response from the update contact. So again, so this is done. This is going to be a put request, and we are passing the ID. We are extracting the ID from the path variable right here. That is using the path variable, and then we are also passing the data to be updated, and that's going to be collected using the request body like so. So this will be gotten and then passed down, and that will be updated. So let's get to see how this is done. So go to your Postman right here. Again, if I try to get our contacts, we are not expecting to get, okay, let me run my service right here first of all. My service is up and running, so let me come back to my test environment, send again, and now we have 0 contacts. So let me add a new contact, add this, let's say add Mary right here, and then let's add James, like so. If I try to get our contacts, we can see we have 3 contacts right here. So let me create a new API to update a contact. So that's going to be again localhost. Let me see, localhost API/contact/update. Is that what we called it? We say /update, then / the ID of the contact we want to update. So let me update contact 3, which we can see contact 3 is James. So let's update that. Now, again, because we want to update, so our method right here will no longer be get, it will now be a put right here, we can see. So for update, you can use a put or a patch. So let's make use of the put right here, because what we specify in our API is a put mapping right here, which you can see right here. It's a put mapping. So right here in our API, that's going to be a put right here. Again, we are passing the /3 right here, which will be captured as the path variable right here, the ID. And then we need to pass in our contact body by coming right here, click on the body right here, make sure you're on raw, right here should be JSON right here, and then pass in your JSON object, which is going to be the name. So I want the name to be from the previously was from James. Let me just call this Madison, and then his phone number should be like +88, something like that. So click on send. We can see contact updated successfully. So let me check again. Previously it was James, and now it's now Madison. So again, what if I try to remove the phone number? Let's try to do that and update the name only to, like, let's say Harry Ford. Let's see, send. You can see Harry Ford updated, the phone number is now null. If I try to get all data again, we can see Harry Ford, the phone number is null. Kind of crazy, but let's just keep it simple that way, and we can probably do a lot of validation for this, but I don't really want this to be complex. I just want this to be more easier for us to follow along. We just want to get an overview of what Springboot is, and then so we can understand how data flow from one point to the other. So this is the basic block of building any Springboot application. So I'm going to stop this right here, or I'm just going to, let me not stop it, let me bring it down. I'll just bring it down. So this is our application, and this is our API. And in the next lecture, I'm just going to go over everything one after the other again, so we can have a more broader view, and then we'll move on to our next project. So let's review everything we've learned so far. So what is Springboot? Springboot is a Java-based framework for building software application, for building backend applications, API, enterprise applications, heavy data application, etc. Now the major layers, or let us say the layers of Springboot are we have the controller layer, which is this right here. So data moves. We have the controller layer, the service layer, and then the repository. So all request comes in through the controller layer, which is the API layer, as we can see right here. So from the controller layer right here, the request comes in and it moves to the contact, to the service layer, which is this right here. So from the service layer, it moves to the repository layer, where the data are gotten. So from the repository layer, the data moves to the service layer right here, and then it's returned back to the controller layer. So these are the structure of Springboot is very easy and it's annotation based. So we have what we call a dependency injection, where you bring in different layers to different layers where they can be used. As we can bring in the right here, we can see in the service layer here we are bringing in the repository right here, and in the controller here we are bringing in the service right here. So by using basic annotations, right, you can see the to-wire annotations helps you to bring in other services or other layers. Now we can see there are other notations right here. By simply annotating this with REST controller, this automatically becomes an API, becomes a controller. We see the controller annotation, we see the service annotation, we see the repository annotation like that, and that's basically it's so very simple. So this is what we've learned so far, and with this knowledge should be able to build different forms of API. We should be able to add validations and do other stuff. So this is the basic of Spring Boot. So this is the overall basic, and that's it for this. In the next coming sections, we're going to be building more complex applications, and we're going to be learning more. Now, in the last section, we got to see what Spring Boot is. We got to see the uses of Spring Boot. We saw the difference between Spring and Spring Boot. We went over the Spring Boot architecture. We got to see the layers of the Spring Boot. We built a simple contact API. We got to understand the controller layer, which is the API layer. We got to see the service layer, which is where we write our business logic. And we got to see the repository layer, which is where we have access to our DB. And then we're able to come up with a contact API where we perform CRUD operations. So we understood how Spring Boot worked, we understood the basic, and that was what we learned in the previous section. Now, in this section, we're going to take things a little bit forward. We're going to take it more like a 3 to 4 step upward. We're going to be learning more things in Spring Boot. We're going to be looking at security, how to secure an application. We're going to be looking at authentication, authorization. We're going to be looking at role-based user. We're going to be looking at how to have users with different roles. We're going to be connecting to our database. We're going to be looking at the Java Persistence API, which is a way for us to create and manage our database tables. We're going to be looking at all of this. We're going to be looking at database table relationship, how one table can relate with another, and how to persist data. We are going to be connecting to a MySQL database, and we're also going to be connecting to a Postgres database. So if you're a MySQL user or a Postgres user, we're going to be working in hand to hand. So we are also going to be looking at validations, how to validate data. We'll be looking at cookies. In Spring Boot, we're going to be looking at section, how to handle and manage cookies and section. We're also going to be looking at more dependency, like the Lombok dependency, which help us to write getter and setter. We're going to be looking at other dependencies right there. So these are what we'll be covering in this section. So this is going to be a project-based course. As we are building our project, we're going to be explaining all of these from the ground up. Now, at the end of this course, we are going to build a simple task manager where a users can register in the application, and a user can either be an admin or a regular user. A user have his details right there, now an email. A user can add a task. A user can manage a task. A user can delete a task. A user can mark a task to be completed. And this also have a category. A task can either be your personal task or it can be your work task, like so. So we're going to be looking at database relationship. All of these are being packed in this course. So by the time we are done with this course, you should understand Spring security, how to manage sessions and cookies in Spring Boot. You're going to understand the role, authorization, authentication. validation, custom exception. So all of these we've taught and packed in this session. We're going to see you in the next lecture. Now let's look at what Spring Security is. So what exactly is Spring Security? So Spring Security is a powerful authentication authorization tool which is used in Java application, or you can say which is the standard for securing a Spring Boot application. So it is primarily designed to protect a Java or a Spring Boot application from a wide range of security threats like so. So one of the powerful reasons why Spring Boot or Java is primarily used for enterprise or banking applications or applications where security is of high concern is because of the power of Spring Security. So Spring Security has been built or designed to enforce a very powerful protection for our API. So let's get to see in a design right here on how the Spring Security function. Now this is a design I came up, so this is the entire Spring Boot right here, this big container right here, the entire Spring Boot, and you can see we have the controller right here, the service right here, the repository right here, and we have the Spring Security, which is very big right here. Now whenever a request is, this is a request or a client, it can be a mobile application, a web application, or any other API, accessing our applications, which is right here. Now, whenever any request is coming in right here, we can see the request passes through the Spring Security. So this security, it acts as a gate man or as a gatekeeper for our application. So any request coming into our application is first intercepted and processed by the Spring Security. So if the request is genuine or if it's threat-free, then that request is permitted to go to the controller. Then from there it moves to the service, to the repository, the data is getting back, and from the controller now it moves directly to the user or where the request was coming from. So it's more like a gatekeeper for our application. It filters all the requests coming in, is the first line of action, or what we call the frontliner, the first soldiers at the gate that scrutinize everybody which is trying to come into the house. So take Spring Security as your gatekeeper or the soldiers in the gate, so they validate everybody trying to come in. Let's say, for example, the White House. If you are trying to, if you go to the White House in Washington, D.C., and you want to go in, you are going to be intercepted by the security guard. So they're just going to make sure you have the permit to come into the White House. So stuff like that, right? So that's what Spring Security does, and we're going to be looking at it in depth in this course. So again, let's get overview of the project we want to do. I'm going to be explaining all of this by building the project. So again, it's a powerful task manager where users can register and log in. You can register either as a normal user or an admin. An admin have access to setting tools. A user have access to setting too. So when you register, you can update your profile account, you can create your task right there, you can create your specific task, you can view your task, you can add your task to a category, you can edit your task like that, you can delete your task, and stuff like that. So this is what we're going to be building, and this is going to be a secure application. So let's get into it. So first of all, I would like to create a repository for this, so I can easily share the link with you so you can have access to this. So I'm going to go to my GitHub account right here, go to the repository part, and I'm going to create a new repository for the entire tutorial, and that's going to be called Spring Boot. Let me just say Spring Boot course. something like that. I think this look a little bit good, okay? And then I'm just going to make this publicly visible and readme. Let's add that to it. Git ignore, that's going to be Java. Let me see, Spring Boot exists, does not. Let's pick it in Java. And license, let's leave it at, let me just say MIT, so others can get use of it, like so, okay? So that's it, or I can say Spring Boot tutorial to be more descriptive, something like this, okay? All right, so that is it. Let's leave it at course. It's just kind of, this is very weird, but let's leave it at course, like so. And yep, so let me create a repository like this, like so. And that has been created right here, so I'm just going to clone it like this, and I'm going to go to my terminal like that, and I'm going to cd, let me clear this up, I'm going to cd into these tools right here, and I'm going to make a directory, call it Spring Boot, let me see, bootcamp, like that, and cd, oh, file already exists, okay, let me cd into the Spring Boot bootcamp, sc, okay, that kind of like crazy stuff right there. Let me just go and get rid of them, which is here to Spring Boot, where is it, Spring Boot camp, like this, and just get rid of this stuff right here, okay. Now right here, I'm going to clone my project right there, and that's been cloned up, and I can then head on to create my Spring Boot app right there. So go to your start.spring.io right there, and we're going to create our Spring Boot app in the next lecture. So let's head on to create our project for the task app. So go to start.spring.io on your browser. Then right here again, the language should remain in Java. The project should be built using Maven. So select that. And the version should be the stable one as at this time, which is version 4. Then the name, you can call it anything. Let me just call it Task Manager. And you can probably just say the Task Manager app. Then the packaging should be in jar. Then the configuration, leave it at properties. Then your Java version, select the one you have installed. If you do not, then click on 25 right here. Now let's move on right here to add our dependency. So click on the add dependency right here. I will need to first of all add Spring, which is the backbone of Spring Boot. So come right here, type for web like so. Then add the Spring Web, which is the backbone for the Spring Boot. So click on add Spring Web right there. Click on add dependency again. Then we need to add the database dependency. As we rightly said, we want to be able to connect to our database. I'm going to be adding those dependencies. So for those who are MySQL users, search for MySQL right here. MySQL, so add your MySQL driver like this. Again, for those who are Postgres user, click on add dependency and type in Postgres. You can see PostgreSQL driver. So add that. We're also going to be making use of JPA, which is Java Persistence API. It's a special library, which is a special dependency which helps us to auto manage our database tables and database script. So by using JPA, you don't need to, write your SQL script. You don't need to, manually create your database table. By writing your entity, what we call model, and by using specific annotations, it's going to auto create a database table for you, and it's going to also create the columns and the fields needed in that table. So by using JPA, you don't need to write your SQL script. You don't need to write select all, insert into. You don't need to do all of these because these have already been done for us. So that's what JPA does. So search for JPA right here. You're going to see Spring Data JPA, and the description says it helps to persist data in SQL stores with the Java Persistence API, which is what JPA means. using Spring Data and Hibernate. So click on that to add that to your dependency. Then we're also going to be performing some validations. We want to validate our data, and that's going to be done using the validation. So again, come to the top, you can search for validation, which is validation right here. If you don't want to search for it, you can just scroll down like so, just keep an eye down to where you have IO, and then you're going to see it right there. So keep scrolling down, you're going to see IO right here, and then moving down, you're going to see the validation right here. So it's simpler when you just search it up right here. Okay, then very importantly, we want to be able to implement security in our application. We want to have authentication, authorization, cookies, session, this kind of stuff. We want users to have a role and want to be able to differentiate from one role to another, from an admin. So this can be done by having the Spring security added. So again, click on the add dependency right here, and you can scroll down to the security section, which you can see security right here. You can see you have different stuff, Spring security, OAuth client, and stuff like that. So we only have business with the security, Spring security right here. So click on Spring security right there to be added. If peradventure you don't want to scroll down again, just come right here and search for Spring security, which you can see Spring security right here under security. So click on that to add it. And then lastly, we want to be able to want to use our Lombok. Lombok can be used to do a lot of stuff. You can use Lombok it's a library which you can use to log, data on your application. You can use it to, auto-generate getter and setters. Instead of you having to type it manually, you can use Lombok to do that. And you can use Lombok for dependency injection also. I'm going to show you guys how to use that. It's very easy. So let's add that dependency. Again, come right here to add dependency, and in the developer tool right here, you can see Lombok right there. So click on Lombok like so to add. Okay, so this is what we need, and you can click generate to generate. Okay, before I do that, let me just show you right there. I love dependencies right here that you can use to build whatever you want to build. There are a lot of them right here. So based on the project you want to do, you can select them and use them right along. Okay, so for us, this is what we need. We need the Spring Web, a MySQL driver for MySQL user. Then for Postgres users, we need the Postgres driver also. Then the Spring Data JPA validation, security, and Logbok. Note, if you are a MySQL driver, if you're a MySQL user, add the MySQL and the JPA, excluding the Postgres. If you're a Postgres user, add the Postgres and the Spring JPA, excluding the MySQL. Okay, now let me click on generate, and let's generate that. Click on generate like that. So that has been downloaded. So what I'm going to do now is I'm going to head to the downloads folder, which is this. I'm going to extract it up right here. So double click like so, and that has been extracted. And what I'm going to do right now is I'm going to open the extracted file, copy everything right there, go to where I cloned my empty project from my repo, which is this. Open it up right there, paste it everything right here, and then I can now open this Springboot repo on my IntelliJ. Now we have all the codes that were used to bootstrap they were used to create our project. So we have everything up right here within this empty folder now. So I'm going to head on to my IntelliJ. I'm going to click on open, and I'm going to try to look for where it was. That was tools, Springboot like so, and that was a Springboot course like that. So open it up, and this is it. And if you're opening it up for the first time, it's going to try to download your dependency, which you can see right here. It's trying to download, and okay, let's just do that right there. Let me double click on this to open up properly. And this is going to try to install the necessary stuff for me, and then I can head on. So before it's finally done, I want to just go to my terminal right here at the left. you can click on it where my icon is, or you can do git branch to know the branch where you are, and we can currently see that we're in our master branch, which is what we have right here. So I don't want to commit everything to my master branch. I want to create a different branch specifically for the task manager project, so you guys can easily check out there and see the code. So I'm just going to come right here and say git branch git checkout minus b, and that's going to be called task underscore manager, like so. Click on enter, and this has been switched to a new branch called task manager, like so, and that is it. So if I do git branch, and I'm now in a task manager, like so. Yeah, the star is there. Okay, so that is it. So now let me move down. We can see my project has been built right there. So right click on that, and again, if you do not have the SDK Java version for this project, so again, go to your right here, click on these settings at the top right here, go to project structure, then SDK right here, click on the SDK, and then you can download the version 25 if you don't have it, or if you already selected a different version that you have on your operating system, you can just make use of that. Okay, so that's it for that. And I'm just going to come right here to the root of my application and try to run it by clicking run. So let's try to run, and let's get to see the outcome of this. Then we'll know what to do. Okay, yeah, my app is trying to run right there. Let me just wait and see the outcome, and we can see I'm getting a little bit of, it tried to run right here. It tried to start on port 8080, which is the default port, and right here we can see an error occurred. And what was the problem? Application failed to start. The description is failed to configure a data source URL, which means that because we now have database dependency in our project, it was trying to connect to a database, and it could not because it did not find any database to connect to. That is one problem why it failed. And secondly, we are now being told that, okay, if you have embedded database, or you can use them. So what we are going to do next is for us to find a way to connect to our database so we can solve the problem right there. So we're going to do this in the next lecture. Now, if you do not have MySQL download installed already, then and you want to make use of MySQL, this is how to go about it. Come to your browser right here, just search for MySQL on your browser, click enter, and you are just going to see something like this. So go to the mysql.com right here, click on the MySQL right there. That's going to be the official link for MySQL. So then click on the downloads right here at the top, click on the downloads like so, and then you're just going to see stuff like this. So scroll down and you're going to see the download right here. So if you do not have MySQL download already, you need to download two things, which is the MySQL community server. So this is where your database actually stays. It helps you to store your database and it helps to run your database. So download the MySQL database server. Then after you've done this, then download the MySQL workbench. So your MySQL workbench is more like a graphic user interface that helps to that helps to display what you have in your database. For example, if I already have everything installed, let me show you how it looks like. This is the MySQL workbench, like this. And this is my MySQL workbench. So it's more like a graphical user interface that helps me to connect or to interact with my database. So make sure you have your MySQL community server installed. After you've done that, then you can install your MySQL workbench. So you can easily use this to interact with your database, to get to see your tables, etc. For example, if I click on this looker right here, and you can see I have some tables already right here and some stuff like this right here. Just these are on my local database, and these are coming from the community server which I already have downloaded. Okay, so do that and Thirdly, you can download the MySQL shell. I don't have the shell. The shell is more like a bash or like a git bash that helps you to access your server right there. So you can use SQL command to interact through the shell to communicate with your server by listing all your database, creating tables and all of that. So if you do not want to use the workbench, you can use the shell. For me, I don't have the shell installed. I prefer using the workbench to communicate with my database in my server because it's more easier for me that way. Okay, so download these two things, and when you've downloaded the server and you're installing the server, it's going to prompt you to type in your username and your password. So take note of the username and the password, for those are what you will be needing to connect to a database. For example, if I want to connect to my database right now and I create a new connection by clicking on this plus right here, it's going to prompt me to pass in my username right here and then my password. So when I was installing my community server, the password I inputted there should be what I will pass in right here. Okay, so take note of that when you're installing your server like so. Now, if you want to make use of PostgreSDB, then come to your browser right here and type Postgres like so. Just type in Postgres, click on enter, and you're going to see postgresql.org. Click on that like so. And right here at the top right here, you're going to see download. So click on the download at the top right here. And right here, you're going to be prompted to select your operating system which you want to download Postgres to. So let's say I'm a Windows user, I select Windows like this. And then it's going to show me how to install Postgres on your Windows. So I recommend using the EDB installer. So click on download the installer like this. And right here, it's going to show you the different Postgres version, the different operating system right here, and then you want to select. Okay, so we can see right here it's not supporting Windows 32 like so, right? So so this Postgres for Windows supports Windows 64. So if you're a Windows user, come right here. You can click either of these version by clicking on this right here, and it's going to try to download that for you. Can see right here is trying to download like so. Okay, yeah. Now for those who are let's say you are a MacBook user, you can click on the Mac OS right here, and you can either install using the installer right here by clicking on that. Select your operating system click on that to install, or you can move down to install using the postgres.app. So click on the postgres.app right here. It's going to take you to a website called postgres.app, and it's going to show you one kind of stuff right here to download. Click on the download, then click on if you want to install this version 18. If you want to install a lower version, let's say 16, click on that, and then that's going to download right there for you. Now, if you've downloaded Postgres, by default, when you follow the instruction, you should be able to also download the pgadmin also. Okay, so when you follow the EDB installer, it's going to also help you download the pgadmin, which is something like this. It's just like the GUI, a graphic user interface, which helps you to connect to your Postgres server and then helps you to manage the database right there. So if you have difficulty, installing either your Postgres or your MySQL, there are a lot of resources out there. You can probably just go, let's say, how to install Postgres, and let's say Postgres, let's just say pg admin on, you can say, let's say Mac or Windows, let's say on Windows, and then it's going to just show you the step right there. In most cases, they're going to suggest the videos for you that you can, go through, or you can go through YouTube, search for how to install Postgres or how to install MySQL, and they're going to come up with those stuff for you. Okay, so just click on that. Make sure you have those databases installed for you to be able to proceed with the course. If you already have them installed, congratulations, that's good. Let's move on. Okay, so let's try to connect these to first our MySQL database. For those who are MySQL user, let's get to see how to connect your application to your database. So firstly, let me go to my pom.sml so I can get to see what I have right here. So here, my pom, you can see these are what I have. These are my dependency right here. My JPA, security, validation, etc. I have my MySQL J dependency. I have my Postgres right there, and etc. My GPA is there, and every other thing is there right here. You can see right here I have my Lombok plugin right here. So if you look at your build right here, you can see I'm having two Lombok plugin. One was coming from the one I already have in my IntelliJ, which is this one right here, the Maven compiler plugin. And the other one was what I added in my dependency from Spring Initializer. So if you're having these two right here, if both of them are showing up, you can get rid of this first one. You can comment it out like so, or you can totally get rid of them. But if you don't want to do that, you can still leave it right there. There's no problem, right? I mean, but it's, you can just get, comment one out, okay? So yeah, so that's it. Then if I move down right here, you can see I added two, dependency for MySQL and Postgres. This is because this is a tutorial. I want to show you how to connect to both database, but in a real time, you're only going to, have one for a specific database. So for now, I just want to show how to connect to the MySQL database. Because I want to do that, I need to comment your Postgres one out for now. So this is going to, comment this out. And if I want to resync and remove this, I have to press this icon right here. This is going to say synchronize Maven change. So when you add a new dependency to your pom.sml, or when you remove anything, you have to come right here and click on this little M stuff. This is going to refresh or update your dependency. So if you have anyone that you have removed, it's going to remove it from the external libraries right here. If you added a new one right here, it's going to add it to the external libraries right here. This is where it gets the source code from that helps you to build your stuff. Now, if peradventure you made change to your pom.sml and you're unable to see the little M icon right there, what you need to do is to come to the right. You're going to see this M right here, which means Maven. Click on it right there, and then at the top right here, you're going to see synchronize Maven project, more like a synchronization logo. So right click on that and click on synchronize all Maven project, and then click on it again and say reload all Maven project. So this is going to help to re-download your dependency, and it's going to help to resynchronize or re-update the dependency you have right here. Okay, now that has been done, and for us to connect to our database, our connection it's done in the application.properties. So go to your resource right here. Under your resource, you're going to see the application.properties. This is where our database connection is. So first of all, I want to specify my ports by saying server.port, and then let's give it a port, and let me call this ports 80. Let me just say 80. 88, something like that. And I'm going to do that. Then for me to connect to my SQL database, I'm first of all going to open my workbench, and I'm going to have that database created. So I'm going to go to my localhost connection. If you do not have this, or if you've not done that, for you to be able to create it, come right here. You're going to see MySQL connection. Click on this plus right here to create a connection. Then pass in your connection name. I can say localhost. Let me say 2. Then your host should remain 127. This basically means localhost. Username is your username when you were when you're installing your server, and the database, the password will be the password you imputed when you're installing your MySQL. So mine is 1, 2, 3, 4, 5, 6, 7, 8. Click on OK, like so. Then you can test the connection to be sure that it's going to work. Okay, that has been connected successfully. I can click OK. You can see my localhost 2 has been added. If I click on that right here, it's going to open it up, and you can see these are the existing database I have. Now, for me to create a database, you need to first of all create a database that you can connect to your project. So to do that, you can come right here at the top right here. You can see there's a big, database plus right here. And when you hover on that, it's going to say create a new schema. You can click on that and pass in your schema name. Let me just call this task. Let me just say task DB and click apply. You can see it's going to, execute this code to create a database for us. If you don't want to do that and you want to write your code by yourself, which I always like to do, so that you can come right here to your, you can come right here. That's going to open up your query, screen and just say create database and then just call it, let me call it task DB. Then just click on this fire button right here. And you can see below right here it has told me that the database has been created, which let me try to put this up. You guys can see. Okay, I think I'm having difficulty pulling this up right here. Let me try again. Okay. Yeah, but we can see below right here says database has been created, something like that. Okay, if I refresh right here, I can see the task DB right here that I just created right there is there. So this other one was what I used some time ago. I can just delete that like so. And now I have my task DB right here, which was created. So for me to connect to this right here, I'm going to come to my project and then I'm going to say, let me first of all add a comment and say MySQL database connection. And that's going to be, you're going to say spring dot data source dot URL equal to, then this is going to have your URL connection. Then you're going to say JDBC, okay, then double column MySQL, because this is a MySQL DB, put in your double column again, double slash, then your MySQL, then the URL to your database. So because my database resides on my laptop right here, it's going to be, the URL is going to be a local host or 127.0.0.1, and then my port is going to be 3306. How do I know my port is 3306? If I come right here, you can see it right here, the same port is 3306 like so. And then after that, I'm then going to put a slash, my database name, which was called taskdb, like so, taskdb. So this is going to be my database URL. So for those who have their database remotely, somewhere very different for you to connect to it, this is not going to be your, let's say HTTPS, let's just say Amazon, let's just say, just your database URL, your port, and then the name right there, okay? So that's it. Then after this, you need to specify the username because we want to have access to this database. So to do that again, you're going to say spring dot data source dot username, and that's going to be equals to your username for accessing your DB. For me, that is root. Lastly, you have to pass in your password because we need the password to be able to access it. So go again, spring.data source dot password, and that's going to be your password. Mine is 1 2 3 4 5 6 7 8. So let's try to check if I can connect to my DB. Again, make sure your database is up and running. If you're on a MacBook, to be sure your database is running, come to the top right here, click on about system setting, like that. Then move down, you're going to see your MySQL at the bottom right here. Click on that, and you're going to see the status if your MySQL server is running. You can decide to stop it. This green button means that your MySQL server is running, right? Okay, good. Okay, now after you've done that, I'm just going to try to run my app again to check if it can connect. So click again to run the task and let's see the result. So right now we can see we have been able to connect to my database, which you can see right here. And now that error is gone. So what we can see right here is that a unique security password has been generated for us because we are using Spring Security and our application is secure, which you can see right here is currently secure. So before you access your application, you need to pass in your password. So that is why this password was generated for me, so I can have access to my application. So this is it on how to connect your MySQL database. And in the next lecture, for those who are using Postgres, I'm going to show you guys how to connect Postgres to your Springboot application. I'm going to stop this right here and I'm going to see you in the next course. Now let's look at how to connect the application to a Postgres database. So the first thing you need to do is to, create the database in your Postgres. I'm just going to go to my PG admin 4, which is my GUI for accessing my Postgres database. I'm going to open it up like so. And let me pass in my system password. And that's opened up. So at the left right here, you can see servers right here. When you click on the servers like so, you can see you have your Postgres right there, which is 18. And here I have my databases right here, which are basically 3. The first thing for me to do is to create a database. So at the top of this database right here, double click on that and you can see create. Right, click on that, just click on create database, and you can pass in your database name. For me, I just want it to be called task DB, and then the owner should be Postgres like so. Then click on save like that to save like so. So now right here you can see your Postgres task DB has been created like that. So the database has been created. So the next thing for me to do is to connect my Springboot application to this task DB database right here. So I'm going to come back right here to my application, which is actually this one. I'm going to go to my POM XML, and I'm going to, in the last lecture, I showed how to connect to my SQL. So for Postgres users, I'm going to bring back the Postgres dependency, make sure the Postgres dependency is there. I'm going to get rid of the MySQL dependency, just comment it out so we can have our Postgres right here, because this Postgres is needed to access the Postgres DB, okay? Now, when you make a change to your pom.xml, you are going to come up with a little bit of M icon right here. Click on that, and that's going to reload your pom.xml. It's going to recheck your dependency, re-download the ones that are there, and get rid of the ones you no longer need. So that's what that does. If peradventure you've made a change to your pom.xml and you're unable to see the little m right here, what you should do is at the far right here, you're going to see a small letter M right here, which means Maven. Click on it right here, and you're going to see a little bit of hover, like a synchronous, logo right here. Click on the drop down and click on Synchronize All Maven Project. Click on it again and click on Reload All Maven Project. So this is going to resynchronize what you have in your pom.xml. It's going to download the dependencies that have been added or removed, and if you have any dependency that has been removed, it's going to remove them. So when it does that, it's going to synchronize your external library right here. These are where the actual file of the dependency resides, which we can use within our project. So by this, I have added my Postgres SQL dependency, and I've reloaded my project, and I can now have access to the library right here. Now, for us to connect to our Postgres DB, come to your resource right here, come to the application.properties. This was the one I used in connecting to MySQL. I'm just going to comment it out like so. And then come to down right here, I'm just going to add a comment to say Postgres DB connection. So again, you're going to do spring dot data source dot URL, and that's going to be again jdbc double colon, because I'm using a PostgreSQL, this is going to be Postgres, GRESQL, right? So make sure this is spelled correctly. PostgreSQL, like so. PostgreSQL, then put in your column, then put in your double slash right here, and then pass in the URL to where your database is. So because my database is on my local machine, that is going to be local host, like so, and then pass in my ports. My ports for my Postgres is 435432. So take note of the ports of your Postgres when you are installing that. And again, then put in your slash and pass in your database name. So the database I created was called TaskDB. So I'm going to call that TaskDB. Now moving down, I need to pass in my username and then my password. So again, spring.data source.username. So what is your username for your connecting to your Postgres? That is called Postgres. That's for me. Then the password is going to be spring.data source.password. And mine is 1, 2, 3, 4, 5, 6, 7, 8. So when you are installing your Postgres, make sure you take note of the username and password when you are installing your Postgres. So very important. Those are the data you need to connect or access to your Postgres DB. Okay. Now this has been done. I'm going to come to my home right here. Click on Run. If I do not have that error, it means that I've been able to connect to my DB. If I'm having an error with my credentials, that means I'm unable to connect. So let me just click on Run and let's watch to see the outcome if I will be able to connect to my database. So right now we can see I've been able to connect to my database and that error is gone, and I cannot see that use generated security password like this right here. Because I'm using Spring Security, as I rightly said, our application is currently secure, and because we've not come up with our own custom implementation, by default, Spring Security will generate a password for us, which will be used to access our application if we want to have access to it. So that is exactly what we're expecting, and that is what was done for us right here. So I've been able to connect to my DB. Let me try again to alter my credential. Let me check if I can connect. Let me pass a wrong password, and then let me just run again to check if I can connect to my database. So I've passed a wrong password, and let's just get to see what will happen. You can see because my password is wrong, I'm having an error right here. You can see I'm having multiple error. I'm unable to connect like this. JDBT connection failed. Password authentication failed for user. That's because my password is not correct. So make sure your credentials are correct. Make sure your database exists right there, and everything is okay. You will be able to connect. Now, when we were configuring our connection to our database, there was one important update we omitted, which is the JPA, configuration on how to, manage our database table. So we're just going to do that quickly. So irrespective of your database, if you're using JPA, you need to add this implementation. That's going to be, I'm just going to say JPA/hibernate configuration. So that's going to be the update. I'm just going to write that out, and I'm going to explain what it does. So say spring.jpa hibernate then .ddl-auto equal to, then let's set it to update. Now, you might be wondering, what exactly are all these? So what is Hibernate? What is JPA? What are all these? We already got to understand that JPA is a library that helps us to, persist data to our database. By using JPA, you do not need to write your SQL query. You don't need to write your select statement. You don't need to write your insert query. You don't need to create a database table. It's going to auto create this for us based on the annotations you are using in your application. Now again, what then is a hibernate? Hibernate is simply the engine of JPA. So these are just technical terms that are not really helpful. So hibernate is the engine of JPA, just as Spring is the engine of Springboot. Okay, so that's what hibernate is the engine of JPA. So it's the one that actually does the job of helping to persist data in our database. Now you can see right here, we're basically saying DDL auto is update. So what does this mean? So this basically means that we are saying that we are telling Hibernate or JPA to automatically manage our database schema, such as when creating, updating, or dropping table, or when your application starts, based on what the application defines in the entity classes. So we're going to look at all of these. So whenever there is a change in our entity class, remember the entity is what is converted to a database table. So whenever there is a change in the entity class, by saying update, Hibernate or JPA is going to look at those changes to update our database column. So this is basically specific for your database columns thereabout. So if I add a new, if I add a new feed in my entity class, it's going to add a new feed in my database column because I'm setting this to update. So this is basically what it does. It helps to auto update your database table based on changes you make in your entity code. That's what it does. But in the production environment, we don't really use update. We basically set this to none, right? Or validate. So what this means is that because we're in a production environment, whenever somebody make a change to the entity code, we do not really want Hibernate to make a modification of the database table column in a production environment. So we don't really want to do that. So, but for development's sake, let's make it to update so that it can easily modify our database columns right there in our DB. So this is what this is. So irrespective of whether you are using your Postgres or your MySQL, make sure this is added right here as it is, like so. Now let's continue with our project. Now when building a project, the first thing I do is to structure the project into different layer, or what we call folder. Okay, so that's going to help us to know what we are doing, and it's going to make our development faster. So the first thing you have to do is to have them into different layers. Remember, we have the repository layer, the controller layer, and the service layer. So let's have those folder right up. So come right here and right click on that and create a new package and call that controller. Like so, the same way, go to the top, create a new package, call it service, and the same thing, click on the dot, create a new package, call it repository. And again, these are the main folders we need. We also need some other folders like the DTO. So come right here, create a DTO like that. Then we need the enums. We want to have enums, so call it enums like that. Then we want to have our model or our entity. So you can call that model or entity, models, like so, or you can call them entity. So either of them is fine. And then I'm going to have my exception classes. So also in this course, we're going to be looking at exception. We're going to see how to throw custom exception. Whenever an error occurs in our application, we want to be able to return a custom exception response automatically within our project. So we're also going to be doing that by having a folder where our exception logic will be. I'm going to call that exception like that. Okay, like that, right? So things are a little bit spicy, and I'm going to head on to have my but before I would do that, let's also have the security package. Remember, we are going to be implementing security, so let's also have our security right there, create a new package, call it security, like so. That's going to contain our security classes and functionality. Now this is properly structured, and in the next lecture we're going to start with our entity, which are our model. I'm going to be explaining that, looking at database relationship, and then see how it's done. So let's get to look at how our database table will look like, and then the relationship between this table. So right here, I already came up with our entity design. This is basically going to be the database tables we'll be having. We're going to be having the users table and the task table. The user table is going to have the user ID, which is unique, the user email, the user password, the user role, and then the tasks of that user. The task database table is going to have the ID, which is unique for every task. It's going to have a title, a description, the category the task belongs to, and then it's completed. This is going to show if that task is completed or not, and then the user who created that task, or the user whom the task belongs to. Now, if you look at the user's table design right here, you can see a user is expected to have some tasks. So this can be represented as a list of tasks, something like this, like that, which means that a user is going to be expected to have lists of tasks. So that means that for every task a user creates, there's going to be a link right here that's going to link to all the tasks a user have. Same also in the task right here, a task belongs to a user. So this can be called the user like this. A task belongs to a user. So whenever you have a task, the user who made that task is going to also have a reference. The task is going to have a reference to the owner of that task, which is the user. So now in the task table, we're going to be having these feeds, and then a feed called user, which basically hold a relationship or a link to the user who owned that task. Same also in the users table, we're going to be having a column called tasks. That's going to hold a link to the tasks of that user, to all the tasks of that user. So this is our entity, and this is going to be our table, and these are the relationship between each of them. So let's get to see how this can be represented in code, and I'm going to catch you in the next lecture. So let's head on to have this in code. So I'm going to come right here. This is our project, and within the model, you can actually call this model or entity. So it depends on your naming convention. And within the model folder right here, I'm going to define my entity. So come right here, create a new Java class, and that's going to be a class. I'm going to call this user like that, and this is going to be our user like so. So now this has been done like so, and first thing for you to do, since this is going to be our entity, which means that this is going to create a users table for us in our database. For us to make Springboot do that, we need to annotate this with @entity like so. So that's coming from the jakarta.persistent. So that is the JPA right there. So by using @entity, this is going to tell Springboot that, hey, this should be treated as an entity. So what that means is that Springboot is going to, create a database for you. It's going to create a database table for you with the name you're going to specify right there. And it's going to create the columns, which is going to be the properties of this, object right there. So we're going to see that. Now, by making this an entity, this is going to be managed as an entity. Springboot is going to create SQL query for us where we can access the data, we can get all data, we can save the data. It's going to create all the queries necessary for us to manage a user in our database. So moving on, we are going to have something called @table, like so, table, again coming from the Jakarta persistence right here. And right here we are saying that, hey, I want you to create a table for me, and we're going to give this a name called, and I want the table name to be called users, like that. So if you don't specify this, it's going to also create the table called user with an S, like so. So this is going to create a table for us in our database called users, like so. Then moving on, I'm going to also say, just annotate it with our data from Lombok. You can see this data is coming from Lombok. What this data does is going to help you generate getter and setter for the properties of this class, as well as the toString. Remember, in Java, when you're creating a class and you're creating fields or properties for that class, you need to create a getter and setter method, which is going to help us to have access to the properties of that object. So by using the data from Lombok right here, you don't need to manually type in your getter and setter. It's going to automatically generate that for us under the hood. So that's the power of using the Lombok like that. So an entity means that this is going to be treated as an entity. It's going to be managed on its own by Spring JPA. Then table right here, by passing in the users, means that it's going to create a database table for us called users, and the data is going to generate getter and setter. Now let's head on to have the feeds or the properties that we need right there. So for a user, we want a user to have an ID that's going to be private. Data type is a long and ID. We want the user to have the email, like so. We want the user to have a password. We want the user to have a role. I'm just going to, for now, make it a role. We're going to have that shortly. And we want the user to have, lastly, the task. This is going to be a list of tasks. For now, that task entity does not exist, so let's just call it task right here. And then I'm just going to make this empty for now by using the new array list, like so. Okay, and these are the properties of this user right there. Now, when I run an application, it's going to create a column in the database for me with these feeds right here. Now let's move on to to make this, to enhance this further. Now right now, if you look at the user, we rightly said that the ID right here is a unique identifier for that user, which means that this ID is unique, and this should be auto managed by, we should not have business assigning an ID to the user. We want to have a way where an ID will be auto assigned to that user, and that ID will be unique throughout that application, throughout that database table. So for us to do that, there is a very easy way to do that in Spring by using an annotation right here, say @ID, like so. By doing this is going to treat this as an ID, as a unique identifier right here. And then if you want to move on to specify how this ID should be managed, I'm just going to come here again to say @generated value, like so, and then specify the strategy right here and say generated type.identity. So what this means is that it's going to auto manage this ID, and it's going to, whenever it's generating an ID, it's going to make sure that this ID is unique within this database table. So that means it's not going to generate an ID, a conflicting ID. So when you add a new user to the table, it's going to give it an ID 1. When you add another user, it's going to have ID 2, like that, like that. So that's what this strategy means, that it should auto-generate the ID for us uniquely. So now let's move on to the email, right, like this. So by default, it's going to create a column for me in my database table called email. But if I want to specify a different name for what that column should be, I'm going to come right here and say add column, like so, and I can specify, let's say, the name. I can say I want this to be called, let me say, users_email, and this is going to create a column for me in my database table, in the users table called users email. But if I don't do anything, if I leave it as it is, is going to create a column for me called email. There are other things I can, pass within this. I can say the unique to be true. This means that it's going to make sure that the email is unique throughout that table, which means that you cannot create a user whose email already exists in the database table. When you try to do that, it's going to throw you an error. So that's what this means. This email is going to be unique throughout our table. You cannot have two users with the same email. If you want to move on again, you can say nullable to be false, which means that when you are inserting a user, when you are creating a user, the email must be passed in before the user is saved right there. So these are other things that can be done. So let's look at the password. I'm going to come right here and say add column like that. I can say nullable. Let me just say nullable to be false, which means that a password must be provided before a user is saved. So again, I'm going to also do something like this by saying adjacent, where is it? Adjacent ignore, like so. And what this does is that because password is a very sensitive data, whenever I am serializing my object, which means that whenever I'm converting a user, a Java user object to a JSON, is going to ignore this password field right here, because a password is very sensitive. So when we're returning a user object, we do not want the password value to be displayed. So when I'm getting my users from my database, it's going to ignore the password right here. That's what the JSON ignore means. When I'm getting my user, it's not going to add the password along because it's very unique and it should be kept secret. Now for my role right here, I'm going to create the role shortly. So let's leave that for now. Then for my task right here, I'm going to leave those for now. So when I have my task right here, then we can come and associate the relationship between a user and then a task. So I'm going to head on to create my task entity. So same way, let's create our task entity. I'm going to come right here within my model and create a new class right there, call it task, like so. And that's going to be a class, and I can come right here and annotate this with at entity. We already know what this means, and then I'm going to annotate this with at a table, and then I'm going to give this the name of this table should be called tasks, task like so. And I'm going to also have my data from Lombok like so. So if I go back to look at what the fields I need in a task, we need the ID, the title, description, category. This should be an enum like so, and then it's completed, and then the user. So let's get to do that. Again, this is going to be the private. The data type is a long like that, and that's going to be the ID, and then the task title, and then the description, and then the category like that. For now, it does not exist, so let me just keep it as it is. And then a boolean to just help to check if that task has been completed or not. And by default, I'm just going to make it a false like so. And then I'm going to also have my user right there, which is our user like so. And this user should be coming from this user right here, okay? Good. So again, this is our ID. We need to annotate this with ID, telling our JPA that this should be the unique data indeed. This should be the ID of the table. And then I'm going to say add generated value, strategy, generation, type.identity. This is going to help us to manage our ID, to auto generate our ID for us uniquely. Then for the title, I'm just going to leave it right there. It's going to create a column for us called title, the same way with description. So if you want to probably do other things, you can say add column, and then right here you can do whatever you want to do. These are different things right here. But for me, I don't really want to do anything. Leave it right there. It's going to create a title for us, and by default, these columns can take in null values. So if you do not want your title column to take in a null value, again, you know what to do. You can do like this and say nullable to be true. You can see we are by default is nullable, which means false. Then you can set it to be true, right? To be false. I mean, nullable to be false. Okay, so now that is it. I'm going to move on to have our enums, and then we're going to come again to them explain database relationship. So we want to be able to have the user role and then the category a task belongs to. So for us to do that, I'm going to come to my enums package right here, create a new enum, which is a Java class, and scroll down to the enum part and call this category, like so. And this we want to have just basically two categories, which is personal and then work, like so. So a user can either be able to create a personal task or be able to create a work-related task. So just something like that to make our app more fancy. Okay. Then let also have the role of a user. One will have two kinds of users. So right-click on that, create a new Java class, scroll down to the enum and call this role like that. And we want to basically have two roles, an admin user and then a regular user, which is a normal user. So we're going to be looking at how to protect an API to only be accessed by an admin, and then also how to also protect API to only be accessed by authenticated users. So all of these will be covered in this course. So for the meantime, these are the two role users we will be needing, an admin user and then a regular user. Then our category is here. So I'm going to come back to my task and bring in my category right here. Make sure that that is imported from your enums, right, your project. You can see there are other categories coming from other libraries. So make sure you are selecting the one on the enums to avoid getting error right there. So click on that, and then in my users, my role, click on that, my role right here, import, and make sure the role is coming from the one you defined and not from the other libraries right here. So click on the one you defined and you can see where they're coming from right here. Look at their package right here. Okay, now our role has been imported, and then right here I can import this right here to make sure my task is there and everything right is here. So for now, we've not linked our relationship right there. So let's get this done in the next lecture. We're going to link the relationship between these tables. So let's link the relationship. Before we do that, let's modify or define our role properly. So right now, if a role is inserted in the database, it's going to just register the role using the index of the value right here. So if I'm an admin, in the database record is going to use the index 0. If I'm a user, is going to use the index 1. So we don't really want that to happen. We want a situation whereby if I register a user as an admin, the value admin should be registered in the database table. So for me to do that, I'm going to come right here at the top of the role. I'm just going to say enumerated like that, and then I'm just going to say enum type.string. So by doing this, it's going to record the actual value of the role, which is the admin or the user in the database, rather than picking the index. So this also should be done in the category right here, like so, and this also should be done right there. Now, if you want to, probably just, make this a little bit more fun, you can decide to come to the user and say, we do not want the role to be null. So I'm just going to come right here and say add column right here and say nullable to be false, which means that this column right here should not be null. Whenever you are inserting a user, the user role must be defined and passed along. Okay, so now let's head on to go to one of the most important things, which is the database relationship. Now, if a user have a list of tasks, how are we going to tell our database that, hey, going to define the relationship, how we're going to let our table know that user is expected to have a list of tasks. Tasks can be done by using what we call a one-to-many relationship. Now, before I just use that notation, it's very simple. Let me just explain this quickly. Now, a one-to-many relationship means that a one, which is this user, can have multiple tasks. Now, for you to be able to know when to use a one-to-many relationship, you can see right here, this is a list of tasks. So by having a list of tasks, by default, this is going to be a many, right? So this user right here is expected to have a multiple task right here, okay? Now, this is going to be a one-to-many relationship. If this was a different case, let's say this was a task right here. Let's say this was a task. Why am I spelling it wrongly? Let's say this was a task right here, like this. So what would this relationship be? This is not just one value task. Okay, let me spell it correctly. So what would this relationship be? It will no longer be a one-to-many relationship because task is just one. It does not have a list. This is going to be a one-to-one relationship, which has one user having one task, right? Okay. So because one user can have multiple tasks, we represent this by a list of tasks. And then this is going to have the annotation using one-to-many coming from the Jakarta persistent. So once you do this right here, once you do this is going to be auto-managed by JPA. So it's going to create a query where you can search for a task and get all the data that belong to that user. So there are a lot of join query that is going to be generated at the background for us. So we don't really need to worry about that. Ours is just to, have the annotation right here, and JPA is going to do the magic for us. So by annotating this with a one-to-many, we're basically telling JPA that, hey, a user is expected to have multiple tasks, so you know how to come up with the SQL code right there. So moving on, we can decide to define the only part by saying mapped by, which is going to be equal to the user. This basically say that, hey, the user is the only part of this right here, okay? Then we can go on to say cascade. We can specify a cascade and say cascade type.all. So what this means is that if I delete a user, right, then delete all the tasks that belongs to that user, okay? Or if there's a change in the user objects, then wherever you have a user task, also make a change with a reference to that user right there. So that's what this cascade.all does. There are a lot of other type of cascade. You can say, when you say dot, you can have other things. We can have detach, we can have merge, we can have persist, we can have remove, stuff like that. So let's just leave it in cascade.all. Is going to help us to, do all the basic cascade right there, okay? So that's what it is. So map by basically says, hey, this user is the only part of this relationship. And then the cascade.all means that when you delete a user, delete the tasks that belong to that user only. And when there's a change in the user object, also modify that task that references that user. So that's what this is all about. And let's head on to the task and also specify the relationship to the user right there. So right here in the task, I'm going to come right here under the user right here. I'm going to make this remember we have a task right here and then we have a user. And right here already, we already say that a user can have multiple tasks, right? So in the task, what exactly you're expecting this to be? Since a user can have more than one task, it means that multiple tasks can belong to one user. So that's what exactly it is, because right here, the only part of the relationship says that a user can have multiple tasks. So the other side of the relationship, which is the task, this is basically saying that multiple tasks can belong to one user, which means that I can come on the application and create, let's say, 100 tasks, 200 tasks, as multiple tasks as I want. So I need to tell my JPA that, hey, this is what I'm expecting. So that's going to be at many to one. And again, I can decide this is at many to one. So I can decide again to come right here and say adjoin column. And I can say the name should be users_ID. So what does this join column mean? So what this means is that in the task table, it's going to create the column is by default is going to be the, task user underscore ID, but it's going to create a column for us, or the name of that column is going to be users underscore ID. So if I don't specify this right here, by default it's going to be the users right here, this name right here, user underscore the name of the primary key, which is ID. So if I decide to call this primary let's say primary key, like so, then by default, if I don't specify anything right here, this column name is going to be called primary underscore key by default, except I come and change it right there. Okay, so that's basically what that is. Let me take this back to where what it was, and then by specifying the column name, you can decide to call this users underscore ID, something like that. Okay, yep, so something like that. So right here in the user right here, you can decide to also come right here, and at the top right here, I'm just going to do something, and probably I'm just going to explain this in the next lecture. So I'm trying my best not to make this complex, but let me do everything down so we can move along. So right here, I'm going to, before I do that, let me just quickly, okay, right here, I'm going to come right here and say at JSON managed reference coming from the fast JSON annotation, and then I'm just going to give it a value. I'm going to call this users tasks right here, okay? And then I'm going to come to the task. I'm just going to explain it shortly. Let me just, do everything right here so it will be easier. I'm going to come to this task right here and say JSON, that should be JSON back reference, and again the value is going to be the reference to this right here, which is the users dash task. Let's just make this users dash tasks like that. I'm going to copy that. I'm going to say value is going to be user task. Okay, now I know you might probably be confused, what does the JSON back reference, because if you look at the import, it's not coming from the Jakarta persistent, which means that this is not coming from our JPA. It's a different annotation. So what this does is that the JSON managed reference, it's going to help prevent what we call circular dependency, which might lead to Stack Overflow. Remember, we have a user is going to have a task, and right here within the task, a task have reference back to a user. So now when you don't do this, when by default you are getting the user right object, is going to get all the task for us, and within the task is going to again referencing the user again, which is again referencing all the tasks. So this might lead you to, if you don't manage your application properly, it might lead you to what we call circular reference, which might lead to a Stack Overflow. So if this can be done manually, it can be managed manually, but I just want to show you guys how just to do this in case you come across a large application production code where you have a JSON managed reference and you have like a JSON back reference, just to let you know why they are doing stuff like this, okay? So if you don't do this, we can manage this by having a custom DTO and then limiting the fields that we need. So this can easily be managed, okay? Now, yeah, so what JSON managed reference does is that it's saying that, hey, when you are serializing, which means that when you are converting a user to an object, add the task of that user. Just go ahead and do your normal serialization, then add your task. Then in this task right here, by adding a JSON back reference as giving a reference to the initial parent, which is the user's task right here. So when we are serializing, which means that when we are converting a task to an object, which means that when we are returning a task when we are using a task to return a reference, do not add the user to that. So if I'm returning a user and the user is returning a task, within this task right here, do not add the user again do not add the user to the data you are returning. So that's what JSON is managing the back reference of this task, this user right here. So when I'm returning a user entity to use to return a response. It's going to give me all of this feed. It's going to give me the list of all the tasks. Within that list of tasks, it's going to ignore this user right here, so that is not going to lead to a circular reference where I'm getting task of user of task of user. So that's what this is all about. So if you are finding it a bit confused, don't worry yourself, just leave it out and just take it as it is. The more we build projects, the more I'm going to come and explain this stuff. But the most important thing for us to know is to understand the relationship, which we can see right here. Understand a many-to-one relationship, understand the one-to-many relationship, and stuff like that. Okay, so that is it. Also remember that the line of this annotation, you can put this above or below. It does not really mean how you arrange them. As long as they are on top of this, it will be affected on that properties right here. So these are database relationship, and this is how to specify that in Spring Boot. So let's head on to have our DTO, which is the data transfer object. Normally in an application, in a Spring Boot app, it's not appropriate to directly return your entity class as DTO. So it's appropriate that you create a corresponding class, which we call DTO. So let's create the task and then the user DTO. So within the DTO folder right here, I'm going to right click on that and create a new Java class, call it user DTO like this. And here I'm going to come with the feeds, which is going to be the private long ID. For us to be faster, I can come up right here and just get hold of everything right here. So let's do that. Copy everything right here, come to the user DTO, have them up right here. Now we're going to remove these entity annotations right here. We're going to remove all of these. I'm going to remove this as well, and then this as well, and remove the initializer like this right here. So this other one is going to be now be a list of task DTO like so, something like this. Okay. Yep. So now I'm just going to get rid of the imports that are not needed right here by using option command L. Is going to help to remove your import right here, or you can click on the file at the side, do reformat code like this, and you can just do this to optimize your import like that. Okay, so again, we need the ID, we need the email, we need the password, we need the row, and then the tag. So this user DTO class right here will be what we will be using to return the user back there. Let's say I want to get my user profile. This is going to be used to return the data which I'm getting from the DB from this user right here. So I'm going to be using this to collect the data. I'm going to convert this right here to this up right here. So that's the better way to do things to keep our code clean and healthy. So here I'm going to annotate this with our data like this from Lombok. That's going to help me to generate the getter and setter for each of these property. Also, we want to be able to use this class right here to return the response. So I'm just going to say JSON include, and that's going to be JSON include dot not null. So what this means is that if I'm using this class to return, as a response, that means if I'm converting data to a JSON using this class, which basically means that if I'm serializing, right? Serialization is where you convert a Java class to an object. So if I'm converting a Java class to an object, then this right here that says JSON include dot not null is basically saying that ignore any field right here that is null. So right here, this password field is going to be null because it's already been ignored right here in our user entity right here. So this is going to be ignored. So that means that when I'm returning my user DTO response, I'm not going to be able to see the password field because this value is already null. So because it is null, this is going to exclude this right here during serialization. Okay, so that is it like that. And let's also do the task DTO. So I'm going to come right here, create a new DTO, call it task DTO like this, like that. And I'm just going to come right here and go to my task, copy everything right here, come to the task DTO, paste them right there, and remove this database stuff right here. Remove this first right there, and then do something like this. So for this time around, the user will be the user DTO like so. So let's get rid of these imports that are not being used. Okay, again, annotate this with our data like so. From Lombok, that's going to help us generate our getter and setter. We have our title, description, category is completed, and then the user, which is a user DTO. So again, I'm going to annotate this. That should be an art right there. I'm going to annotate this with art JSON include, which is going to be JSON. That should be, what am I doing? That should be at JSON include dot not null. Like this is going to exclude nullable fields right here during serialization, which means when I'm using this to as a data response like so. Okay, now you can decide to get rid of the user when I'm getting a task. I might decide not to get the user along, so it's not important for me to fetch a task and then fetch the user of the task along. So instead of me to come right here in the task and then to have this back reference right here, and the user, I have my JSON manage reference. Another way for us to do this is to come, when writing our DTO, is to exclude the data we don't need by, let's say, having that out, or let's say commenting it out, something like that. So this is also going to work. If I also leave it up right there, and as long as I have my JSON back reference and my JSON manage reference, this is going to be perfectly cool. I'm just going to get the user data without having the nested information, without returning the task of the user along. So because we don't really need to, when we're getting the task, we don't need to get the user along, I can just comment this out so we can get the basic task details, which is the title, description, category, and is completed. Okay, so moving on, let's also have a class to. Before I do that, I just want to also introduce you to another new annotation. Not a new annotation, is be there. That's going to be called the JSON ignore property. So let's, within your task DTO, come right here and say at JSON ignore, where is it? JSON ignore properties like this, and I'm just going to say ignore unknown to be true. So now what is this used for? We can see these are all coming from the Jackson fast XML JAPC dependency, which by default comes along with Springboot. Now, so what does this JSON ignore properties, ignore unknown to be true? So this is going to take effect when I'm using the task DTO as to receive my object from the body. So when I'm using this as my body to receive data, it's going to ignore those fields that are null, or those fields that are not present in my body. So it's going to ignore those fields and then only work with the fields that have data. So that's what this is doing right here. So when I'm adding a task, I'm going to be using the task DTO to collect the task. That's going to ignore the fields that I did not pass a data in. So I'm going to also do this to the user DTO like this. Let's say I'm updating a user, right, which I'm going to be collecting the data using the data user DTO. I want to just update, let's say, only the email, or I want to update only the password. It's going to ignore other fields that do not have data. It's going to set them to be null, or it's going to ignore them automatically. So that's what this does. It's going to ignore properties of fields that are null when you are using this class as a body response, or to collect data when making a post request or a put request. So that is it. In the next lecture, we're going to be looking at our generic response class. We're going to also be looking at our login or registration request DTO. So let's head on to have our login and registration request DTO. So if we want to register a user, I want to log in a user, we need to have a DTO to collect the response, which will be passed down to our application. So let's have that DTO right there. We can decide to use the user DTO right here, but I just want us to have a custom DTO so we can see how to implement validation. So I'm going to come right here to my DTO and I'm going to say, right click on that, create a new class, and that's going to be called registration, which is registration login request. Like that, that's going to be a class, and I'm going to have my add data right here, and I'm going to have my feeds, which is going to be the email, and then the password. I need to pass a password in when registering a user and when logging in, and also the role of that user. The role should be coming from your enums. You can see there are different roles right here. Make sure you select the one that is coming from this package right here, the enum, like so. That's going to be role. So that's going to be private role of role, like that. Now I need to add validations to this so that when you are trying to register or log in and you do not pass an email, I want an exception to be thrown or a warning to be thrown to you that say, hey, you need to pass in an email. So we already have a library called validator, which is this library we added when this validation right here. This was a library we added when creating an application, and this is what we're going to be using to validate user input right here in our class. So I'm going to come right here and say at email, you can see the email is coming from the jakarta.validation.constraint. So at email, this is going to make sure that a user is typing in an email. If you type in a non-email value, an exception is going to throw in. So if you are not typing a correct email, a message that should be thrown should be, please provide a valid email address. Okay, then for the password, again, you can also say at not blank, and if peradventure this is blank, a message to be thrown should be, let's say, email is required, like that. So for the password also, I'm going to also use validation at non-blank right here from the jakarta.validation. And then if that is validated, the message should be password is required, like that. Okay, so these are this for the row. The row is optional. We're going to set a default row right there when we are writing our logic. So when you want to register or log in, these two fields are required, and this is how to use validation from your dependency right there. I'm going to show you how to invoke this in the controller layer. Okay, so these are what we need, and let me head on quickly to have my API response class, which is a generic response class. That's going to be called API response. I'm going to make this a record. You can make it a class, but I just want to make it a record like this. Records are more useful for data that will not be modified. Okay, so here I'm just going to call this an API response of type. I'm going to give it a data type of type T, which can be anything. And right here within this right here, I'm going to pass in the feeds needed, which is the status code, then the message, comma, and then the data, which is going to be passed in. So the data can be your user DTO, your task DTO, or a string or any other kind of data you want to be displayed. So right here, I'm going to annotate it with adjacent include, and that's going to be JSON include dots not null. So what this means is that if there are data that is not present, it's going to not display them. Okay, so that's it. So this is going to be our generic response class. I'm going to head on in continuation in the next lecture. So let's run this app and see. If I run my application, I'm going to have two tables created for me in my database called the tasks and the users. Okay, so right now for me to confirm, if I go to my database and go to my task DB right here, I'm just going to right click on it and go to PS query tool right here. Let me go to the query tool like this, and it's going to select the database. If I say select all from, let's say, users, that table does not exist. You can say users do not exist. If I want to confirm, you can right click on the task right here. Okay, if you're using Postgres, click on the task, go to the schema right here, and within the public, go to the table section. If you click on it, you can see there are currently no table, like so. Right, so there are currently no tables. So let me run my app right here, and I'm expecting this to auto create two tables for me. So at the top right here, click on the plus, and let's get to see the result if this will run correctly. Okay, just click on this to enable that, and let me wait. My app, let me see if my app has been run correctly. So if I go to my database again, and let me try to run this again, you can see users, has been created. If I let me refresh this again, and if I click on my table again, you can see I have tasks and users created for me right here. And if I say select all from tasks like so, we can see our task is there, and we have our feed right here, the user ID, the title, description, category, and that corresponds to, and break this down, that corresponds to the task we have right here, which is this one right here, like so. So now you can see with JPA, you don't really need to manually create your database table by specifying your annotations right here, which is what we are doing right here, and specifying your feeds for that class is going to convert everything into a database table, and the feeds will become the columns, as we can see right here. Okay, so this is how JPA work. And by doing this, we also do not need to write our custom SQL to get our task or to save a task. It's going to be done for us by JPA, and we're going to see that in the course. So in the next lecture, we are going to be looking at Spring Security. As I rightly said, Spring Security is the gateway for our application. Whenever any request is coming in, that request is intercepted by the Spring Security. The request is filtered before it gets to the controller and then perform the operation. So let's head on to have our Spring Security setup. So let me close this up right here. Let me close all tabs, and let's head on to have our Spring Security implementation right here in the security. Now, currently we have our users entity right here, and we need to let Spring to know that, hey, use these values such as the password and the email to authenticate a user. So we need to find a way to feed this information right here to the Spring Security so it can work on this information. Remember, the email is going to be what we'll be using to uniquely identify a user. So we need to tell Spring Security that this is the email, use this to generate a session or a token for that user. Okay, so for us to do this, we need to come to our security right here. I'm going to create a first class called, I'm just going to call it custom user details, like so. It's a class, and this is going to implement the user details of Spring Security. You can see the user details I want to implement is coming from the package Spring framework.security.core.userdetails. So this is going to implement the Spring security user details. So I'm going to right click on that, click on implement members. I'm going to implement these first three to get authority, the password, and the username. These other ones right there are optional. So let me just click on these like that. And so after that, I need to, I'm going to create a controller right here. Instead of making this a class, I can make this a record, I can just call this a record just to make things more simplified. And within this record, I'm going to eject the user into it by saying user. That's going to be from our model. Be careful to make sure that this user you're passing in is coming from your model, not your security. So this is from our entity model right here. Yeah, so take note of my imports to see where they are coming from. And I'm just going to call this user, okay? So this, let me just call this user details. Let me rename this correctly. That should be user. I did use it, something like that. That should be user like that. Let me just rename that correctly, okay? You can name it whatever you want. I just want to maintain a correct naming convention, okay? So right here, whenever a user is being logged in, whenever a user is authenticated, what we want to do is we want to collect the email and the password of the user and then feed it into the user details. Remember, this user detail is coming from the Spring security. So when we collect the email and password of our user, which is our custom user we created, and feed it into the user details of Spring security, then Spring security can be able to use those data to authenticate that user and then to do whatever it wants to do with that user, okay? So let us do that. So here for the password, this is going to be user.getPassword. We are basically extracting the password of the user and feeding it into the password so Spring security user details can make use of that. For the username, this is going to be user.getEmail. Remember, our username is, we want our email to be our username. So the username is the unique identifier for a user. So for this our case, we want the email to act as the username in Spring security. So the email is our username right here. So just pass it that. If you are having a different username in your application, you can pass that right here. Now for our authorities, remember we have roles. So this can help us to, protect certain endpoints. There might be some endpoint we want a particular user with such roles to access. So we need to also specify and pass in the roles of the user into Spring security. So you can use that to protect some routes for us. So I'm just going to do this by coming right here and say list.off, and that's going to be new simple, where is it? Simple granted authorities. And that's going to be the user. I'm going to get hold of the user again. I'm going to get access to the role of that user. And then I'm going to get hold of the name. So this is going to pass in the role of that user, which is this right here, into the granted authority. So that's going to help Spring manage that user based on the role of that user. Okay, so this is basically the architectural design for Spring Framework. You might be a little bit confused right now, but don't really be. This is basically how it's done. So just follow along. It's a design pattern, and that's how it is. Okay, so we are going to head on to now create a user detail service where the user will be authenticated and then passed into this class. So that's what we're going to be doing in the next lecture. So let's have our custom user detail service. The service class is what is going to load our username to verify that the user exists before calling this class right here. Okay, so let's do that. I'm going to come right here within the security package, and I'm going to create a new class right here. I'm going to call it custom user details service, like so. And again, this is going to implement again the user details service from again the Spring framework, like that. Okay, Spring security framework. Okay, so right here, I'm going to click on implement the method right here, and there's a method called load user by username. I'm going to implement that method, and this is going to be used to load the username like so. Okay, now before I do that, I need to annotate this with @service right here. So this is a service class, and I will be injecting this elsewhere. So let's annotate it with @service, and then I'm going to first of all bring in my user repository by saying private user repository like so. I don't really have it right now, so I'm going to quickly create it shortly, and that is going to be done by auto wiring it like so. I don't have it currently. I'm going to do this after this in the next lecture. Okay, so now I'm going to come right here and just verify to be sure that user exists with us by saying user, which is our model. Make sure the user is coming from a model and not from any other place by calling this user, and that's going to be our user repository dot. I'm going to be having a method called find by email, and then I'm going to pass in the username. Remember, we already saw here that the email has now acted as a username of Spring Security. So whenever you see username, just pass in your email like that. So that's basically your email, okay? And then I'm going to say or okay? That's not going right here. There's something like or else. You know what, before we do that, let me just quickly come to my, where is it? Let me quickly come to my repository right here and have my task and my user repository, okay? So we can move on smoothly. So I'm going to come here and create my user repository. So right click on this and create a new, that's going to be an interface, and call it user repository like that, okay? And this is going to extend, very important, JPA repository, JPA, that should be J small letter PA repository like that. And this is expected to pass in the entity of the user, which is our user. That should be coming from the user model like so, and then the primary key of that entity, which is a long like that, okay? Now here I'm just going to have a method called find by email, which is going to be an optional of user. I'm going to call it find by email like this, okay? Yep. So we can decide to annotate this with that repository like this. If you do not, because we already extended the JPA repository, and the JPA repository already have the repository annotation, is also going to work. So you can decide to do this or don't do it, okay? So now, by specifying your repository this way, Spring JPA or Hibernate is going to create all the methods you need to be able to perform operation on the user. It's going to help you create the select SQL query, the insert SQL query, the find SQL query. You know what? Let's just go into the JPA right here and let's see what we have there. So if I go into the JPA, which I'm getting, we can see we have save and flush, we have delete, we have get one, get by ID, get reference, find all, you know, and stuff like that. If I decide to go in depth into this CRUD right here, you know, we have save all, find all. If I decide to, you know what, to go into the CRUD repository, I can begin to move until I, you know, get to see the, you know, underhood infrastructure, okay? So these all have been extracted for us already, so we don't really need to manually type in our query. By coming right here and defining your repository and extending the JPA repository, is going to automatically pick, you are going to pass in your entity and the primary key of your data type, and it's going to generate all the methods needed for you to be able to perform operations like finding by ID, saving. You don't need to write select or query by you just call your user repository.save. It's going to just save the data in your database. So we can see these are very easy. You can see also you can decide to write some custom query, like as you can see right here, I have find by email right here. Because I have the email feed right here, I can say find by email, I can do find by password, find by role, find by task, something like that. And when you say find by and you pass in the feed name, it's going to auto generate your SQL query, which is needed to select or find those data in your database. So when I say find by, this is a special keyword right here. JPA is going to generate a select all query. It's going to do select all from database dot your user table where that feed equal to the email you are passing in right here. So I can decide to also come right here and say optional and say return a user for me, which is this model, and then say find by password, something like that. So it's also going to generate a query for me where I can search all the users where the password belong to the password I will pass in right here, which is going to be password like this. Okay, so that's it, like that. That's just going to take in an email like so, and it's going to search the user data where the email corresponds to the value we are passing in right here. Right, so that is it. And optional basically means that if this user is not there, it's going to return an empty stuff. If the user is there, it's then going to return the user. That's what that is. So let's head on to continue right here. And this is going to be, let me import this class right here. Then it's going to be user repository dot find by email. And then I'm going to do dot or stro. If peradventure an email is not found, I want to throw an error, and that's going to be, let me move this to the next line, and that's going to be something say new user not found exception, like this, coming from the Spring Security again. And then I'm just going to say user with, let's say the email, let me just say plus email. The email now is the username plus then not found, something like this, right? Okay, yep. So now we've gotten it. What do I want to do? I need to pass in that user which we've gotten into the user details service record right here. So I'm just going to come right here and say then return new. Then I'm going to call my custom user details and pass in the user right there. Remember, this thing you need to return the user details right here. And this user details is being gotten from right here, right? So this implement the user details. You need to call this, pass in the user. So when you call that method right here, you pass in the user, is going to perform all the operations and return the user details, which will then contain our password and our username. So this will then be returned back to Spring Security, and Spring can then move on to authenticate our user. In the next lecture, we are going to look at the Spring config, where we get to see the entry point for our application and get to configure calls and other beans that are needed. So we head on to have our security config class, which is going to be the main first class that will be intercepted when a request is trying to come into our application. So I'm going to come right here within the security, create a new class, Java class, and call it security config, something like this. You can call it anything, but let's just keep it simple. And here I'm going to annotate this with @configuration. This is coming from the Spring Framework context.annotation. And then I'm going to enable web security right here. And then I'm going to, after this, I need to enable the method security. I'm going to show you guys how to use method security in your controller. So let's annotate it with enable method security like this. So these are the things we need. Annotate this with your security config class, and then I'm going to head on to create a bin of security filter change. So let's first of all say public security where is it? Security filter chain, and then this is going to be called security filter chain, and this is going to take in a HTTP security like this. I'm just going to call it HTTP. Let's just make it simple. And I'm going to head on to start with my implementation. Now, this is going to be a bin, so annotate this with at a bin. So what are bins? So what is a bin? So a bin helps that object to exist globally throughout your application. So when you make this a bin right here, it's going to create an object of this or an instance of this method, and it's going to be created. It's going to exist publicly on your application. So I don't need to create an instance of this every time I want to do it. So anytime a request is coming through our application, we do not need to manually come right here to say to create a new instance of security config, to say new security config, and you begin to do your stuff. We don't need that, because by making this a bin, all the configuration we're going to be having right here is going to be publicly available throughout our application. It's just going to be there globally. Okay, so that's what bin means. Bin is for you to create an object and make that object exist globally throughout the lifetime of your entire application. So that's what bin does, and that's what it's doing right here. So make this a bin. That's the standard for this. So right here, I'm going to say HTTP like this, which is this one coming in right here that we're passing in, and then I'm going to say dot the course. And then here I'm going to call it a course right here like this, and I'm going to do something like this and say course dot configuration source like this. I'm going to make this a request like that, and I'm going to move down right here and say course. I'm going to say I just hope I still remember this thing. I'm going to say course configuration. Let me just be very sure if this should be course again, CORS course. Okay, I think I'm having problem right here. Let me see. Let me move this like this. Let me try to break this down so we can see correctly. Course right here, which I'm going to call it course, is going to be course dot configuration source like this, and then it's going to be expecting a servlet request, which I'm going to be calling request, and I want to do something with that. Okay, so all right, let me come here and then say course configuration like this. That should be imported. Let me call it config, and that's going to be new course configuration. Okay, and then I'm going to say config or course config dot set allow. Let's just start with allow origins pattern like this. And what kind of request do we need? What kind of origin do we want? What URL do we want to access our backend? So what kind of requests do we? What I'm trying to do is what kind of requests or what kind of endpoint do we want to access our application? So that's what I'm trying to do right here. And if you have your front end, you can probably just say, or let's say you have multiple front end right here, you can say list.off, and you can probably just say, let's say HTTP, you want localhost, something like, let's say the port is, let's say your front end is on 3000, and then you have another API, which you've in the production, and that can be HTTPS, and that's going to be, let's say your URL is, let me just say dennis.com, and then you have every other endpoint. So just what are the front end you want to access this application? That's what we are doing right here. So for me, because I'm probably just testing this out, I'm just going to make it all. This means that I allow every person to be able to access your backend. So these are course configuration. It's also an security implementation like that. So I'm just going to move on and say config again dot set allowed origin pattern. That's what I just did before. Okay, let me just say now it's going to be set allow method. So let me say set allow. Let me move down. Set allow. Where is it? Allow methods. So what kind of methods do we want, to be allowed in our application? We want all get, post, put, delete to be request to be accessed. So I'm just going to say list dot off, and then we're going to pass the want a get request to be able to come in. We want a post request to be able to come in. We want a put request to be able to come in. We want a delete request to be able to come in. And want, you can say options also. And if you want a patch request, you can also say patch request. Yeah, something like that, right? So for me, I don't really think I want patch, but if you are having that, you can pass that also to it. So these are the requests that I want to be able to come into my application. Then after that, I'm going to say config again dot set allow headers. Where is it? Set allow headers like that. And that's going to be list dot off all again. And then I'm going to say config dot set allow credentials like that. Again, that's going to be all also of all like that. And then I'm just going to return. Let me just do the last one, config dot set. Where is it? Config dot set allow credentials. This should be true, not all. This should be true. Like that. Yep, that should be true. Okay. Credentials. Do we want to allow credentials? Yes. So that is it. And then I'm going to come right here and say return config like that. Okay. Then we're not done yet. Then I'm going to come right here and say dot c cross resource forgery. I'm just going to say abstract. Where is it? Abstract configurer. Abstract HTTP configurer, then I'm just going to disable it like that. Just disable CSFR, just cross resource forgery stuff. So that is it right there. And again, this is our course config. It's basically telling us what kind of URL should we allow to, hit our controller. What kind of requests do we want to come in? We want from every kind of, where am I? We want every kind of URL to be able to come in. Now this other one is telling us what kind of request we want to, what kind of method we want to allow. We want a get request, a post, a put, and a delete, and options. The other one is, do we allow header? Yes. Credentials, are they allowed? Yes. And then we're returning the config back, and that's going to be passed as a course right there and be registered in the Spring Security right there. So when a request is coming in from, let's say, anywhere, and it's coming right here to the Spring Security, which is the first line of defense, it's going to check to make sure that that request meets this requirement. If it meets this requirement, then it's going to head on to the other things which we are going to be configuring. So we're going to continue with this method right here in the next lecture. So let's head on to configure the path to handle session. So I'm going to come right here and say dot session. Let me just get hold of that. Session management. And I'm going to call this session. And then what I want to do is session dot session creation policy. Session creation policy. And that's going to be session creation policy. You can see right here. Dot, you can make it always, this is going to always create a session whenever a user has been authenticated, or you can say dot if required, like so. Either of them is okay. Then I'm going to move right here and say dot authorize HTTP request. Where is it? Authorized HTTP request. So what we want to do now is we want to determine which of the routes should be protected or which of the routes should not be protected. So here I'm just going to call this auth like this, and I'm going to say auth dot request matches. So if your controller matches slash API slash auth slash login, or this is going to be our login route, or if it matches slash API, where is it? Let me type it correctly. Or it matches slash API slash auth slash register. Then if it matches both of these, then let's say dot permit all. That means what I'm trying to say is that if a user is trying to log in or register, do not authenticate that route. Do not protect that route. Allow those routes to be accessible. So here is where you can register the routes you want anybody to access without having them to be authenticated. Okay, so permit all. And then after that, I will say any other route which were not registered right here, then that should be authenticated, which means that before you can access any other route, you need to, be authenticated. You need to be have a session already with us before you are allowed to access every other route, such as the user's route. Like you want to get your profile information, you want to get all users, you want to create a task, you want to update a task. Those are protected routes. So before you are allowed to create a task or to view your task, you must first have a valid session. You must first be authenticated. So this is where those stuff are handled. This is the one right here. Session management is what is used to create a session when you log in, and this other one above is for you to determine which method are allowed on our endpoint, which URL should be allowed to access us, etc. So let's head on. Moving down, I'm going to come right here. So if you can see, before I do that, if you can see, when I'm writing my code, there are some places where I have to, put in a dot, just try to follow that. If you are finding it difficult, following along, just understand what I'm doing, then the code is already available. You can just go right there, get hold of the code. The most important thing, as I always say, is not to learn how to code, is to know what your code is doing and why we are doing what we are doing. So that's the most important thing in software development, not writing code, is to know what to write and what your code is doing, okay? So now let's move on, and what I'm going to do is to implement error handling. So I'm just going to say .exception handling. So if an exception occurs, what do you want to do? I'm going to call it ES like that, and then I'm going to say EX dot authentication entry point like that, and I'm going to just collect my request. It's going to accept a request, a response, and auto exception. So I'm just going to call it like this: request, response, auto exception. And I'm going to say response dot send error, and the error is going to be 401. And then what else should be passed along? It basically means the user is on unauthorized. Okay, so that is for authentication entry point. If a user is not authorized and is trying to access a protected endpoint, these errors are going to be thrown like so. Okay, now let's configure a logout dot. When you pass a dot, you can see different methods right here. So let's have a logout right there. When we click on logout, what do we want to do? So let me call this logout like that, and I'm going to say logout dot, what should be our logout URL? That's going to be, logout URL should be let me just say /API /auth /logout. So if you hit this URL, that means we want to log out. So what do we want to do? We want to invalidate the HTTP session. Remember, the session has already been created, so we want to invalidate the session first. Then after that, we want to clear authentication, which I'm going to make it true. And after that, I want to delete the cookies like that. And what is going to be the cookie name is going to be called JSection, JSEXX ION ID. So this is the section that is being created right here. This is the session, name right here called JSection ID, like so. Okay. Yep. So that's it. Then after that, I'm going to say log. You can decide to say log out successful handler. I'm just going to be log. Where is the log out successful handler? And it's going to, take in your request, response, and authentication. And then I'm just going to say response dot set status. If it's successful, I'm going to set status right there. Let me move this to the next line so we can see what we are doing. Response dot set status, and that's going to be a 200. So when a log is successful, want to send in, want to make it a 200. So this is going to be the logout route. So when you hit on this route and you're authenticated, it's going to, clear your section and it's going to log you out by removing your section, clearing your cookies and all of that. So this is our, cookie that we are creating. Make sure that the cookie name is right there. Is JXE, then SSION, then ID. Just want to be very, very clear, okay? Then I'm going to add some comments right here so you guys can see when you are going over the code. You're going to say ensure the server. Okay, let me just say this is for logout. This, let me see, this is, so let me keep it simple, handle logout. This is to handle unauthorized access, something like that. I mean, it throws an auth error when you are unauthorized, something like that. This other one right here, it's to protect, to register the routes we want to ignore /protect, something like that. And this other one to manage our session, to, let me call this register, or let me say to create a session. Let me say to create a section for authenticated user, like that. And then this other one right here, the course right here is to determine which URL, or let me say which source should be allowed. So let me call to say which client, let me call this client, which URL or clients should be allowed to access our application, or let me just call this our API, and to determine which API methods are allowed. So just stuff like that, right? Determine, let me just spell that correctly. To determine, yep. I'm still having difficulty spelling this. To determine, yeah. Okay, yeah. So that is it. Then we're not done yet. I'm just going to, at the end of everything, I'm going to return http.build. I need to build it. So return http.build. Remember, this means you have to return a security filter chain, which is going to be globally available. So by building everything and returning it, this is going to always sit right there. So whenever a request is about to come in, it's going to intercept it and go over it. And if it meets the condition, it's going to do what it has to do. Okay. So that's it. To move it down, I need to do another two things. I need to create another bin of authentication manager, which is going to help us to, define authentication. So that's going to be authentication manager, which I'm going to call authentication manager, and that's going to accept authentication configuration. Yep, call that config. Let's call that configuration, and then this is going to return. Let me move this up a bit so we can see clearly what I'm doing. So move this up, and this is going to return configuration.get authentication manager, like that. Okay. Now moving down, let me create another bin of password encoder. Remember, whenever a user is registered, we do not want to save the password as it is. We want to convert the password to a hashed form so we can save it. So come right here, create a bin, public, call it, we're going to be using the bcrypt. Here is a BC arrow. We're going to use the bcrypt password encoder from the Spring Security right there, and call it password encoder, and I'm just going to return new bcrypt encoder like so. So what am I creating a bin of this? Remember, we're going to be using the password encoder in the registration page. So by making a bin of this, is going to happen globally in our application, so we can just go right there and then auto-wire it and make use of it, rather than for us to create a new object every time we want to hash a password. Okay, so that's what these are. So when you create a bin in your application, immediately your application is started, that bin is built and it becomes available globally on your application. So this is the security configuration, and we are done with the security implementation of our application. Now let's head on to write our task repository. Now the way it's done normally, it's when you are done writing your entity, which is your model, you head on to have the DTO, and then you head on to have your repository. So I was faster than myself. I quickly just, was excited about having to write your security. But so let's head on to have the task repository. So in my repository right here, I'm going to right click on that and create a new Java class, call it task repository, like that, and that's an interface right there, and this is going to extend the JPA repository. And what do you want to do right here? You need to pass in the entity of the repository, which is going to be this time around task. Make sure it's from your model right there, and then you need to pass in the ID, the data type of the primary key of that entity, which is long. So how did I get to know this is long? If I go to my task entity right here, you can see long is the data type of the ID. So that is how it's done. Again, you can annotate this with a repository. You can decide not to do that. You don't really need to do this because I'm extending a JPA repository. By default, it's going to be treated as a repository. Okay, so this is always going to be an interface, so you can extend this, interface right here, which also extends other interfaces and other classes. So that is it. So now for us to manage our task, when you do this, by default, it's going to generate method for you where you can add a task, update a task, find a task by ID, get all the tasks. But there are some, we want to be able to get all the tasks that belong to a particular user. When I go to my task right here, you can see a user, it has a relationship to a user, a many to one, which means that multiple tasks can belong to a user. So this means that every task that is being registered or being saved is being attached to a user. So right here, I want to be able to get all my tasks for a particular user. So I'm going to come right here and say, this is going to return a list of tasks because a user can have multiple tasks. I'm going to call this find by. So find by is a special keyword we use in our repository. Then you can say find by. You can say find by ID, find by title, find by description, find by category, find by is completed, or you can say find by user. Okay, so we are interested in this. So let's say find by user. The user should start with a capital letter like that. And then again, you have to pass in the user, like that, which is going to be passed in. Same way, let's also have to find by a user and a category, okay? So we also want to be able to find, a task. We want, in the front end, we want users to be able to search for their task or to find all the tasks that belong to them and then the category, okay? Remember we said we have two categories, the personal and the work category. If you are adding a new task, you are to either add a task to your work category or to your personal category. So we want to be able to also get a task, want you to be able to get your task for a particular category. So I'm going to be doing that by again say find by, and then it's going to be user. If you want to find by multiple feeds, you're going to say and another feed again, category, like that. Very simple. Here you're going to pass in your user and then the category. So the category should be from your enums, like that, called category. Very simple. So this is what you need to do. So with this, JPA is going to generate the code, the query for you to find all your tasks by a user and a category. So that is it for this. We're going to head on with our lesson. So what I should do next is supposed to be for me to have my registration and my login implementation where users will be able to register and log in. But before I do that, let me quickly have my exception classes. So I'm going to teach you guys how to create a global exception handler so that whenever an exception is thrown within your application, a custom response will be returned right there. So let's show you guys how to do that, and I'm just going to use two examples using a non-found exception, bad request, and every other kind of exception. So I'm going to just quickly come up with that, and then I will explain to you guys what is going on. So let me close all tabs right here. So within my exception right here, you can see I already created an exception folder. This is going to contain my exception. I'm going to right click on that and create a new Java class. I'm going to call this not found exception. So let's say, for example, we are trying to find a user and the user is not found. I'm going to get hold of this class and I'm going to throw this right there. This is going to be used to throw an exception. So this is going to extend a runtime exception like that, and I'm going to come right here to, to create my controller. I say my controller to create my constructor, and within here I'm going to pass in the error message, which is going to be, let me call it message, or you can call it error, anything. And this is going to be, I'm going to invoke the controller of the runtime exception by saying super. This is going to invoke the controller of this runtime exception. I'm going to just say passing the message right there. So the same way, I'm going to have what we call a bad request exception. Let me quickly just have that up. Bad request exception, like that. And the same way is going to extend the runtime exception. And right here, I'm going to have my constructor like that and take in a message, and here I'm going to invoke the constructor of the runtime exception by saying super, and I'm going to pass in the message right there to it. So this is just like for us to handle bad exception, and this will be to handle runtime exception. Really nothing really serious going on right here. Now what I'm going to do next is I'm going to create another class called, I can call it anything, and I'm going to show you how that can be used to return custom exception that occurs anywhere in our application. So again, within the exception, I'm going to click on write this, create a new Java class. I'm just going to call this global exception handler. You can call it anything, but it's best to stick with the naming convention so that when you get to see the name, you know what the class is doing. So here I'm going to first of all annotate this with as controller advice. You can see the controller advice right here. So what this means is that if there's any error that occurs in your application, any errors that if there's any request that is coming in through the controller into the application, if an exception occurs anywhere within the controller, the service, or the repository, those will be handled right here. Whatever implementation I'm going to put in right there will be handled right there. And from there, I can decide to return a response back to the controller based on my logic. So that's what that is doing. So if any error occurs, let's say within my repository layer or my service layer or my controller layer, I'm going to be returning a custom response back to the user. Let's say, for example, a user is trying to log in and the user passes, let's say, a bad credential, and within my service class, I'm throwing this bad request exception. So based on my implementation right here, instead of the code to break or the user not to know what's going on, I'm going to define within this controller advice what to be returned back into the controller. So the user is going to be able to get a response and read to see what is going on to know that your credentials are not correct. So something like that. Just a better way for us to handle error management. So I'm going to also quickly annotate this to add my log with SLF4J. You can see this coming from our lombok, like this, lombok.external.this. So this is more like a stylish way for us to log, instead of you to print your error out by using system.out.print or something like that, by using system.out or system.logger, anyone, by saying, let's say, logger dot, I don't know, system.out.println. Instead of doing this stuff right here to print email, let's say you want to print something out, this system.out or system.print, that should be, yeah, system.out.print is used to print stuff out on Java. So instead of us to use that to log error, by using SLF4J, we can easily log using logbok by just saying log dot, let's say it can be info or log.error, and then just passing what I want to log out. Okay, yep. So that's make it easier. So right here, I'm going to first of all have a method to handle any exception that we do not know. So that can be done by saying public. This is going to return a response entity right there, and it's going to be of type API response. Remember, our response class is going to be the API response. This is going to be what we'll be using to return any response. So of type, I can say type anything, which is type T right here, and I'm just going to call this handle unknown exception, like that. And this is going to be any exception that you do not know that occurs within an application should be thrown like that. So instead of TD should be question mark, which is a white card, like that. Okay. So now within this right here, I can log something by saying log.info or log.error, something like that, and I can just say internal, let's say server error, and then I can then just say comma error or exception, like that. Okay, so we can see this. I'm using lombok right here to log, instead of me to do system.out.println, which is a default way to print stuff out in Java. By using this log is more like sweeter, something like that. It's more cool. Okay, now after this, I need to return my API response by saying API response, and again is of white card, which means it can take in anything. I'm going to call this response, or you can call this error response to be descriptive. And this is going to be new API response. I'm going to pass in my HTTP status, which is going to be internal server error.value. That's going to be a 500, and then I'm going to collect my exception. Let me make this a little bit big, which is exception.getMessage, and then for my data, just make it to be null, like that. So then I'm going to return new response, where is it? Response entity, and then I'm going to pass in my error response. Then the status code is going to be HTTP status http status dot eternal server error, like that. Okay, so now, so how are we going to know that this should return any kind of exception? By coming right here and say at exception handler, and the exception it should watch out for should be any exception like that, any exception that is coming in that, you know, is general exceptions should be handled with this. So this is how it's done. So let me show you how to, you know, handle any exception that we are thrown using this bad request right here. So for that, I'm going to come right here and say public again response entity of type API response. This should be accept a wildcard, and this is going to be handled, let's say bad request exception. It can be, you can call it anything, and right here I'm just going to then pass in the bad. Remember, the bad request exception is going to be coming from my exception, not from the Apache right here. This the one I created. So call it exception ex right here, and here I can, you know, build my stuff like this. Let me just copy all of this out right here so we can be a little bit faster. And then this is going to be, for bad requests, is going to be a not found. Should bad request be not found? No. Let's just call it a bad request. Should be bad request. Bad requests dot value. That's going to be a bad request, say 400 error. And then here is going to be a bad request. So I can add log right here, log dot error, and say bad requests. Let me just say bad request exception, and that's going to be the exception dot, let's get the message like that. Okay, so something like this. I can probably just do something like that. Yeah, so the this value right here is going to be placed within this right here. Okay, so that is it. And then for me to be sure that this is going to handle a bad request, I need to annotate this with at exception handler, and that's going to be called bad request exception. Make sure this is coming from our exception, and I'm just going to say dot class like that. Okay, I can just let's say you write this correctly. Does not mean. Lastly, let me also have to handle the not found exception, which is this not found exception right here. So if this is used to catch an exception, I want to trigger a response right here. I can just copy everything right here so we can be fast, paste it. This is going to be called not found exception. Make sure the not found is coming from your exception right here, because there are a lot of not founds right here from different libraries. So that should be coming from the one you defined right here. And again, that should be the not found here, and this should be not found like that. And a not found exception is a 404, and that's going to be called not found like that. Okay, so this is it. So anytime in your application you catch an error, or you throw an error, let's use the word throw. Anytime you throw an error using a bad request, anytime you throw a bad request error, it's going to come right here and return this response to the controller, which is this one. Anytime you throw a not found exception within your application, it's going to return this to the controller. And anytime you throw a generic error, it's going to return this to the controller. So this is how to handle error globally. And you can see in Springboot, things are very, very easy. When you have the right annotations, everything works in sync. So in the next lecture, we're going to look at, you know, the service, and then we'll be able to register and log in a user. So let's head on to have our registration and login service class. So I'm going to close this up right here and just close this up a bit. And within my service right here, I'm going to first of all create an interface. So the last time we had our service class, we got to see how we created our service class directly. But most of the time, it's appropriate to have your service interface and then have the implementation of that interface. So that is just a basic, design pattern. So let me come up with the interface by coming right here and create a new service class and scroll down to the interface section. I'm going to call this auth service, and this is going to contain the method for registering and logging in a user. So each of them is going to return an API response of a wildcard, and I'm going to call this register like that, and it's going to take in our registration and login requests, which I'm just going to call this registration reg request like so. And then let also have to log in. This is going to take in a wildcard as well. It can probably be a user detail or anything you want to return as a login response. So then this is going to be called login, and it's going to as well take in the registration login request, which I'm going to call login request, and then I'm also going to pass in my HTTP servlet like so. HTTP servlet request, which I'm going to call request like this. Okay, so next I'm going to have the implementation of this interface by coming right here, the service. Again, I'm going to create a new folder or package, call it implementation, which is going to implement our interface service, and I'm going to create a new Java class, call it auth service implementation like that. And again, this is going to implement our auth service which we just created. I'm going to hit Option Enter to implement the registration and login methods. So because this is a service class, we need to annotate this with @service like this. This is going to tell Springboot that, hey, this is the service layer, and right here I'm going to be bringing in my AutoWire by saying private user repository called our user repository. Remember, when we want to register a user, we want to be able to save that user to our database table. So I need to bring my user repository. Remember, we said the repository is where we have interaction with the database. I need to bring this down, and to bring this down, I'm just going to say AutoWire. So if you're using Logbok, there are other ways to do this. Instead of me to have AutoWire this, I can just come right here and come at the top here and say require argument constructor coming from Lombok. So when I do this, I need to add a final right here. Make sure you add a final right here, and this is going to also help to AutoWire this. So there are two ways to do this. You can either annotate this with @AutoWire right here, or if you want to use Lombok to AutoWire it, you make this final. You have to bring in this required arg constructor from Lombok. That's going to help to AutoWire these, anything you put in right here. So it's going to help to AutoWire your final classes. So again, I want to bring in my password encoder, which is going to be called bcrypt password encoder, which is the password encoder like that. And then I'm also going to bring in my authentication manager. Where is it? I'm having difficulty typing authentication manager. So you can see, as I'm using require arg constructor, I do not have to AutoWire each of them one after the other. But if I don't want to use this, I need to AutoWire each of these one after the other by saying AutoWire, remove the final, then come to the other one and say AutoWire, remove the final, come to the third one and say AutoWire like this. So if I don't want to use this require arg constructor, then this is how I should go about it, by using the AutoWire. So if you do something like this, it's perfectly okay. But if you want to use the Lombok to AutoWire, you have to get rid of this and then replace each of them with a final like so. So let's do that. Make this a final, and make it a final and make it a final. Okay, so with this we are good to, we're auto wiring this down like so. Okay, yep. So I'm going to head on to have the registration implementation. It's very simple. The first thing I want to do is just to make sure that that user does not already exist, that image does not already exist. So by doing so, I'm just going to say user repository, right, dot find by. You see, if I do find, you can see I have access to different find by from the JPA Hibernate. You can see this method already available for me. So I can just do find by, let's say, email. The find by email is a custom one we created. So I'm just going to pass in the registration request dot get email like so, and I'm going to check if is present. So if an email is already there, so I need to throw an error by saying throw new. Then this time around is going to be a bad request exception, bad request exception. I'm going to say the error message I want to pass in is going to be email already exists, something like this. So when this is thrown, it's going to, remember when I throw this error right here, remember what, just think about what's going to happen. It's going to trigger the bad exception request. You can see the bad exception is coming from my exception, and it's going to trigger the controller advisor, which is this one right here, and it's going to render this bad request response to the controller. It's going to return this response so when a bad request is caught. So this is how it is done. And yep, so this our registration request. We are not done right there. So I'm going to head on to, if everything is okay, let me build my user object to save. That's going to be your user model. Let's be careful where we are importing our user from. Call that user, and that's going to be new user like so. And I'm going to say user dot set email. That's going to be from our registration request dot get email, and then user dot set password. Let me pull this up a bit, and that's going to be, we don't want to pass in the password directly. We want to encode the password so it will not, so somebody cannot just come to my database and get any password, get the raw data. So let's encode it by say password encoder dot encode, and then it's going to be the request dot get password. So this is going to encode the password, and then to save this, I'm just going to, let's also pass in the row before we save it. I'm going to say if the registration request dot get role, right? If the row is equals to dot equals, let me say role dot admin. You can have your different logic right here. Then let me set the user dot set role is going to be admin, role dot admin. Else, if it's not admin role, then user dot set role is going to be role dot user. So make sure the role is coming from your role enum like so, role dot admin like that. Okay, now after we've set the role, let's head on to save this. It's very simple. Just say user repository dot save, and that's all. Then pass in your user object, and this is going to save our user to our database table. You don't need to write a custom save query. By doing this, that is all you need. Then let's head on to return our API response by saying new API response. I'm going to pass in the status code, which is going to be 201, and then the message should be user saved successfully. And then I don't want to pass in, let's say I don't want to pass in. You can decide to pass in the user or convert the saved user to a DTO by coming right here and say user equals to, we'll call it saved user. And then here this is going to be the user, saved user right here. And when the user is saved, it's going to return the user object. I can, return the saved user directly, or I can say, let me convert this to a DTO by, saying user DTO equals to new user DTO. Let me call it saved user DTO equals to new user DTO. Then I can say saved user DTO dot set email. That's going to be saved user dot get email, and then saved user DTO dot set. Let me say set row is going to be saved user dot get row. You can do something like this and then pass in the user DTO as the data. So this is fine. So let's just leave it like this. And in the next lecture, we are going to have the login service method implementation. So let's head on to have the login service method. So right here, I'm going to, first of all, you might be wondering, why am I passing in the HTTP request right down? So this is going to help us. So whenever we log in a user successfully, we are going to authenticate that user. We're going to send the token generated to the global section, which will then be used to authenticate that user. So that's why we're passing in this right here. So to log in is very simple. When the user is logged in successfully, we want to generate a section for that user. So let's just get to see how it's done. And here I'm going to use my I'm going to say authentication like that. That's coming from the spring framework.security.core. I'm going to call that authentication, and that's going to be authentication manager.authenticate like that. And I'm going to pass in, I'm say new user name. Is it new user? I'm expecting this to autocomplete for me. New username, password, authentication token, which is this up one right here. And here I need to pass in the email and the password by extracting it from the request. And that's going to be login request. Where is it? That should be login request dot get email. You get the email, comma, you pass in the password, which is login request dot get the password. So we are extracting the email and the password from the login request, and we are feeding it into the authentication manager. So this is going to be handled by the authentication. So when this is done, what it's going to do is that it's going to come to the custom user details right here. It's going to collect the username right there. Handle, check our database to be sure the username exists. If the username exists, it's going to then pass in the detail, the user, to the custom user detail service, which is right there. It's going to pass in collect the password, feed into the Spring Global Security user detail, feed in the username also right there, which is the email. And when that is done, it's going to be correct. So after this, let's just tell you what to do next. Then after this is done, then I want to say security. So that's basically what this is doing right here. Just wanted to explain what this is doing. Then after this, I'm going to say security context holder. Where is it? Security context holder. I'm just trying to be sure I'm not making mistake with my. It's the longer I wrote this kind of security context holder. Okay. Then I'm going to say dot get context like that, dot set authentication, and then it's going to be this authentication. Now what this is doing right here is going to, this is already the authenticated user. It's going to set this in a global context and expose it to the Spring framework. So Spring will now be aware of this kind of user. I will say, okay, now I'm aware that this user exists. So what I'm going to do next is to create a session cookie for that user by saying HTTP session like that, okay? And I'm going to call the session, and that's going to be the request like so. Remember, this is the request we are passing in. It's going to automatically be passed down from the controller. Then I'm going to say request.getSession, and that's going to be true. That should be within true. And after this, I'm then going to say the session.set attributes, and that's going to be called Spring, capital letter Spring underscore security underscore contest. So contest host. So make sure this is a very unique keyword. Make sure it is spelled correctly. So this is the unique attribute that the Spring Security will recognize. So do this, put in a comma, and then say security contest holder dot get contest, right? Dot get contest, like that. Okay. Now this is going to extract the contest right there, and then it's going to it's going to generate a cookie for that user, which is going to set it as the cookie for that session for that user. So these are to configure a session, and that's going to exist throughout the session of that user. Now I'm going to come right here and say return the response, which is API response, and status code is 200, and the message should be login successfully or login success. And then for my data, I don't really want to pass any data, right? Just want to keep it cool like that. Okay, so this is it, how to log in. Whenever a user is logged in, we are getting the username and password, we are feeding in into the authentication manager. The authentication manager is going to perform the necessary request, the necessary operation to be sure that the user and the email exists and then the password exists. If everything exists, it's going to create a cookie, a security cookie or a token. It's going to create a session token for that user, and that token will be what we'll be using to validate the activity of that user within our application right there. So again, make sure this is spelled correctly. Spring, capital Spring underscore capital security underscore contest. For this is a session attribute. Okay, so when this is done, then you then have access to, you have access to the application. You can do whatever you want based on what the application wants you to do, which is then based on your role. So this is how it is done, and I'm going to see you in the next lecture where we'll have our controller and then we can test this out. So let's head on to have our controller where users can register and log in. Now, before I do that, I'm going to quickly add some comments right here. I know this can be a little bit confusing for beginners, so let me add some comments so when you are going over the code, you can understand what it's doing. So right here, I'm just going to say it calls the custom user details service and custom user details class we created under the hood to validate the user. Okay, that's what this piece of code is doing right here. Then when that is done right here, this is going to save the info to security contest, like that, contest. And this one right here is to create a session for that user. Create a session, and this actually called set cookie session. And let me just say create a cookie session that is the JE session ID for that user. Okay, so when you are making a call, this is going to automatically pass this session down. It's going to automatically pass this session down. You don't really need to do anything when you log in on your front end or in your Postman. Whenever you are logged in, it's going to set this session right there for that user. So when you're coming in back, it's going to automatically pass the session down using the set cookie. So let me just add that again. It is going to auto pass the session down when you are accessing any endpoint via the set cookie. I know it can be difficult for beginners, but no problem. Then this is just to return the response back to the controller, to return the response to the controller. Okay, yep. Okay, so now let's head on to have our auth controller. I'm just going to come to my controller right here. I'm going to right click on that, create a new Java class and call it auth controller, like that. And here we know what to do. You need to annotate this with @rest controller. This is a REST controller, and then you want to pass in your path, which is going to be your request mapping. And we want this to be /API/auth, like so. And then here I need to bring in my dependency by using AutoWire. We have different ways to do that. You can use @require add constructor from Lombok, and then come right here and say private, then final, and then that's going to be your auth service, and then auth service. Or you can say, I don't want to do this, I want to use the AutoWire, like that. And in that case, you have to get rid of the final. So either of them is okay. It depends on your choice. Okay, now let's have our registration part by saying post. That's going to be a post request, and that's going to be a /register. And here I'm going to have my method right there, which is going to return a response entity of API response, and this is going to be of type, it can be anything. And then I'm just going to call this register like this. Now to register, we need to pass in our registration and login request by saying add body, like that, at request body, so to say. And then I'm going to say login request. I'm just call it reg requests, something like that. Then I'm going to have my body right here and say return response entity.ok, and that's going to be the auth service dot, then to register, then you pass in the pass in the registration request, like so. Now you can see when I do this, the registration request is the only thing I'm passing in right there. Okay, good. Okay, now that is it. And let's quickly have for login. I'm just going to copy everything right here. Let me just format it, copy everything right here, paste it down, and the part is going to be called login, and this is going to be called login right here. And this time around, I need to pass in my HTTP servlet request, which I defined right here in my auth service. I say I need to pass in the request down right here. So how can we do that? It's very simple. After you've passed in your first parameter right here, put in a comma, and then just say HTTP servlet request, and just call that request. And right here in the login, a comma, and then pass in your HTTP servlet request. So this is going to, by default, bundle our request and then pass it down in. Okay, right here, I think I'm saying login. That should not be the login. That should be your request right there. Okay, so this can be called, I don't know, let's leave it that way, and we are good to go. Okay, so now if you can see, we are passing in our body right here, but in our body right here, it's telling us that we are making validation right here. So for me to invoke these, validation right here, for me to invoke this and this, there's one last thing we need to do in our controller. I need to come right here before my, before this, it can be after the request body or any of them. I'm going to have one annotation by saying add valid, like that. So add is valid like that, add valid. So when you add the valid, we can see the valid, let me see where it's going. We can see the valid is coming from our validation right here. So by saying add valid, by adding it to this right here, it's going to enforce the validation of these right here. It's going to enforce this validation. It's going to make sure that if you don't pass in an email, it's going to throw a validation error. And if you don't pass in a password, it's going to throw a validation error. So that's how to invoke validation in your controller or in your application. In the next lecture, we are going to test this out and see how it goes. So let's head on to test this out. I'm going to come right here to click on this green button to start my application. And as that is trying to start up, I'm going to pull up my Postman, which we use for testing, like that. So let's pull that up and let's get to see, right? Okay, my Postman is up right here, and let me check my app. We can see my app has started correctly. Let me just wait for it to start fully, and it has started properly. So make sure you are able to connect to your database. Okay, I'm going to clear this up right here by closing all tabs, and I'm going to test this up. Remember, the path for us to test is going to be, let me pull this down a bit. Pull this down a bit. It's going to be slash your localhost, your port, slash API slash auth, and slash register. Before I go down, you can see my port is running on port 8088. So let's take note of that. So I'm going to come right here. You can decide to create a collection to organize your API. So let's do that right here. I'm going to click on create collection right here. Click on that. I'm just going to call this collection name tasks, like that, right? That is okay. Then right here within that, I'm going to click on to add a request, and this is going to be called, this is going to just give it a name called register, like that. And our API is going to be localhost 8088 slash API slash auth slash register. This is going to be our URL, and this is going to be a post request, as that is what we specified right here to be a post request. Okay, now I'm going to pass in my body. Remember, the body for us is we need the email, the password, and the row is optional. So I'm going to come right here, click on the body right here, click on raw, make sure you're on JSON right here, and come right here and then say the name. The name for this, I just, not name, that should be email. So to say, that should be email right here. So let's not make mistake. Then the email is going to be, let me say dennis@gmail.com. And then my password is going to be, let's just keep it simple, @Dennis. So you can decide to save it so you can keep it and reuse it later. So when I click on send, let's get to see. When I click on send, we can see cannot invoke this because the return value of getRow is null. Okay, so because getRow is null, we are getting this error right here that we must pass a role. Okay, so I might probably want to, modify my service so that I won't get that error right here. So that is coming from this. So I can modify the login, the registration right here, and then let me say. So here we are getting an error because this get role, it's the get role right here is null. So I was trying to access a null value. So I'm just going to say if get role. Let me first of all say if. Let me say if requests dot get role is equals to null. Then I'm just going to say user dot set role to be role dot user, something like that, right? So this is just going to help us to go over that thing like that, and then I can probably just have and say as if, and let me just wrap everything with to as if, and then this is an admin, like that. Then do this, and then else just leave it as a user, something like that. So right, so this is more better. We are handling our null error right here. So I'm just going to rerun this and let's see what's going to happen. So if I don't specify a role, it's going to by default set the role to be user. If I specify an admin, it's going to set it to be admin. So let's just get it started again. And that has been started right here. So let me test this again. Again, let's leave it as it is. We are not handling a null error. we've rectified that. So click on send again. And we can see user saved right here. This is the registered user. This is the email and the role. If I go to my database and I say all from users like this and hit run, okay, let's just run it. We can see this is the user that was registered. This is the password. The password has been hashed. And this is the row of a user, and then the ID was, one registered. Okay, so let's add an admin user by saying role. So this should be capital admin, like this. Make it a capital admin so it can be captured as an admin. Then if I try to register this with an existing email, let's see the error. We can see it's giving me the error, say email already exists and the data was not saved. So let me use Mary, which is, and send. We can see user saved and the role is an admin. So if I try to use admin as a small letter, and let me just use a different username. Let's see what will happen. Let's see what will happen. We are testing, so that's basically how test is done. You can see he was not able to convert it to, you can see we need a capital user or an admin, okay? So that's it. So when you're passing your role, make sure that they are all in a capital K so it can be converted to the value of the enum. So this is our registration. Let me check my database again. We can see we have two users right here, the user Dennis and then the user admin, which is Mary. So this is okay. We're going to head on to have the login test. Let's head on to test for the login. Again, you can see when I try to access this method right here, I was able to access them because I already said in my security config, I already said this route should not be authenticated, which means that whenever you are trying to access this route, you should be allowed to access it. Where did I do that? If you can remember your security config right here, we basically say right here that when I try to access this /API auth login or the register link right here, do not permit. But if I'm trying to access another kind of link, you should authenticate. So let's just try that to see. So let me just come right here and let me duplicate this and let me try to access a different link that is not within the auth right there, and let's see what is going to be. Let me just say /API/task. No, this does not exist, but let's just see what's going to happen. If I try to access this, we can see we are getting a 401 unauthorized because we are not permitting that link to be accessed, and because we are not authenticated, we cannot access this route. It's giving us an unauthorized error. Okay, so now let's just head on to login. So for the login, that's going to be API/auth/login, and this is going to be a post request, and let me just call this login here. And then for me to log in, you need to pass in go to your body, make it a raw, your JSON, and pass in your email and password. So let's log in as this admin Mary right here. So click on send. We can see login was successful. So how do I know that I was able to log in? Let me just try to access a kind of different route right here. It's going to, let's just see what happened. Let's just say /task, something like that. And let's just probably just do something like this. It does not exist. Let's just try it out. When I send this, you can see I'm no longer getting the unauthorized. I'm not getting the 500 eternal server error because this route does not exist. So this means that I've already been authenticated, so I can now move on to access other routes. Now, one thing you should take note of is that this is a session cookie. What we are basically doing right here is a session. So if I restart my application, that means that session has been wiped out. So it's not a permanent authentication. So anytime your application is restarted peradventure or you restart your server, that session is gone. A user needs to relog in to be authenticated. So I've restarted my application. If I try to access this route now, you can see I'm not getting a 401 unauthorized. That means that my session has been invalidated. So that's basically, how, the session work. So if we want to have a permanent authentication, then we can then make use of what we call the JSON Web Token in JWT. So in the next project, we're going to be looking at how JWT work and how to have a permanent authentication so that even if you stop and restart your application, that token will still remain valid. So in the meantime, we're going to just stick with this, and I'm going to head on to have the task service. So we're going to see you in the next lecture. So let's head on to have the service and the controller for the task. So I'm going to, stop this up right here, and I'm going to clear all of these right here and just kind of close this up a bit, and then let's continue. So I'm going to come to the service right here. I'm going to have the interface for us to manage a task. So we can create a task, delete a task, update a task, and get all the tasks for a particular category. So I'm just going to right click on that, create a new Java class, call it task service. I think that should be an interface, so to say. And let me come right here and define some methods. This is going to return an API response of, this first one is going to be a task DTO, and this is going to be called create task. This is going to be used to create a task, and it's going to expect to pass in a task DTO right there. And then the user email, the user who is creating, who want to create this task. So I'm just going to call that user email. We're going to extract the email from the authentication. Okay, so that is it. Then let's also have the method to get all the tasks. That's going to be to list task DTO, and that's going to be called get, let's call it get task by user and category. So this is going to be used to get all the tasks of a user. A user can also select a task by each category. Remember, a task can belong to either one of both categories, either a personal category or a work category. So with this method, you can get all the tasks for a user, and you can also get all the tasks for a user for a particular category. So again, this is going to pass in it's going to take in the user email, which I'm just going to call the email, and then the category, which is going to be the category, the user, the task the user want to search from. And then let's also have another method to delete a task, and this is going to take in the task ID. Let's just make it simple. And finally, let's also have a method to, toggle a task to a completed state, something like that. You can use to update a task to be completed, or let's say not completed, stuff like that. So I'm just going to call it toggle task completion like this. Again, this is going to take in the task in question, which is going to be the task ID, and then the user, authenticated user, which is going to be the email. So this is going to be extracted from the authentication. I'm going to show you guys how to do that. We don't really need to manually pass in the user email. Okay, so now let's have the implementation for this, and I'm going to come to the implementation folder, and that's going to be task service implementation. I'm going to come right here and say create a new class, call it task service implementation. Let's keep it short, and this is going to be a service, so annotate this with add service like that. And I can add some logins if I want to log by using SLF4J from Lombok. And if I want to autowire, I can use the require R constructor from Lombok also to autowire. So this is going to implement my task service interface. That's going to be task service interface. I'm going to right click on that to implement all the methods right there. So before I move on, I need to inject my dependencies, which are the task repository, like so, and also the user repository as well final user repository, so we can use to verify a user, just to be sure the user belongs to the user, just to know which task a user belongs to and which user is creating a particular task. So call that user repository like so. Now let's head on to how to create a task. It's going to be very easy. The first thing I have to do is to verify the email of the user by saying user equals to user repository dot find by email, and that's going to be the user email. And then if it's not there, let's throw an error by saying or else throw, and that's going to be a new not found exception. From our exception not found, I'm just going to say user not found, something like this. And then after that, I need to create the task object I want to save by saying task equals to new task, like that. And then I'm going to say task.set. Let me set the value right now. Task.set, let's say set title. That's going to be our task DTO, or you can call it task request. It's okay. We can, let me just call this task request. I don't know. I think that's okay. I can say task request dot get title. Then I can say the task dot set description. That's going to be task request dot get description. Then I can also pass in the category by using a logical statement, and that's going to be set category. So I'm going to say if the task request dot get category is not equals to null, if the user is trying to pass a category, then I'm going to get the category and then set it by that. Else, if it's null, then let's just make the category to be default. So if you are not passing in a category, I'm going to make it set the default to be your personal. Okay. So then I'm just going to say task finally dot set user, which is the user who is creating the task. That's going to be the user we've gotten right there from the authentication. Okay. Next is for me to save the task. I'm just going to call this saved tasks. That's going to be the task repository dot save, and that's going to be the task we've built right here. Okay. And then I can then convert it back to the DTO I want to return. You remember we are returning an API response of task DTO. So I can manually convert this to a task DTO by saying task DTO. We know how to do that, right? So let me not do that. I just want to create a method which can help us to map, task to a task DTO. I'm just going to quickly do that right here. And that's going to be a private method because it's only going to be used within this class right here. So this is going to return a task DTO. I'm just going to call this map to DTO like so. And it's going to take in a task right here, which is a task. And then I'm going to then create the task DTO like this. That's going to be the new task DTO, and then I'm going to say task DTO dot set ID. It's going to be the task dot get ID. Task DTO dot set title. Task dot get title. Let me move this up so we can see properly. Then the task DTO dot set description. That's going to be the description of the task dot get description, and then task DTO dot set category. That's going to be task dot get category, and then finally the completion, which is going to be task DTO dot set completed is going to be a task dot is completed, like that. Okay, and then I'm just going to return the task DTO like so. You can see I'm not saying task DTO dot set user. Is it in my task DTO? I don't want to add the user along, so you can get rid of that. Okay, so now you can see I'm not adding the user along, right? Which is good. So this is it. I'm just going to come right here and say, let me just call this map. Let me rename it properly. Map task to task DTO. Okay, something like this. So let me just come right here and say task DTO. Let me just call this saved task DTO. That's going to be map task to DTO and passing the saved task along like so. And then right here, I'm going to build and return my response. Very simple by saying return API response. That should be new right there. There should be a new return new API response. And then I'm going to pass in the status code, which is 201. Then pass in a message and say task created successfully. And then I can then pass in the save task detail like so. And yeah, so this is it for us to create our task. In the next lecture, I'm going to test this. We're going to have the controller for this, and then we're going to test it out to check if we can create a task. So let's have the task controller right here. I'm going to come to my controller right here at the left. I'm going to create my new controller class. I'm going to call it task controller. It's a class, and I'm going to annotate this with at rest controller because we want it to be a RESTful controller. And then I'm going to say request mapping, and the path is going to be /API/tasks like so. And I want to also auto-wire by using the require arc constructor this time around by saying require arc constructor. And right here, I need to bring in my dependency, which is private final. Remember, when you're using the require arc constructor, your dependency should have a final right there. But if you're not using that, if you're using auto-wire, you don't need to pass in final. I'm just trying to, echo this out. So that's going to be called task service like that. And I'm going to have my method right there, which is a post mapping like so. I can decide to pass in a part. I can decide not to pass in a part. So either of them is fine. Let's just not pass in a part. When you go to this route and it's a post request, by default, it's going to trigger this method right down. So let's have the method up, and that's going to return a response entity of API response of task DTO. I'm going to call that create task, and this is going to take in our request body, which is a task DTO, like that task DTO, and then command. This had to pass in the authentication, automatically passing the authentication by saying authentication right here from Spring Framework Security, and just say authentication like so. And then I'm going to have my body put up right here, and I'm going to say API response, which is of type task DTO, and just call that response, and that's going to be a task service dot create task. I'm going to pass in the task DTO like that, and for me to pass in the email, I'm going to extract it from the authentication by saying authentication dot get name. Remember, the username is our email, so by saying authentication dot get name, is going to extract the username from the authentication, which is from the session, and pass it down. So this authentication is the cookie session that will be auto-injected into this method right here. So that is it right here. And then I need to return something. Return the response entity dot okay, and that's going to be your response right there. All right, so that is it. And I'm just going to run this so we can test this out. So I'm just going to do this in the next lecture. For me to test this out, I'm going to run this right here. As it's running, I'm going to open my Postman, and then I'm just going to create a, let me just call this post task. I don't know, something like that. And that's going to be a post request. It's going to be /API/tasks. And then in my body, I need to click on raw JSON. I need to pass in my task object I want to save. So for me to do that, I probably might not have forgotten. So let me just come to my task detail. And then I need the title, description, and the category like so. And then it's completed. By default, it's completed, it's going to be false. So let's pass in the title, and that's going to be to read, let's just say to study, let's say for PhD. And then the description, let me just say, go over my quantum computing thesis. And then what else do I need to pass in? The category, which is category, this is going to be personal. If I don't specify this by default, it's going to assign that to a personal. Then it's completed by default, it's going to just set it to be false. So before I do that, let me make sure your database is up, and let me just first of all go to task right here. And we can see there are currently no tasks right here. Now, if I try to do this, I'm not expecting this to work because I'm not logged in. So, because when this authentication is trying to verify a logged in user, it's not going to be there, so it's not going to work. So let's just check it, send. I'm expecting a 401 error unauthorized. So that means I need to create a session for myself before I can log in, before I can access this endpoint. So come to the login right here. I'm going to log in as Mary as an admin, so let me log in right here. Immediately I log in, a session is automatically created for Mary. So if I come back right here and I just send, that session that was created is going to eject the authentication into the request. That's how session work, and I can have access to this endpoint. You can see task has been created successfully, and if I go to my database right here, you can see the task was added, completed is false. Description, okay, the description was not be captured. Character, title is there, description is null, category is personal. So let me just check why the description is not captured. Come back right here again. Description, which is description. I'm going to, again, just go to the create task right here. Go to the implementation. I can just log the description by saying log.info and say description is this, basically how to debug, just to be sure why the description is not there. That's going to be task request.get description. Okay, now if I see my my task right here, I'm setting the title, description, the category, and the user like that. So let me just log the description to be sure why it's not coming up. Okay, so I need to restart it again because I just added the log. Okay, so before I do that, let me just verify to make sure that the spelling for my description is correct with what I have right here. Okay, everything is there, and let me come again. Description is the task.set description. Okay, this should be task.set description should be task request dot. So I did task.get instead of task request. So the description should be coming from the task request like this. Okay, I think this was where my error is. Let me just quickly rerun. So because I stopped my server, my application, all my sessions were cleared. So I need to relog in again when I restart. Okay. Yep, so I need to come right here again to relog in like this. Okay, my application is not yet run, so that's why I'm not able to log in. So it has started now. Send. Mary has been logged in. Again, let me just say to workout. Let me just say go work out for your daily routine. Something like this. And this one is also personal. Let's click on send. We can see this has been added. The description is there. If I go to my DB right here, I can see my description right there is there. Go work out for your daily routine. So this is it, and I'm going to head on to have methods so you can get your task, you can delete and then toggle a task. I'm going to stop this right here, and we're going to continue in the next lecture. Let's head on to have our remaining task methods. So I'm going to come to my service right here, task service, implementation of it. I'm going to head on to get the tasks by a user and category. So in this one, we want user to be able to get all their tasks, the tasks that belong to them, and can also search by passing in a category. So I'm going to come right here and first of all, just get user right here. Just get a user from the DB by getting the user email, which is going to be this. And then after that, I'm going to, then if the user is found, I'm going to, have a list of tasks right there, which I'm going to call tasks. And this is going to be used, this should be list of tasks, and this is going to be used to hold all the tasks that I'm getting. So I'm going to have a conditional statement because we want to be able to get all the tasks of a user from both category and a task from a particular category. So I'm going to say if the category is not equals to null, right? That means a user want to search by a category. I'm just going to say all your task equals to the task repository dot find by user and category, pass in the user and then the category right there. And this is going to get all the tags for a user for that particular category. Else, if we are not searching for a category, I just want to get all the tags for that user by saying task repository dot find by user. Where is it? Dot find by user. I'm just going to pass in the user. This is going to get all the tasks of that user for both categories. So after this, I need to find a way to map this to a task DTO by saying list of task DTO, call it task DTOs, and this is going to be task.stream, like so. I'm just going to say .map, and that's going to be this. I'm just going to have a method called map task to task DTO. Adding that is going to collect each of the tasks and map it to DTO and convert everything to a list and then store it right here as list of tasks. So, and then I'm just going to say dot to list to convert everything to a list. So that is it. The next, I'm going to specify my message, API message by saying if category is not equals to null. What's going on right here? If category is not equals to null, my message should be user tasks category is going to be, let's say, plus category, like that. Else, if category is null, I'm just going to say all tasks retrieved for you. Just say for you, or something like that. Let's say for you. Okay, so let me just bring this down so we can see properly, right? So if there's a category, if I'm getting a task of a category, I'm just going to say user task category, like that, as all tasks retrieved, like that for you. All your tasks, let me just say all your tasks. That's more appropriate. Okay, so now let me return my API response, and that's going to be 200, and the message is going to be the message right there, and then that's going to be task details, which is our list of task details like that, and that's going to be returned right here like that. So let's just head on to have the delete implementation, and let me just have everything up. Then I'm just going to head on to have the controller. So let me just have the delete so it will be fast. We already understand what we need to do. So for the delete, I'm just going to come right here and say if not task repository dot exist by ID, which is the ID. So if a task repository does not exist, so I'm going to say, I'm just going to throw new not found exception from our exception right here. Let's be careful. And then I'm just going to say task not found, something like this. Else, if a task is found, I'm going to say task repository dot. When I say dot, you can see we have different things right here. I have delete by ID, which is coming from the JPA repository, JPA hibernate. And I'm just going to say pass the ID to delete it, and then I'm just going to return my response. Let me just give this some space around so we can breathe around, and then return new API response, and that's going to be status code is going to be a 204, which is primarily used for a successful delete operation. And I'm just going to message is going to be task deleted successfully, and then I don't want to pass in any data, just make it a null. Okay, so let me have to toggle a completed status right there. And first of all, just going to copy this to get the current user from the email. So let me move this down and move this down. So first of all, have that right here. This is to get the email of the user, which we're going to be extracting from the authentication. And after that, I'm going to say let's use if not task. Where is the task right here? Okay, I've not gotten the task. Let me do that and think. I was trying to be very fast, so I'm just going to say I'm just going to first of all get the task right there. Say task equals to task repository, then dot find by ID, which is going to be this ID right there. And then I'm going to say or else throw. If it's not there, let me throw this error right here. Let me just copy this error, and that's going to be task not found, like that. Okay, now we've gotten the user, we've gotten the task, and then I'm just going to now move on with my logic and say if not task, right, dot get user, right, dot equals dot get user dot, let me see, get, what am I doing? If I just want to check if the user of this task is the same with this user right here. So I'm going to say if not task dot get user, task has a user right there, then dot, I think get email, yep, dot get email, then dot equals eq dot equals, then the email right here. Instead of let me just say dot equals, let me just say the email that is being extracted, which is email. So I can actually get rid of this user right here because the email is going to authenticate and then pass down. So I wanted to do dot equal user dot get email. I just said nope. Since we already have an email right here, we might not really need this anymore. So get rid of that. So if the user of this task is the same as the authenticated user, then what I want to do is I want to just, if it's not the same, if this user is not the same as the authenticated user, I want to throw bad requests, throw new bad request exception and say you do not have or you are not authorized. Let me say you are not authorized to delete this task. It doesn't belong to you. Something like this. You know, it's kind of a very weird stuff, but it's not really bad. Okay, yep, so that's it. If the authenticated user is not the owner of the task, we just want to say you are not authenticated, you are not to do this else. If you are that should not be unauthorized to, let's say, to update this task, not to delete. You're not authorized to update this task, okay? Then if everything is fine, I'm going to say task dot set completed is going to be the inverse value of the task dot is completed. So if the is completed was true, it's going to make it to be false. If it's not, if it was false before, it's going to make it to be true. So just to toggle it between true and false. Now after that, I'm going to say task right here, which is going to be the updated task. That's going to be, I'm going to resave this by saying task repository dot save, and that's going to be the task. And then I'm going to say the status is going to be, let me say, I don't know if I should do this right now. Let's just updated task dot get status dot is completed, and then if this is completed, I'm just going to say completed s. If it's not true, I'm just going to say this should be s, should be like this. I'm just going to say pending, something like this, or completed, something like this. Then after this, I'm going to return the new API response of status. Let me just move this down. The status is going to be 200, and then the message is, let me say, task marked as, then I'm just going to say as plus the status, which can be completed or pending, and then I'm going to then pass in my updated task right there. Is this the updated task? Nope. I'm expecting an API response of DTO. The updated task is a task. I'm just going to say map to DTO, then the updated task, like that, is going to convert this to a DTO and then return it. Okay. So this is it. This is what we need. Our methods are complete. This is going to be used to toggle a task. This is to delete a task right here. I can also make sure to check that you can only delete your task. We can do the same thing. Just copy everything right here, and I can do the same thing right here. Let me pass in the email again, and then just have stuff like this. Let's just have stuff like this, and then say you are not authorized to delete this task. It doesn't belong to you, okay? We can have something like this, and then I'm going to then need to update my task service to delete a task and then pass in the email like that, and that has solved our problem. So right now, if you want to delete a task, we must be making sure that you are the owner of that task by just making sure that you own the task, and then you may be allowed to delete the task. Okay, so that is it. Before I will do it, let me first of all this should be at the first right here. So let's just make sure that the task exists. If it exists, then if it does not exist, then we throw task not found. If it exists, let's get the task right here. So we've gotten it, make sure that the user is the owner of that task, and then delete the task from our DB. So let's head on to have the controller API methods. So let's head on to have the other controller method for the task. I'm going to come right here, and the one is to get all tasks for a user. That's going to be get mapping like that, and it is going to be a public response entity of API response, and this is going to return a list of task detail like that. I'm going to call this, what should I call it? Let's just call it this name, get tasks by category, stuff like that. And that's going to be this name right here. So let me close this a bit so we can have some breathing space. Let me just get rid of that. Okay, now this is going to be used to get our task. We want to be able to also search, want to be able to pass a category from the params. I'm going to be using the parameter, which is request params like this. I'm going to specify the required to be false, which means that you don't need to pass a category, and that's going to be type category and called category like so, put in a comma, and then I'm going to say authentication like that, called authentication like so. And then right here I'm going to say return API response entity first, response entity.ok. That's going to be task service dot get tasks by user and category. I'm going to pass in the user email, which is going to be extracting from the authentication, which is going to be passed in automatically, and then the category right here. Okay, so by this, if you pass in a category, that's going to be fine. If you do not pass in a category, that is also going to be fine. These are to collect parameters, pass parameters down to an API. So if you don't want that, if you want that to be optional, you can add a require to be forced to it, as we can see right here. Now let's head on to have a method to delete a task, and that's going to be delete mapping. And again, the method is going to be public response entity dot API response. You can probably just say dot string or anything you want it to be, and then call it delete task. So this is I'm going to be collecting the ID from the path variable by saying slash, wrap this within a variable called ID. So when you go to API slash task slash, the value of the ID is going to be collected and extracted. And right here, for me to have access to that, I'm going to say add path variable, and then the data type is a long, and I'm going to collect it by saying the ID, which will be the name of this variable right here. So that is it, and I'm going to come right here to, before I will do that, let me also pass in authentication. So I'm going to also pass in my authentication by say authentication like that. So this is going to be return response entity.ok task service dot, this should be delete a task. And then what do I need to do? Let me check. First of all, pass in my ID and then the email. That's going to be the task ID, and then authentication dot get name as the email. Pass it down. Finally, I need to have to toggle a task. That's going to be, you can use make it a put request or a patch. So let me just make this a put request, put mapping, and the path is going to be slash toggle slash then the ID of the task I want to toggle, and again public. Let me just copy everything right here. It's going to be faster. Copy everything, paste it here, and call this toggle task status, and this is going to be the ID which I'm extracting from the path variable. Authentication is passed in, and for here the method is going to be toggle task completion, and then ID, the task ID, and then the authentication email which I'm passing in. So these are all the methods needed to manage a task, and in the next lecture, I think I'm getting some red stuff right here. Let me see where that is coming from. That's coming from a task controller. Let me just scroll down gradually and gradually. Okay, let me just build so it can show me the error right there. Okay, we can see this is the error right here, response attitude.ok. And okay, let me see. And I think I added too many stuff right there. Okay, I added too many. Let me see, response entity dot okay, task service dot this, and passing the ID authentication, the name. I think this should be 3, like so. And let me see what is going on here. I think, let me see. Let me see, this is puts mapping, and let me get rid of this and check. Okay. Okay, this should be return response entity dot okay. Let me just rewrite this again and say return response entity dot okay, and that's going to be task service dot okay, I think I understand the problem. I should return. Let me look at the return data for this toggle. The return is an API response of task DTO, and I was having API response of string. So just make that a task DTO right here, and our error is gone. Okay, so if I rebuild again from the top and rebuild my project, the error is gone. So that's the advantage of using, a strictly typed language like Java. When you have a syntax error, it's going to be thrown, at compile time. So you don't need to build up whenever you are trying to compile your application. It's going to throw you such error when it's detected in the syntax. So that's one of the advantage of using Java, and that's going to be it for now. Next lecture, we are going to test this out. So I'm going to head on to test the other task methods right here, which is to get all the tasks for a user in a category, to delete a task, and then to toggle a task. So before I do that, I made the mistake in my task service implementation. So write down. So go to your task service implementation, scroll very down, where you are mapping your task to your task DTO. I made a mistake right here. The order here should be task.getTitle because I want to convert the task right here to the task detail. So I made a mistake right here. So this should be task ID. This detail should be task.getTitle, and this other one in the set completed should be task.isCompleted. So make sure you add changes to yours to make sure yours is correctly written. So have you done that? Click on the top right here to run your application, and I'm going to head to my Postman to test that out. So I'm going to quickly add a new endpoint for me to test like so, and I'm going to come right here, and it's going to be /task, and that's going to be a get request to get all the tasks, and you don't need to pass in your body. So if I click send, right, you can see I'm unauthorized because when I restart my application, my existing session was cleared. So I need to log in to be able to access all my tasks. So come right here to be log in as Mary like this, login successful, then come to your task, then get all your tasks. You can see all your tasks. I have my personal tasks, 2 personal tasks, and I also recently added 1 work task, so we can be able to test, by searching by category. Okay, so right here I have 3 tasks, personal, and 1 work task. So let's add to search by category. So come to your parameters right here. Then in the key, you pass in your category, and the value is the category value. So if I search personal and I send, I'm going to get all personal tasks. If I say passing work and I send, I'm going to get work task. If I type in a wrong value, I'm going to be expecting an error like that. Okay, so that is it. If you want to add a work task, if you've forgotten how to do that, come to post a task. Make sure the category is set to work like this. Okay, so this is it to get all tasks for a user. If you do not pass in, if you don't pass in a category, it's going to get all the tasks for that person. So let me try to log in as a different user and let's see the outcome. So I'm going to log in as Dennis like this. And let's see if we can, be able to get it. So I'm currently logged in as Dennis right here. So let me try to get all my tasks for this guy. And we can see there are no tasks for that guy because I don't have a task. So let me quickly, post a task. I'm just going to say, this is my first, let's say, work task. And let me just come right here and say, to arrange my table first day at work, and the type is a work. So send right here, and this task can be registered for the user Dennis, which is currently logged in. If I try to get all the tasks for this guy, we can see right here, this is the only task. If I pass a category of personal, we can see no task for passing now, but if I pass in a work, and we can see that's it. So let me log in at Mary again, and then let's double check, get all the tasks for a user, and we can see this is a work task for Mary. If I remove that, I can get all the tasks for Mary. So that is it, it's working fine. So let's test to what we have to do next is let's test to toggle a task status. So I'm going to come right here, duplicate this, and this is going to be a put request, and the path is going to be /tasks/ let me get to look at it again, /toggle, then the task ID, which is going to be /toggle/ let's just say ID3. Let me be sure ID3 belong to this guy. Okay, this is a work task. Let's try to toggle that. And then let me just call this toggle task completion. So when I send, we can see task has been marked as completed and the completion status is not true. If I try to get all the tasks again for Mary, we can see completion status is not true. If I toggle it again, and then I try to get again, the completion status is now false, which we can see the tag is now marked pending. If I toggle it again, it's now marked to be completed, and the completion status is now seen as true. Okay, so that is it, and it's really moving very fine. So let's test to delete a task. Let me quickly be very fast, and this is going to be a delete mapping, and this is going to be called delete task. So first of all, let me try to delete a task of another guy, which is Dan. So to delete, I'm just going to pass in the task ID, which is going to be a task. So Dan has a task 4, and I want to try to delete that as Mary. Let's get to see the outcome. Send. We can see you are not authorized to delete this task. It does not belong to you, okay? If I try to pass in an ID of a task that does not exist, we can see task not found. So let me just delete task 2, ID 2, and task has been deleted. If I try to get all the tasks right now, we can see task ID 2 is gone. We only have 1 and 3. So all our endpoints are working correctly. And what we're going to do next is to have the service method for users. We want to be able to have an API that can get all the users on our platform. We want to be able to get the profile of a login user. I want to be able also to update the profile. So this will be done in the subsequent lectures. So let's do that. I'm going to stop this up right here and close all my windows or all my tabs. and I'm going to head on to the service right here. And within the service, I'm going to create an interface, call it user service by saying user service like that. And I'm going to have my methods right there. And I'm going to be having, remember, all our methods should return an API response like this. And that's going to be, this first one is to get all the users, and that's going to be a list of user DTO like this. And I'm going to call this get all users like so. And then our other method is going to be used to get the user's profile accounts. That's going to return a user DTO of API response, and this is going to be called get my, let me just say get my profile. And again, I'm going to be passing in the email of the authorized user. And then lastly, I'm going to have to get update a user account, and this is going to be called update, let me just say user profile, and this is going to take in the email of the user, and we can just say let's pass in the user DTO. That's the details we want to update for that user. So let's head on to have the implementation for this. I'm going to go to the implementation part, create a new Java file, call it user service implementation. And we know what to do, annotate this with @service, require our constructor for auto-wiring your dependency, and you can use SLF4J if you want to log in. Then after that, you have to implement your interface, which is user interface. Where is it? User in. What's going on? That should be user service, right? I think I'm feeling sleepy right now. So user service, and hit option implement methods. And right now we've implemented all the methods. So before I proceed, I need to bring in my auto-wire, which is going to be my private final, and that's going to be the user repository right there. So let's kick off to get all the users. So first of all, this is very easy, and this is expecting to return a list of user DTO, where is it? User DTO like this. And then let's just call it user DTOs. And then this is going to be the user repository dot, we have find all. This is going to get all the user. Then I'm going to stream, so I can get each individual value. I'm going to map over that individual value, and then I'm going to have a method called map to DTO. So I'm just going to say this, and then I'm just going to call it map user to user DTO, something like this. And I'm just going to say dot to list. So I don't have this method right now, so let me create it down below. It's going to be a private method, and that's going to be private. It's going to return a user DTO like this. I'm going to call it like so, and it's going to take in the user, which is your user entity from your user model. Call it user, and let me move this down so we can see properly. And here I'm going to, create my user DTO, objects, and then say new user DTO. And here I'm just going to say user DTO dot set ID. That's going to be the user dot get ID. And then user DTO dot set name. Let's just say set email. That's going to be the user dot get email. And then user DTO dot set role. Where is the role? Like that. That's going to be the user dot get role. So this is what we need to do, and then I'm just going to return the user DTO right there. Okay, so by invoking this, we are going to convert the user to a user DTO, and then I'm going to return my API response, and this is going to be 200, the API status, and I'm just going to say users retrieve successfully, and then pass in the user details right there, which is going to be a list of user details. So this is it to get a user. So let's quickly have to get the user's profile. Very easy. First of all, let's say user like that, and then let's use the user repository to find by email by passing in the email like so. And then if it's not there, let's throw an error and say email not found, which is going to be a new not found exception. And then let's say user, can say user not found or something like that. Okay. User USER. Okay. So having passed this stage, we're just going to move down to return our new API response. If a user is found, obviously the data will be saved right here in the user. So let's return that data. And API response is going to be 200, and the message can be profile retrieved, something like that. And the data, I'm just going to use the map users to user DTO and pass in the user. This is going to convert that to a DTO and then help us return an API response of user DTO. So finally, let's have to update a user. First thing for me to do is to verify that this user is our user by, having this right here. I just copied it from here, have it right there. And after that, I need to, if a user is there, I need to update the email of the user from the details coming from the user detail. So I just want to keep it simple. I just want to update the email only. In a larger application, we are mostly going to be updating other feeds based on if that feed is present, right? So here I'm just going to say, we just want to keep it simple. I'm just going to say if user DTO dot get email is not equals to null, which means that if there's an email feed in the user DTO, that means I want to change that user. Then set the user, existing user, set the email to be the new email we want to switch. User DTO dot get email. Although it's not appropriate to just update email directly in a production application. If a user want to update the email, you have to send a unique code to the user. The user have to pass in the code back. This kind of fancy stuff. But this is just a tutorial, so we just want to show how basic stuff can be done. Okay. Now after we've done that, I need to update the user in the database by saying updated user equal to the user repository dot save. By doing save, which is the user, it's going to just update that user already. It's not going to create a new user for us. It already knows this user belongs to her. So it's just going to update the data for that user. So that's how an update works. And then I'm just going to map this to a DTO by saying user DTO. I just say updated user DTO. And that's going to be map user to DTO by passing the updated user. So that's going to convert this to DTO. And now let me return my new API response. It's going to be 200. Then I will say profile updated successfully. And then I'm going to pass in the updated user DTO. So these are our methods for the user. In the next lecture, we are going to have the controller API methods. Let's have our user controller. So move to the controller right here, create a new class, call it user controller. I will know what to do right here. Annotate this with @rest controller, then @request mapping, and the path is going to be /API/users. And then if you want to use require add constructor for AutoWire, you can put that there. For me, I want to use AutoWire differently here. So I'm just going to say @AutoWire. and then I'm going to say private, then user service, like that, then user service. Okay, so just want us to get used to how to auto-wire using this and then the require a constructor. Yep, so let's have our method to get all users. So that's going to be a get mapping, and that's going to be path is going to be /all, and then this is going to be a public. Again, you return a response entity of what? Of API response of type list of users DTO. User DTO. Something like that, and then I'm just going to call this get all users, and right here I'm going to return simply a response entity.ok. That's going to be the user service.get all users. Very simple, and this is going to get all users. So for me, I only want admin to be able to have access to all the users. So for me to do that, I need to implement what we call the method security, which we can, if I go to my security config right here, you can say I did enable method security. So now this is where one would make use of this. So for us to do this, again, if I want to protect this route so it can be accessed by only admin, I'm going to come right here and say at, where is it? I think I remove it, okay. I'm going to come right here and say at pre-authorize, like so. And here I'm going to say has authority. Make sure the spelling is spelled correctly because these are case sensitive, and then use a single quote right there and pass in the row, which is admin. So by doing this, only admin will be able to access this API right here. So this is how to implement method security in Spring Boot. So everything is very easy by using the right annotation. You get whatever you want to do done. So let's head on to how to get a personal profile. That's going to be get mapping, and the path is going to be slash, let's say profile, let's just say /me, and then that's going to be public response entity of API response of type user DTO, and this is going to be called get my profile. And again, I'm just going to pass in my authorization, which is going to auto invoke and get the session, the cookies of the current user, which is going to be authentication like that. And right here, I'm going to say return your response entity.ok, and that's going to be the user service dot get your profile, and I'm going to say authentication dot get name. That's going to extract the email from the cookies and pass it down this method like so. So let's head on down finally to have to update our profile. I want this to be put mapping, and it's going to be called slash, the path is going to be called slash profile. I can say, let's say slash update. You can do a lot of things right there. And this is going to be again public response entity of API response of user DTO like so. I'm going to call this update profile, or let me say update my profile to be specific. And here is going to collect a body by saying at request body, and that's going to be the user DTO like this. Let me just call it user DTO, and again I need to pass in my authentication so it can extract the cookies from the token by saying authentication like that. So there are also other ways for you to do this. If you don't want to pass this authentication directly to access the email, there's another way to do this by saying you can come right here and say add authentication principal, and then say user details, and then user details like that. So there are different ways to do things in Spring Boot, and right here I can just say return response entity.ok, and then user service dot update profile, and I'm going to pass in the email by saying user detail dot get username, which is going to pass in the email down and then the user detail like so. Okay, so you can see with this, it's also the same with this, but this is more, this does not, this is just only get your username, but this you can get, this is going to get all the authentication right there. For this, you only get your user details. So either of them is fine, but because we'll be working with this, let's just stick with this to avoid confusion. So I'm going to stick with this, and this is going to be authentication dot get name like that. So our controller is fine, and I'm going to head on to test these in the next lecture. So I'm going to run this so we can test this out. And as that is trying to come up, I'm going to go to my Postman and then create to test this out. So I'm just going to duplicate this, and I'm just going to call this get all users, which is going to be get all users like that. The path is going to be API/users/all, and I don't need to pass any params, so that's going to be get request. So normally if I try to access this, it's going to tell me to log in because I'm currently logged out. So let me log in as Dennis, which is a normal user, which is not an admin. So let's get to see. So this is Dennis, and before I even get all the users, let's try to test to get the user profile information. Let's test that out first. Let me test this out first. So I'm going to duplicate this again and call this get my account info, and this is going to be /user/me. Is it users? Let me get that again. /user/profile/me. Okay, let me just be very sure. And if I try to send this, we can see this is the profile of Dennis. Is a normal user, as we can see right here. So let me try to access all the users by clicking send. We can see access was denied, right? Access was denied. I'm actually authenticated, so I'm not getting an unauthorized, or I'm not getting an unauthenticated error. I'm actually authenticated, but I do not have the right role to access this endpoint, so hence we get the access denied. So again, let me try to log in as an admin, which is Mary. Send login is okay. For me to be sure, I can just get my profile info again. We can see I'm now logged in as Mary right here. So if I try to access the get all users again, you can see I'm able to get all the users because I'm now authenticated as an admin. So that's how method security works. So these two endpointers work correctly. Let's head on to update profile information. So I'm going to continue with the admin to update her information. I'm going to duplicate that and call this update my account info, and that's going to be a put request, and the path is /profile/update. Let me see, /profile/update and I need to pass in my body right here, which is going to be raw JSON, and I want to change my email only because that was the implementation we had. And my other email was mary@gmail.com. I just want to call this, let me say, sandra@gmail.com. So if I send right now, we can see no static resource for user style. Okay, I didn't spell the update correctly, so let's spell the update correctly. Update, send. You can see profile updated successfully. The email is now Sandra, and then her role remains the same. So if I try to get account information again, we can see user is not found because, we changed your email. So automatically, we're not able to authenticate your old session because we're still keeping that value. So for me to redo that again, I need to log in as Sandra, like this, right? And if I try to get my account of Sandra, we can see Sandra now is there. The email was changed to Sandra. So let me take it back to Mary. I think I prefer Mary, I don't know. Mary has been updated. Let me log in. If I try to log in as Sandra, now we can see bad credentials. So because the email was updated. So change it back to Mary. Yeah, and I try to get account details. Right now we can see Mary is fine. So all our API are working correctly. So these are basically, how Springboot works, how Spring Security works. So with this knowledge, you should be able to build any application you want to build, be it an e-commerce application, be it a banking application, be it a microservice, a heavy data application, gaming apps, heavy apps, you should be able to do that, right? Okay. So that's it. I'm just going to stop this right here, and I'm going to push my code to the repo so you guys can see. I'm just going to clear this up right here and say git status. Let me be sure I'm in the right repository, and let me say git branch. Let's be sure we're in the task manager, and there are some files I don't want to push, so I'm just going to go to my .git ignore and ignore them. First is going to be a ds underscore store. It's a crazy file that auto generates store, and then I want to ignore the IDEA. I think that's all I want to ignore. I want to ignore the target like so. And yep, so let me come right here again and do git status. We can see this dot store is still showing up. Let me add it properly. I think it was not properly spelled. And let me clear this up again. And I don't know if I can zoom this in. Okay, I can't. Let me do git status again. We can see we have, these files right here. So let me do git add dots. It's going to add everything to the staging environment. Git status again. We can see these are all be added to the staging environment. So if I do git, let me clear this so we can see my command git commit -m. I'm just going to say project completed. Let me just call this. Let me say task management project completed. Let's just say version 1. Click enter. Everything has been there. Then git push. Git push set upstream. I need to set that branch right there in my repo, in my remote repo, because the branch currently does not exist. It only exists in my local machine. So let me just do that, and it's going to create this branch in my remote repository, and it's going to push my code right there. So we can see this has been pushed to my remote repository. So that's going to be right here, and I'm going to work in the next sections. We are going to be looking at a more complex project. I'm going to see you guys there. I actually forgot to test the logout, so let's do that. I'm going to rerun my application again, and if I go to the Spring Security right here, let me move to the Spring Security config, the security config class right here, and we can see right here, if you scroll down, you can see this is the path to logout, which is /API/auth. I think this should be logout. I spelled the logout wrongly. You can just correct the spelling at your end to be logout. So whatever you spelled right here should be what you should pass in at your path. So let me rerun this again. Just rerun that again. So when you go to the logout part, what we're basically doing is we are deleting your cookies, right? And we are returning a 200 response. So this can be any request. It can be a GET request. We didn't specify the particular request right here. But if you want to probably, have your custom, logout, you can probably just do that at your auth and have a /logout and do your stuff. But with what we have right here, we are good to go. So let's test this out. I'm going to, my app is running. I'm going to come to my Postman right here, and I'm just going to, let me just create a new link to logout. Let me call this logout like that. And this is going to be /API/auth/logout. So what you have to do is come right here, copy everything you have right here, just to be sure that, this was spelled correctly. Copy that, come right here, and then just paste it right there. So make sure this is the same with what you defined in your security config. So let's test the logout out. For now, if I try to access this route, okay, it's giving me 200. Okay, yeah, it's fine. But if I try to log in right now, let me log in first. Let me log in. Login is successful. Let me try to get all users, which is working right here. Let me try to get my account details, which we can see right here. Okay, now let me test the logout. You can be a get request, can be anything. So let's just make it a get request. Send right here. You can see it's okay. If I try to get my account details again, so you can see I'm not unauthorized because I've been logged out. Okay, so let me log in again. Has been logged in, get my account info. Account info is there. Then let me log out again by using the put request. Let's just try the put request and see sent. 200 okay. Try to get my account details. You can see it's unauthorized. So by defining this, where is it again? That's not there. Okay. So by defining this, you can pass it whatever request method you want. It can be a get, a post, a delete, a patch, anything. As long as the API matches this route right here, it's going to trigger a logout. By logging out means that we are deleting your cookies. And for you to perform, you need to re-log in to continue, doing your stuff. So this is the logout, and that is how it's done. I'm just going to, add this to my Git again. I'm just going to say git commit -m and say, let me just say clean code, I don't know, and then git push, and then this has been pushed to my repository like that. Okay, so that is it. I'm going to see you in the next project. We are gradually on our way to becoming a senior engineer. So by the time you are done with this project, you're going to be a senior engineer and you're going to learn everything that is required of a senior engineer. So we're going to be taking this 10-step upwards. Now let's get to look at what we'll be learning in this session of this course. We are going to be looking at what microservices are. We're going to be learning the event-driven architecture. So what we'll be doing right along has been the request response. So now we're going to be looking at how the event-driven architecture is using the Apache Kafka. We're going to be looking at the Eureka Server and the client. We're going to be looking at the API gateway. We're going to be looking at JWT token. What we used in the last course was, session authentication. So right now we're going to be looking at how to authenticate using the JWT token. We're going to be sending emails out also, and we're going to be at the end, we're going to build a fintech backing application, a microservice-based application where we have the account and the user service, we have the transaction service, we have the notification service, we have the API gateway service, we have the discovery service, and we're going to be putting all of these together. And these are what we're going to be learning and building. So let's quickly get to see what JWT is. JWT means JSON Web Token. It's used to authenticate a user across microservices, unlike the session authentication or the session token, whereby when you stop your application and you restart, your session is lost. So in the JWT, it is sessionless, which means that it does not need a section to authenticate you. So whenever you stop your application and you start it again, as long as your unique token is still there, it can be used to validate you. So because we are going to be having multiple services, by creating a JWT token in one service, it can be used to validate and authenticate you in other services, as long as the unique secret key is shared within all services. So that's what JWT is, and it's most used and is appropriate for microservices because it is stateless. So whatever happens to your server, as long as the JSON is there and is up and running, you can easily be authorized. So in the next lecture, we are going to be looking at what microservices are. We're going to be looking at an overview of what we'll be building and how it will be broken down. See you in the next lecture. Now let's look at the microservice architecture or a microservice. So what is a microservice, or what are these? So a microservice, it's an approach to software development where a large application is broken down into smaller independent services or units. So for example, let's say we have an online banking application where users can log in, users can get to see account details, users can manage their account details, users can make transactions, can send money to other banks. Notification will be sent. User is going to get a mail when a transaction comes in or when a transaction goes out. So let's say we have this kind of application we want to build. So there are two different ways to do that. You can either write everything in one code base where you create one repo, you have all your code packed in one code base, you have one database for them, and you deploy. Or you can decide to break that application down into smaller services where you have your user service, your account service, your transaction service, your notification service, and each of these services is going to have its own database. So that is a microservice design, or that's what we call microservice. A large application broken down into smaller applications where each application functions as an independent unit. So by saying an independent unit, it means that each application is going to have its own code. It can be deployed independently. It's going to be managed independently. It's going to have its own database, very important. So this is what the microservice is all about. So let's take an example. Let's say, for example, I just have a little bit of sketch just to explain what this is. So we're going to be building a fintech app, which is, an online banking app where you can make transactions, okay? So I can decide to either make it a monolithic application whereby I'm going to have one code base, just as we build a task management app in the last project where we have one code base for everything. I can decide to do that and have one database right there with each of them having a table in one database, or I can decide to break these applications down into different services where I'm going to create like 4 different repos, and each of them is going to have its own application by creating each of them using start.spring.io. Each of them is going to have its own database, its own, let's say, authentication, its own code base that's more appropriate with its own database. Then I'm going to just call that a user service, and I'm going to create another application with its own database and code, call it the account service. I'm going to create another one called the transaction service, and then the notification service. And each of them can talk to each other either via API call or via the event-driven architecture, which we are going to be looking at, okay? So this can be a different approach for me to do this. So if I decide to use a microservice approach, that means that I'm going to break them down into different services, and I'm going to have them right there. If I decide to use a monolithic, that means I'm going to write everything in one code base. So these are the difference between a microservices and a monolithic application. Yes, a microservice is a large app broken down into smaller independent units where each unit is treated as an entity. Now, when using the microservice architecture, which means that I can deploy the user service independently, I can deploy the account service independently, I can deploy the transaction service on its own, I can deploy the notification service differently, and then managed differently. So that's what the microservice architecture is all about. So let's just get to see them. You can see we're going to be building an online banking app, and we're going to be having the user service, with its own database, with its own code base. We're going to be having the account service, with its own logic, with its own database, with its own code base. We're going to be having the transaction service differently. we're going to be having the notification service as well. So, by doing this, we have, come to, by doing this, we are going to be making use of the microservice architecture design. Okay, so that is what it is, and I'm going to see you in the next lecture. Now let's get to look at what the event-driven architecture is all about. So take these, before we even do that, let's get to see what the request response, or we call the traditional, architecture is. When we did our last project, we got to see we use the traditional architecture, though we did not necessarily make an API call, but that was traditional. So now the difference is that in the traditional architecture, or what you call a request response, when you are sending an event out, you have to wait for the receiving service to, respond. So let's say, for example, which we are going to be doing right now, we will be building a microservice application, which is an online banking application. We're going to be having the transaction service, the account service, and the notification service. Now, if I want to use a request response for communication between these services, this is how it's going to be. So let's say a transaction has been made successfully. I'm going to be sending an email out using the notification service. So for me to do this with the traditional response, I need to make an API call to the notification service, and I need to wait for the notification service to respond with me that say, hey, I'm up, okay, I've taken a response, I've sent it out, and here is the response. So that is the traditional request response. So in the traditional request response, it's more like a phone call. If I want to talk to, if service A want to talk to service B, I need to say, hey, service B, how are you? I want to do this. You need to respond to me that, okay, I'm available. It has been done. I need to wait for you to give me the response, or for you to tell me the outcome of the request I made. So that is what we call the request response. When service A make a request to service B, service A has to wait for service B to complete the request and return a response before service A can move ahead. So that is the traditional way, and it's not really too cool when you are operating on a microservice architecture, and it can slow your application down. So let's say, for example, I'm building an application that is used in the whole world, and I'm getting like 1 million, requests per second to send email out. Let's say I want to send email out. Users come in every seconds per 1 million users per second, is sending stuff to me, and I need to broadcast or to send them out. By using a request response, it's going to be very slow. I need to make a call to my service B to say, hey, please help me send this out. Service B, I need to wait for service B to finish sending that, message out before I head on to process other message, which is going to be very, but there's going to be a lot of bottleneck. It's going to be very slow. So that's where the event-driven architecture comes in. So with the event-driven, it's called the broadcast. So I just have to send it out, and I'm assured that it's going to go out. I don't need to wait to get a response. So for the event-driven, the service A do not wait for the response from service B. It's just assured that that event is going to be handled, or that request is going to be handled. So that's the difference between the event-driven and the request and the response. So this is going to be our project, and this is an example of how to build that using the request response. I'm going to be having the user service, the account service, the transaction service, the notification service. So from the user service, if a user is registered, I'm going to be sending an email out to the user to say, hey, you've been registered, here's your account number. And for me to do that, I need to call the notification service to send the message out, because here is where notification are being sent out. So with the traditional request response, I need to make a request to the notification service via API call, and I need to wait to get a response to be sure that that message has been sent out. So this is the traditional request response. Alternatively, when a transaction is made in the transaction service, I need to make an API call to the account service to say, hey, transaction has been made. Please update the account number of this guy, reduce the balance or increase the balance. They need to wait for the account service to say, hey, this balance has been treated or this request has been treated. So this is the traditional request and response. Now, if I want to build this using the event-driven architecture, which is what we're going to be doing, we're going to be using the event-driven architecture for this. Here is how our design is going to be like. So when a user registers and an account is created, I'm going to publish the event to the notification service, and I'm not going to wait to receive a response. I'm going to proceed to do other things because I'm rest assured that that message is going to be delivered, is going to be handled appropriately by the notification service. So this is the event-driven architecture. Also, when a transaction is made, I need to send a message out. I need to update the account balance where the transaction was made. So I'm going to send event out to the notification service to send message mail out. I'm going to, send event out to the account service to, handle without me waiting for the response of those events. So when I send an event out from the transaction service to the account service, I'm not going to wait for the response. I'm going to proceed to continue with my business. So that is what the event-driven architecture is all about, and it's very, very optimized, it's scalable, and it's fast. Now, this can be accomplished or can be brought to life by using what we call the Apache Kafka or the RabbitMQ. So these are popular brokers which are used in messaging and send event out, which are used in the event-driven architecture. So Apache Kafka and RabbitMQ. So either of them is okay. I'm just going to be looking at the difference, and we're going to be making use of Apache Kafka. Now, the difference between them are basically very, very simple. Kafka can be scaled horizontally. So Kafka can process millions of messages per second, while RabbitMQ can process 4K to 10K per second based on the node. So for RabbitMQ, you can process 4,000 to 10,000 messages per second. So while for Kafka, you can process millions per second. So when you're building a very, very large application for the whole world, Apache Kafka is very, very, it's vital, and you can, use that to, send for your event-driven architecture for broadcasting message. Let's say you are building Bank of America, or a bank where the whole world uses, Apache Kafka is going to be your go-to for event-driven. So that's one. Another thing is that for Apache Kafka, you can easily rewind old events. So when you send an event out, you can, rewind those events, let's say, a year later or months later. So those events are not gone forever. You can easily roll back to get hold of events that have happened before. But for RabbitMQ, you cannot do that. Once the event is delivered or is gone, you cannot roll back the event. So those are the major differences. And Apache Kafka is the go-to, which is what we're going to be doing. Both of them is fine. So if you are building a very large application, Apache Kafka is recommended. If you are building a very small application, then you can go with RabbitMQ. Now let's get to see the mode of operation of Apache Kafka so we can get to understand what we'll be working on. So in the event-driven architecture, we have what we call the producer and the consumer. So it's very, very easy. The producer is the service that sends the event out. So we call that event, or you can call it the request, anything is called event. So the producer service is, it's where the messages are being sent out or where the event is being published. Let's use the right term. It's where events are published. And the consumer service is what receives the event. And then we have the broker here. This time around, it can be your Kafka or your RabbitMQ. So in our project, which we'll be building shortly, a microservice banking application, we are going to be having the user service, the account service, transaction, and the notification. Now, in the account service, when an account is created, we're going to publish an event to the notification service via the Kafka. So when a user register an account is created, I'm going to send the account number as I'm going to publish the account number to the notification service so it can send an email to that user. So by doing that, the account service is acting as the producer, while the Kafka is the medium where it's going to be sent through Kafka and Kafka is going to relay it to the notification. So what the account service is going to do is just to publish the message to the Kafka, more like you broadcast the message out. Kafka is going to handle everything. So by broadcasting the message out, you have nothing to do, you don't worry about anything. Kafka is going to make sure that that event is delivered. So it's going to send the event to the notification service, and the Kafka is going to watch to make sure that notification service have treated the event properly. So in a situation where the notification service is down, it's going to wait until the notification service is up. So Kafka, a broker, has been optimized to be able to do that. So it has to wait until the service is down, and whenever the notification service is up, all the messages that have piled up is going to broadcast them to the notification service, and then that's going to do the needful. So that is how it's done. Let's just get to see more, different design where we have the producers, which in this case you can call it, where you are sending the message from. The services, which will be where the event are broadcast from. It can be your account service, it can be your transaction service. They are basically called the event producers because they produce event. And the event channel is the Kafka, which relays the event to the event consumer. In this case, it can be your notification service, which is going to receive the event, or it can be any other service which you want to receive the event. For example, when I make a transaction, the transaction service is going to be the producer, is going to notify the account service of a transaction so the account service can update the user account balance. So in that case, the transaction service is going to be the producer, while the account service is going to be the consumer, because the transaction service is sending event to the account service to update the account balance of the user in the account service database. So that's basically how this is how it works. And as we continue to build our project, we're going to understand more on how this works under the hood. Now, in addition to our microservices, we are going to be adding two extra services, which is very important for managing microservices, called the discovery service and the API gateway. Now, the discovery service, it's very simple. Its job is to make sure that all our services are discoverable, and we can easily check to see which service is down or which is running without having to check each service independently. So with the discovery service, we can easily know which service is running, and it's going to make each of the service easily discoverable in the API, in the microservice architecture. So we're going to be looking more into the discovery service, and we're going to be using the Eureka Server. So I'm going to quickly talk on what the Eureka Server is and what it does. Again, we're going to be looking at the API gateway. So the API gateway, the entry point for all services in our microservice. So it's more like a gatekeeper, which helps to, it's just a gatekeeper that it is the entry point to all, your services. Let's say we have something like this. I don't know. This is my, let me move this right here. So this is my, see if I can move it. So let's say this is my microservices right here. And okay. Let's say this is my microservices. Let me just bring this in. Okay. I'm unable to move this. All right. So let's just say this is my microservice right here. And I want to have another service, which is going to be the entry point, something like this right here. It's going to have something like this called the API gateway, which is going to be the entry point for all our applications. So anybody which is trying to access any services within our microservice is going to pass through this gateway. So the API gateway is going to be helpful for authenticating the user, helping for load balancing. Let's say we have millions or billions of requests coming in. instead of these to overwhelm our services right here, the API gateway is going to, manage them the best way it can by load balancing them, distributing them properly. Let's say you are trying to access the transaction service. When you come to the API gateway, it's going to look at you and take you directly to the transaction service. If you want to access the account service, it's going to take you directly. So the API gateway is more like a gatekeeper for our microservices. Okay. Yep. So that's what it is now. Before we talk more on that, let's get to look at what the discovery service is, and we're going to be using an Eureka Server. So what exactly is Eureka Server? So Eureka Server was developed by Netflix. Netflix, it's a movie. I don't know. We know what Netflix is. You can, when you download the Netflix app, you can watch movies, and do some other kind of stuff right there. So Netflix uses a microservice-based architecture. They have multiple services, and they have services for different movie category. Just they have a lot of services. It's microservice design. So they had a problem where they wanted to be able to have a service or dependencies on, you can use that word, so they can get to see which of the services is running, which is not running, which is down. They wanted to be able to check the functionality for all of the services they have from just one single point. So that was how the Eureka server came up. They designed and developed it, and they made it open source. So with that, we can make access of the Eureka server to get to see which of our services is running, which is not running, all of that. So I'm going to be teaching you guys how to make use of these to manage your service, to get to see them, to check for them, and all of that. Okay. So now the Eureka server and client, we're going to be looking at all of these together. Now, in our microservice design, we're going to be having the account service, the transaction service, the notification service, the discovery service, then the API gateway. So all of those services are going to be having the Eureka client, because they're going to be clients. We want them to be discovered in the discovery service. Why the one discovery service right there is going to have the Eureka server. So it's very, very simple, just a very easy thing, and I'm going to show you guys what it is. So let's just get to know that is what the Eureka dependency is. It's just for you to be able to discover your microservices, all the applications you have in your microservice, to be able to see which of them is running and which is not running, and to easily communicate between them. That is the job of the Eureka client and server. So now let's quickly get to see what the Spring Cloud API gateway is. So what is the Spring Cloud API gateway? So the Spring Cloud API gateway is a dependency which helps us to load balance our application. It helps us to ensure all requests are distributed evenly, as we saw earlier, and it acts as a gateway to allow our services in a microservice architecture. So in our project, which we're going to be building shortly, we're going to be having the API gateway standalone service, which, as we rightly said, is going to be right here, the API gateway service. And I can probably just make this a little bit big. Let me say 30. We're going to be having our standalone API service gateway, which is going to be the entry point of our application. So all requests are going to be coming in through right here. Let me see if I can have multiple arrows like that to just be sure to, let's see. So let me duplicate this. I'm going to duplicate this and do stuff like this, like that. Okay. Yeah, so I think this is a little bit better. So all our requests are going to be coming through the API gateway, which is the API gateway service, and we're going to be making use of the dependency called Spring Cloud API Gateway, and that's going to collect all our requests right there, and it's going to relate them to the necessary microservices right there. Let's say this one is coming to the account service right here. Let me see if I can move this inside. Okay, I can't. Okay, yeah. So it's going to collect all the requests coming in. It's going to filter them, authenticate them, and then direct them to the appropriate, service right there that is to be called. So that is the job of the API gateway. Again, it acts as a gatekeeper to our application. It helps us to load balance, controls, act as a traffic controller, and ensures incoming requests are properly distributed to where they ought to be. So that's the function of the Spring Cloud API Gateway dependency, and we're going to be using that in a standalone microservice called the API Gateway. Okay, now in our application, we are going to be having I think 5 microservices. We're going to be having the API Gateway service. We're going to be having the discovery service. We're going to be having the users and account service. We're going to be having the transaction service, and we're going to be having the notification service. So we're going to be building all of these, and by the time we are done with this course, you will be able to build, manage, lead, design architecture, come up with design pattern of your choice for any Java-based project. So see you in the next lecture. Now, before we create our repo and start building, let's get a closer look at the entities we need and how our database table will look like, and let's also get to see how the operations that will be performed in each of the services like that. So let's first of all get to see the tables that will be needed in each service. So for the users account service right here, we're going to be having the role table, which is going to store the rows. We want a user to be able to have multiple roles, such as a user can have an admin role, a user can have a user role. So that is going to be, we're going to be having a database table called role within the user's account service. We're also going to be having the user table right here, and the fields are the email, the password, first and last name, the rows, and then the date it was created. They're also going to be having the account table, and the fields are the account number, the account balance, the currency, which is going to be an enum of can be USD, GPG, NGN, depending on the currency we are using. We also going to have the account type, and it can be a service account or it can be a current account. So we're going to be having the account status, if it is frozen, if it is active, if it is inactive. We're going to be having the user who created the account and then the date it was created. So these are the database tables we'll be having in the user's account service. We're also going to be having the transaction service, and it's going to be having its own unique database. And this is a table right there called the transaction, and the feeds is the reference. For every transaction, we are going to be creating a unique reference for that transaction, which will be stored in the reference column. We'll be having the reference, the account number that the transaction is coming from, and then the account number is going to the bank code which we are transferring from, and then the bank which we are transferring to. The amount in the transaction, the description, the currency, the transaction type, the transaction status, if it is pending, if it is initialized, if it's successful, if it's refunded, we're going to keep track of the status, then the direction of the transaction, if it's a credit or a debit, then the channel, is it through an API, is it a mobile app, is it a web app, and then the date it was created. So these are the feeds within the transaction table in the transaction DB. Then also for the notification database, we're going to be having the notification table, and these are the feeds, the recipient email. If we are sending an email out, we want to store the email we are sending the notification to. If it's a phone number, we are sending. If it's an SMS, we are going to store the recipient phone number right there. The notification type, is it a push notification? Is it an SMS? Is it an email? That's going to be specified right there in an Enum. And then the subject, the message, the status, the reference, the transaction reference, if it's there, and then the date that notification was sent out. So this is going to be the table within the notification database. And this other one is the transaction table within the transaction database. And these are the rows table, the users table, and the accounts table within the users account. They should be called accounts within the users account service. Now let's get an in-depth view of each of the service and the operations that a particular role user will be performing. So let's take an example of the user service. We're going to be having a normal customer user. He or she can register, he can log in, he can get his or her profile information, and he can get a profile with the account information also. Then we're also going to be having an admin user. An admin user has the privilege of getting all the users, getting a user by ID, getting a user by email. An admin can be enable or can activate or deactivate a user. An admin can assign a role to a user. Let's say we have new staff, I want to assign different roles to them. Admin should be able to do that. Admin can also remove a role from a user. An admin can get all the users by role, can get all active users, can get all the statistics of a user. So all of these are going to be a controller endpoint, which these will be consumed by the admin, and these will only can be consumed by a user. Now let's head on to the account service and let's get to see the user operation. A user should be able to create an account number balance, should be able to get his account information, to be able to get his account balance and get the summary for his account. An admin can get an account by account number, can validate an account, can get an account by a user, can get all the accounts in the system, can freeze an account or can unfreeze an account. Now let's head on to the transaction service. It's basically where a user can transfer money to other accounts or other bank, can also get his personal transaction history. An admin should be able to deposit money into a customer's account. Let's say you come to a bank and you want to deposit money to your account. An admin should be able to collect your money and deposit that money or credit your account with that money. So these are the operations by an admin, or you can call this a customer care representative if you want to assign that role. So an admin should be able to filter all the transactions in our system, should be able to get a transaction by reference, should be able to get all the transactions by particular date, etc. So we're just going to keep it this simple. You can add more at your end if you want to. For the notification service, it's going to be sending notification out, such as an SMS, an email, a push notification, etc. Then the discovery service is going to help us keep track of all the services that are running, help us to keep track of the status, to know their IP and to know their state. Then the API gateway, as we all know, is going to be the entry point of our service. Is going to monitor incoming traffic, is going to check all the request ID, is going to redirect every request to the right place, is going to act as a load balancer, all of that. So these are the services we're going to be having, and this is just going to give us an overview of what we'll be building, and we're going to start creating each of the service from the next lecture.